Welcome, Vanakkam, Suswagatam. Everyone, very good morning. Sastrikal, Jo Bole, Sonihal, Sastrikal, Walaikum Salam, Assalamu Alaikum. This is your Baba HSP, Magical Chemistry Group. Before I start, kids, just to let me know if I'm properly audible as well as visible. I want to see green hearts along with fire in the chat section. Namaskaram, Namaskaram, Abhivadanam, Suswagatam, Suprabhatam. Everyone, if you can hear me, you can see me properly audible, I want to see chat section full of fire along with green hearts. Yes. After a long time, Baba is over here. Yo Baba, lovely Baba, and this Baba HSP is welcoming you all, and all those students, also those who are thinking like chemistry pedicare customer, inorganic chemistry pedicare customer. I would like to say it's romba sulbam. The meaning of this line is those who are thinking that chemistry, to understand inorganic chemistry, is just the cramming part, or it's very tough to understand. So I would like to say to each and every one of you, no, my dear friends, it's really awesome and simple, and I will make it totally mathematical. Yes, but let me see the chat section. Just give me a sec. Let me check it out. The chat section. Yes. Everyone, good morning. Very good morning. Everyone, mark your attendance. Everyone, just mark your attendance by smashing the like button. You are supposed to smash the like button, kids. Now, this is your Baba HSP. Let me just give you my intro. I have been teaching for the last 26 years. In 1999, yes, I'm the gold medalist. I did my MSc, then JRF, GATE, then I got distinction in my MTech, the best GPA, and I was the topper once again, 2004. But 99, that was the starting point, and Baba is having 12 master's degree, that is MSc as well as MTech. But this is not the whole, the exact data of HSP, sir. Let me tell you, yes, the Tanishka Yadav, first rank holder, my student, and I would like to say Chaitanya Mittal. If you heard this name, Chaitanya Mittal, 4th rank, AIMS 4th rank, my student. Mehak Arora, AIMS 3rd rank, All India 3rd rank. At that time, AIMS was taking separate examination, my student. Mehak's younger brother, Suez Arora, my student, 715 marks. See, 715 marks that year, 18 students got 715 marks, and once I'm talking about Tanishka Yadav, that year 715 marks only the student got, and got the 1st rank. Anyways, so this is my intro, but I would like to say what I'm going to tell you in coordination chemistry, that is very important. So everyone ready? Let me tell you, I will start today. I will deal with 2 chapters. Total 2 chapters. I will take 2 chapters. Can you understand what are these 2 chapters? 2 chapters of inorganic chemistry I am going to take. One is being coordination chemistry, and second is being D and F block. First coordination chemistry, second D and F block. My dear students, both of these 2 chapters holds a hell lot of weightage. Now in coordination chemistry, what I am going to tell you, let me tell you that thing, what I am going to tell you. If I talk about coordination chemistry, I would like to tell you, my dear students, in this chapter, I will start with the proper sequence. Proper sequence, I will follow proper sequence, that is whatever the order given in NCERT. I will follow NCERT order. NCERT order I will follow. Now, my dear students, what are you thinking, that I will deal only with NCERT? Not at all. What along with NCERT I am going to tell you, my dear students? Let me tell you, NCERT plus Tamil Nadu board, because number of things which are missing in NCERT, they are given in Tamil Nadu board. Remember that. Number of things which are missing in NCERT, they are giving Tamil Nadu board, and along with these two things, whatever is missing, that Baba HSP will let you know. Trans effect. Number of things which are missing in both of these, because this year, yes, paper will be on the tougher side. So, Baba HSP plus HSP's notes, along with number of questions, whatever the questions they have been asked in the previous examination, whether it is JEE, it is NEET, it's AIMS, or whatever the expected questions, I will deal with all those questions. Now, let me tell you what is the major attraction in this chapter. Are you getting what I'm talking about? Let me see the chat section. Are you getting what I'm talking about? If yes, I want to see green hearts in the chat section. See the connectivity in between me and you people. This bond formation should be there. The bond formation is only this chat section, my dear friends. In the chat section, if I'm able to see, because from here I cannot read, I can see only this green hearts. Yes. Now, see, in this coordination chemistry, what is the major portion? Oh my God, once again Baba HSP is here. Okay, now see what is there. Let me take one page. Yeah, this page, let me decorate. Decorated page, decoration, let me decorate it. See, what is this? Your time is very, very important, kids. For me, your time means a lot. So, let me copy it. Tick. Number of pages I have copied. Now, let me come to this page. Now, let me tell you what I was going to tell you. In this chapter, coordination chemistry, I will follow the exact sequence what's given in NCERT, but the color. This color you are always cramming. But I'm saying whatever the colors given over there, no need to cram. Baba HSP will tell you how to find it out, the color of any compound. Whenever it is coming in the sequence, according to the sequence of NCERT, I will tell you how to find out color mathematically. Means I will tell you the technique, the scientific technique, that is scientific technique, that how to find out color, how to find out any color of any organic compound. First thing, you have to stay up to that time. Everyone, just make a promise that you will remain up to that time. You're not going to miss even a single second. You have to sit along with the pen and paper. Just make a promise. You will follow each and every moment. I have taken just 2 chapters. These 2 chapters holds a lot of weightage. I'm making a promise that you will be able to solve all the questions. Whatever the questions of IIT, NEET, I'm definitely what I'm talking about. I'm talking from my brain, from my hearty brain, along with application of hippocampus, my dear students. That's a promise, Baba HSP's promise, that yes, you will be able to solve each and every question within fraction of second. The first thing, that color, I will tell you how to find out color. Yes, you are getting my point. This is the problem of majority of students. Now, second thing what I'm going to tell you. On second number, the thing is spectrochemical series. Most of you are not able to apply the spectrochemical series, and that's why your problem is that hybridization, most of the time you are lacking in the hybridization. This is the biggest area of maximum strengths. Why it is hyperligated, inner orbital complex, outer orbital complex. I will tell you just this thing in one line, how to find out hybridization of any compound. I will make it Romba Sulvam Arpudham. Slowly you will be able to understand each and everything. So this is the second problem of strengths. And the fourth one, what is the fourth problem? Let me tell you, the isomerism. And in isomerism, whether it is optically active, how to find out how many isomers, number of GI and number of optically active isomers. Am I right? This is also the majority of students are feeling problem over here. These problems, I'm making a promise, I will solve all these problems. Yes, if these are real problems, whatever I'm talking about, these are genuine problems, then show me green hearts along with fire. I want to see in the chat section. Let me sit in front of the screen and let me watch it out. Yes. Thank you for appreciating my Tamil. Thank you. Now let me see. Yes, everyone is agreed that whatever Baba is saying, Baba is absolutely true. Yes. Now Sahana, welcome. Sri Lekha, Isha, Sandeep, Sunny, everyone, most welcome. Now let me start. Are you ready? Show me some fire in the chat section. Let me start. So I will start that I'm starting from class 10th standard. That simple salt. What do you mean by simple salt? Simple salt, if I want to say simple salt, that strong base, strong acid reacted, they have formed salt and water. This is simple salt. If you dissolve this salt in water, if you add it to water, it will give test of sodium and chloride. Chloride can be detected. If I apply CID serial, Dr. Tarika and Dr. Salukhe, if they are detecting, oh, this man, Pandu, what he has eaten, then they will get the test of chloride. So this is the simple salt. Now if I talk about double salt is, yes, I would like to say double salt. What is double salt? If I talk about double salt, then see, double salt. So double salt means two salts when they are present in a particular ratio by weight. See, if I add K2SO4 plus Al2SO4 whole thrice, and I cool it along with water, adding water on cooling. If I cool it, they will form molecular compound. Let's see what they are going to form. K2SO4, Al2SO4 whole thrice 24H2O. This we known as alum or potash alum. Now if I add this in water, then what will happen? It will dissociate into potassium, sulfate, aluminium. Now whenever somebody is going to detect, somebody is going to do the test, you know that practical chemistry, then they will show their test. Aluminium with hydroxide gelatinous white ppt, barium chloride, it will give white ppt of barium sulfate. That means the originality of this double salt will get destroyed and the ions will be detected, and we will get, yes, identity of ions. That means identity of ions will be there, but identity of the salt will be lost. That is known as double salt. Let me take another double salt. If I talk about FeSO4, let me take the color. What is the color? Write down everyone if you know the color of Mohr salt. I am writing Mohr salt. Tell me what is the color of Mohr salt. Write down in the chat section. Now if I add it in water, then I will get identity of what? I will get identity of ferrous with K4 Fe6, K3 Fe6, whatever the color they are going to show. I will get identity of ammonium, the Nessler's reagent test they can detect. I will get the identity of sulfate. That means they will lose in water, they will lose the identity of the salt. Identity of salt will be lost and identity of ions will be detected. These are double salts. Now let me check it out, the chat section, what you are writing, kids. Yes, green, very good, green color. Its color is being green. Remember that they will ask you what's the color. Now I'm talking about normal salt. I've gone through double salt, but our chapter is what? Chapter is talking about complex compound. What do you mean by complex compound? So our chapter is talking each and everything about complex compound. So let me talk about complex compound. See, complex compound. Complex compound is that compound which doesn't lose its identity even in water. What is the meaning of this thing? What I'm talking about, what's the meaning of this? That if I say K4 FeCN whole 6, just try to understand. Whatever I'm closing inside the square bracket, this is complex compound. I'm not talking about this one. Just this part, what I'm talking about, if I write down like this, FeCN6, 4 negative, this is complex compound. This is complex compound. If I add this compound in water, if I add water to this compound, that means the test of iron will not be there. That means whenever scientist is trying to identify what ions are present over there, they will not get the test. For example, if they are adding anything, they can't detect ferrous, ferric, cyanide. So can't be detected. Ions can't be detected. This point is clear to all of you? If any point is clear, remember that, show me green hearts, right? If not clear, fire. if clear, green hearts. Two symbols you have to always follow. If clear, green hearts. If not clear, fire. Then I will identify that I have to tell you once again or not. The thing should get repeated again or it's okay. Is that clear? Either fire or green hearts. Green to go ahead, fire, that means I have to tell you once again. Very good, students, very good. Now see, everyone. Now these complex compounds are also of two types. Remember that. Complex compounds are also of two types. Complex compounds are of two types. Type number one, perfect, and type number two, imperfect. Have you ever thought of these two things, perfect and imperfect? I'm going to talk about perfect and imperfect. First I will take perfect and then I will take imperfect. Now see, perfect one. If I take Cu2 plus and I add in cyanide, excess of cyanide, then what I will get? I will get CuCN2. Can you tell me what's the charge on copper? Right? Cu2 plus, because its charge is over here, that is Cu2 plus. Cupric. Now if I add once again the cyanide, if I add cyanide, then the reaction will be like CuCN plus Cn whole twice. Now if I talk about this reaction, my dear friends, this is the question of AIMS as well as IIT. This is the question of AIMS as well as IIT, and you have to tell me, kids, what type of reaction is this? What type of reaction is this? Question arises, what type of reaction it is? First option, let me give you the first option. First option, disproportionation. Second option, intermolecular redox. And third option is intramolecular redox. And fourth option is being none of these. None of these. Let me check it out, your answer. Up to here, this reaction is an example of. Let me sit in front of screen and let me check it out. Everyone, fast. Let me check it out, your knowledge also. How much you are able to understand, kids. Apu Rajendra is going with C. Talha is going for A. Kids, C. Most of the students, they are going with C. And some are going with A. Oh my God, kids. Mixed response is coming. Very bad. C. Kids, the correct answer is intramolecular redox. Third is the correct answer. See why? This is cupric. But see, cyanide is having one negative charge. So over here it is +1. Can you see? +2 to +1. It has undergone what? Reduction. It has undergone reduction. Now cyanide was having -1 and now you can see it's 0. Once again, let me tell you, cyanide is what? Cyanide, you know what is cyanide? Cyanide is what? What do you call it? Pseudohalide. Have you ever heard pseudohalide? What is pseudohalide? Pseudohalide means when one of the entity is nitrogen and that is containing negative charge. So this is pseudohalide and this is pseudohalogen, just like chloride. chloride is changing to Cl2. This is halogen, this is halide, -1 to 0. -1 to 0, loss of electron. Loss of electron, that means oxidation. Oxidation, the one who is undergoing oxidation is known as a reducing agent. Am I right, kids? Reducing agent. So cyanide is losing electron and it is converting into 0, -1 to 0. That will be known as what? You have to say this is undergoing oxidation. Oxidation. Now, my dear friends, this is one compound. This is one compound. One type of atom is undergoing reduction and another type of atom is undergoing oxidation. These two atoms are different. Different atoms of the same compound. When different atoms of the same compound, that means intramolecular redox. Disproportionation, you would have said that disproportion is when the same atom is undergoing oxidation and same atom is undergoing reduction, then only you can say disproportionation. But one type of atom and another type of atom, they are different but from the same entity. So intramolecular redox is the correct answer. You got it? If you got it, green hearts. If you haven't got it, fire. Let me check it out fast, speedily. I want to see the chat should be running fast. I will tell you, I am responsible for telling you each and every question. Whatever the question can be asked, I will move like this in the sequence. Everyone, fast, be fast, be fast, 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 kids. Very good, very good. Now let me come to the same reaction once again. I have started with, there was cupric and I was telling you perfect one, perfect one, perfect one, Cu2 plus combined with cyana, CuCN whole twice, then with cyanide, CuCN plus Cn whole twice. Now excess of KCN, casino in excess, then it will get changed into K3CuCN whole 4. Now you can see K3CuCN whole 4, but remember that it must be given in excess. This excess word is very, very important. Then you will get K3CuCN4. Now, when you add water to this, this reaction will go very less in the forward direction and maximum it will remain in the backward direction. First, let me tell you, when you add inside the water, this will break up. This will give 3 types of K plus. This is not the part of complex. This, whatever is inside the square bracket, that is the part of complex. And it right now I can say what? Let me remove this because it will break fully. It will break fully to give this much and this much part. CuCN whole 4, 3 negative. But now this complex, this is the complex, that is counter ion, leave that. This will move very less in the forward direction and will remain maximum in the backward direction. So what I am going to say, it is feebly ionized. Feebly, can you understand the word feebly ionized? I am not saying that it will not ionized at all. It is feebly ionized, means it will give very, very small portion of very, very small amount of cuprous and cyanide. That much small amount, kids, that they can't be detected. In traces, you will get in traces and can't be, that's why can't be detected. That's why can't be detected. Can't be detected. I'm saying feebly ionized. Feebly ionized means it is very, very less ionized, means maximum portion will remain in this form and very, very less amount you will get in this compound. That's why it is perfect. That means it can't be detected. He is right, wrong. He is inside the water. And Dr. Saluke, you know, CID serial and Tarika, they are trying to detect somebody like Champa has eaten this complex and Champa has died. Whew. Champa is no more in this world. Now Dr. Saluke, CID serial, you know, Pradhamanesi per Pradhaman, kuch to gadbad hai. So they are trying to identify what type of chemical Champa has eaten, and that's why Champa is no more. Dr. Saluke and Tarike, they are continuously trying, but they are saying, sir, we are unable to find out what type of element, what type of cation, what type of anions he has consumed. We are unable to find out. Are you getting my point? If it is clear, I want to see green hearts. If not clear, fire. Let me see, kids. Let me see. Everyone, fast. Fast, kids, fast. I have started from the beginning only. I have started from the beginning only, kids. I have started from the very beginning. Zero level I have started. Now see. Imperfect. Imperfect complex. What is imperfect complex? Suppose if I say there is Cu2 plus, in place of Cu2 plus, let me take cadmium 2 plus. Cadmium 2 plus combined with cyanide cadmium cyanide 2. Now excess of KCN in excess. Now you got K4 CD CN6. Now if you add inside the water, it will break into 4 times K plus complex CD Cn whole 6 4 negative. Now this is more ionized to give cadmium 2 plus and cyanide 6 times cyanide. Now they can be detected. They will get that test. That means they can be detected. Now my dear friends, they can be detected. They can be detected. Dr. Saluke and Champa and Dr. Saluke and Tarika, they will say, yeah, cadmium test, we are getting test of cadmium and cyanide. Now, my dear friend, there is very big question. If the identity of ions can be traced inside the water, identity of identity can be traced in water, then one very big question arises. What's that question, kids? What's that question? So the same thing was given by double salt also, simple salts also, and these are complex compounds. And in the starting you were talking about that complex compound will not show the identity of ions. Now you're talking like this. This is very big question or not? First of all, tell me. In the starting I said that normal salts will lose their identity and they will start showing the identity of ions inside the water. But the complex compounds are known for not showing the identity of ions inside the water. Then this is the complex compound. You have written complex compound and I know that this is complex compound, but this is also showing the identity of ions. Then what's the difference? This is big question or not? Agreed or not? If yes, show me green hearts. If this is really a big question, then I want to see in the chat section green hearts. Kids, fast. Now let me tell you What's the answer? Because I have told you this time they will ask very, very good questions, not so easy questions. And I think no one is going to start the coordination chemistry in this way. Whatever I'm saying, people will start coordination chemistry from Werner's coordination theory. They will start from IUPAC because that is easy to understand, but that is not going to give selection or rank. I have started from the very beginning, from the zero level. Now see, kids, what's the difference between double salt and complex compound? Now see, let me tell you, if I take more salt, that is double salt, FeSO4, NH4 whole twice SO4, 6 times H2O. If I keep it in water, it will always show the identity of ferrous, will show the identity of ammonium, will show the identity of sulfate. Always, always they can be detected. Always these radicals will be detected, But if I talk about this complex compound K4, and better to write down this square bracket CdCN whole 4 or CdCN whole 6, 4 negative. Now this is a special compound. This is imperfect complex. Imperfect complex. Now, before telling you about this, I would like to tell you one thing, that if you know ionic equilibrium, you must have studied ionic equilibrium, and from ionic equilibrium you know one thing. What's that? One is being unsaturated solution. Unsaturated solution, what's that? If ionic product is less than KSP, am I right? And saturated solution, if I talk about saturated solution, then IP is equal to KSP. And if I talk about super saturated solution, that means IP is greater than KSP. In this case, salt will get precipitated, and in this salt will not get precipitated, Am I right or wrong? First of all, tell me this thing from the ionic equilibrium, that is being the part of physical chemistry. This is clear or not? Whatever I have written, am I right or wrong? If yes, if you are able to understand, once again the green hearts in the chat section, and if anything is going wrong, then you can tell me, sir, we don't know. If you know this point, then green hearts. If you don't know, then fire. But fast. I want to see the chat running very fast. Now, if I talk about this, then here the Le-Chatelier principle, let me say that if I am having CdCN whole 6, 4 negative, and the equilibrium is lying like this, Cd2 plus 6 times Cn negative. Now kids, if I increase the concentration of Cn, that means if I increase KCN, if I increase its concentration, then the equilibrium will go in the backward direction according to Le-Chatelier's principle. Am I right? That means if it is remaining in this form, then will not show what? Will not show identity of ions. And if it is remaining in this form, then it will show identity of ions, will show identity of ions. That means imperfect complex identity depends on the type of reagent and the concentration. They can show, they cannot show. This is, I'm talking about imperfect complex. So what's the difference? What's the difference, kids? These will always show, always these radical will be detected, but their detection depends on what? Depends on the type of reagent, because you know that if the salt is getting changed in ionic equilibrium, if the type of salt is getting changed, their KSP value will get changed. If I talk about CuS, belongs to second group radical, analytical chemistry, salt analysis, copper sulfide KSP is less, 1 into 10 to the power minus 88. But on the other hand, if I talk about fourth group radical, ZNS, dirty white PPT, its KSP is more, 1 into 10 to the power minus 6 or 8. That means if the type of salt is getting changed, their KSP value is also getting changed and their detection will also get changed. So detection depends on the type of reagent and concentration, these 2 points, assertion and reasoning. Now after this I am going to start from where mostly 99% teachers starts. Werner's coordination theory. I will start with the Werner's coordination theory and let me show you in the NCERT also. But up to now, if anything is clear, let me see the chat section. Green hearts or what? Okay, kids, show me till now if it is clear, kids. Write down in the chat section whatever you want from my side. Now I am going to start from Werner's coordination theory and let me show you in the NCERT also. NCERT also I will show you. I will move according to NCERT. I will follow the sequence of NCERT only. Now see, kids, is it visible to all of you? I will start from here. Werner's theory of coordination. Okay, Werner's theory of coordination. I am going to start from here. Ready? Oh, it's not visible, I think. It's not visible because I think now see, I think now it should be clear. Now just see. Now it must be clear, kids. Werner's coordination theory, Alfred Werner. I am going to start from here, right? So just welcome me that Baba is going to tell you from Werner's coordination theory. Let's it go, kids. Let's it go. I will strictly follow this what to say. The sequence only, right? The sequence only. Now see. Werner's coordination theory. And whatever the questions they can ask, I will tell you each and everything. Okay, Werner's coordination theory, father of coordination chemistry. He is known as father of coordination chemistry. Father of coordination chemistry. Now, what he said, let me tell you. Let me tell you what he said. First point, he said First point, what he said, let me tell you. He has taken very, very interesting example. The best example. Write down in the chat section if you remember the best example, which will always be asked in your examination. Best example he has taken. He has taken the best example. COCl3, 6 moles of ammonia. He has done research with this example. This is the most famous example. This is the most famous example. So in your examination, you will get questions from this example only. Werner's coordination theory. Now see kids, just see to it. See, everyone just see. If I write down before starting Werner's coordination theory, let me tell you Baba HSP's and you people's theory. Okay, I'm not going to tell you Werner's coordination theory first. Let me tell you my theory and yours theory. Okay, let's see. That compound is, this is the compound, right? Now see, I will say here is central metal atom. This is what? This is central metal atom. Central metal atom. Atom or ion. Metal atom or ion. It's like king. Just suppose it's like king. It's like king. Okay? It's like king. Right now I'm not telling you Werner's coordination theory. I'm telling you my and your theory. This is king. Now king can have many queens. King. I'm talking about king. I'm not talking about ordinary person. Ordinary person, 1 for 1. Okay? This I'm talking about king. Kings were having many queens, fixed queens. So its queen is all NH3 whole 6. NH3 whole 6. How many queens? This king is having how many queens? 6 queens. 6 queens. And here in this complex compound, these are known as ligands. What? Ligands. If you talk about organic chemistry, these ligands are known as nucleophiles. Nucleophiles. If I talk about organic chemistry, these are known as nucleophiles. That is lone pair donor. Lone pair donor. And this is electrophile. If I talk about with respect to electrochemistry, I will say it is central metal atom is electrophile, lone pair acceptor. If I talk about inorganic chemistry, then I would like to say it is Lewis base, and this is Lewis acid. Lewis acid. And this coordination, this square bracket is known as, I will say, this is the wall of the Qila, the fort where these king and queen are living. No one can get entry and they cannot go outside this wall. Wall of China, or what should I say, the wall of fort. Wall of fort. This is the fort. Whenever they are inside this fort, they are safe. The king, the queen. The king, the queen. Lone pair acceptor, lone pair donor. This much point is clear. I haven't started Werner's coordination theory. I'm telling you this is Baba HSP's theory. First, let's find out what is the complex compound. Yes? If it is clear, till now if it is clear, I want to see green hearts. Let me sit in front of this computer screen. Kids, don't talk. Just talk about syllabus. Just talk whatever Baba is teaching you, kids. I want to see your bonding. Whenever they are inside this wall, they are safe. This is the wall. Everyone, fast. I want to see your response. Quick response, kids. Fast, kids, fast. Everyone. Fast, kids, fast. Very good. Now see, where the chlorides, 3 chlorides, if you see the complex compounds formula, the formula was like this. CO, Cl3, 6 ammonia. Now just see. This is coordination sphere. This is coordination sphere. This is known as coordination sphere. Coordination sphere. This is the wall. Here is cobalt, the central metal atom. The 6 queens known as ammonia 6. Now, this is the king, this is the queen, and 3 chlorides are over here. 3 chlorides are outside the fort. This is the fort. Everyone is safe over here. They are outside the fort, right? They are outside the fort. Now, the king is having 6 queens. They are inside the house. This is the wall of the house, and they are king's girlfriends. These are king's girlfriends. Okay, they have freedom to move anywhere. They have got freedom. They haven't got freedom. The one who is inside the house, they haven't got freedom. No freedom. These queens are having no freedom to move out. No freedom to go for shopping with anyone. To go for shopping. To go outside this fort. But these are girlfriends. They have got freedom. They have full freedom to move anywhere. This point is clear. They are having freedom. They can ionize. They can move anywhere. So I would like to say these are ionizable valencies. Ionizable valencies. And they will always be negatively charged. Always negatively charged. And these can be neutral or negatively charged. Whatever is present over here can be neutral or negatively charged, but non-ionizable. Till now I haven't started Werner's coordination theory. This is Baba HSP's theory. King will be having queens and what to say, girlfriends. Till now, if everything is clear, I want to see green hearts. Till now, I haven't started Werner's coordination theory, kids. Kids, just do let me know. Baba HSP's theory is clear. If yes, I want to see green hearts. Till now, I haven't started Werner's coordination theory, kids. If you are able to understand what I am telling you, kids, And if you're liking the way I'm going to correlate, see kids, if I'm going to correlate the things, I will be the most happiest person. Now I will tell you that it's not the theory of Werner, it will be theory which you can easily understand, Now see kids, now this is the compound, queens and the girlfriends. Okay, now see, if I talk about that this compound CO ammonia whole 6 Cl3, if you add water or if you add AgNO3, before I start this, or simply add water, first add water. Now there is rain, flood is there, too much flood is there. Now what will happen? Who will get destroyed? Who will go along with water? Who will get away from this? Now during flood, the complex you can see like this. King will be there, all queens will be there, but very sad, what to say, very sad, all 3 chlorides will get away. They will be no more, because the one who was there inside the wall of the fort, inside the house, in-house, they will remain intact over there, but they will be the part of water. That means these are ionizable. So total how many ions you got inside the water? If the question is there, they are going to ask question, total how many ions? A option 1, B option 2, C option 3, D option 4. Total how many ions? Let me see the chat section. This is the question, most important question of your examination. Hey, everyone, just to let me know. Fast, everyone fast. So most of the students are wrong. They are saying 3. 3 is wrong answer. The correct answer is 4. See why? 3 ions of chloride, and this is also ion. So 1 plus 3. So the answer is 1 plus 3. How much kids? 1 plus 3, total 4 ions. Why 4 ions? 1, this whole will be considered as 1 ion and these as 3 ions. Are you getting my point? First, you got it? Now, another question, the second question. As we know that, this you must have studied silver nitrate test. That AgNO3 plus NaCl, what you will get? Decomposition reaction. This NaNO3 will form salt of strong acid, strong base, and AgCl. You will get white PPT of AgCl, white precipitate, white PPT, right kids? White PPT you will get, okay? Now, by keeping this thing in your brain, let me give you one question. If I talk about CO NH3 whole 6 Cl3. Now how many queens this is having? Cobalts, how many queens? These are known as secondary valencies. These are known as primary valencies. For a king, girlfriend is primary valencies. So in short, I will write PV, primary valency, SB, secondary valency. Secondary valency is the queen. The number of queens, 6. These queens, whatever the queens are there, they will give coordination number. They will be responsible for coordination number. Secondary valencies are responsible for coordination number. So that number is 6, fixed. For cobalt it is fixed, that 6. Okay, now this part is there. If I add AgNO3, excess of AgNO3 in this, AgNO3 in excess, then question is how many moles of AgCl and what color we will get. So options, let me give you the options. First, 4 white. Second option, 3 white. Third option, 1 yellow. Fourth option, 3 yellow. What's your answer? Just do let me know. What's your answer? I want to see in the chat section. Everyone, fast. Everyone, kids, fast. Kavishri is going for 4. Kids, fast. I want to see your answer. Most of the people, kids. Yeah, the correct answer, see, and that's why I'm telling you, you have to see the correct answer is 3 white. See, whenever this compound is going to combine with AgNO3, you will get 3 moles of AgCl, because these 3 chlorides, they are ionizable. They will react with 3 moles of AgNO3 to give white PPT. AgCl is white colored. Remember that AgCl is white precipitate. AgBr is light yellow. AgI is dark yellow. So you will get 3 moles. Now another question, just see, is it clear? Because 3 chlorides are ionizable. With AgNO3 you will get 3 AgCl, white precipitate. If this is clear, kids, show me green hearts in the chat section if this point is clear. I will show you number of questions. Kids, your accuracy means a lot to me. Your selection, I will give you the best rank, kids. Our team will give you the best rank, but I want to see your answer in the chat section. Now see, another question. Let's see another question, kids. Question is, if A is given CO, ammonia whole 5, Cl2, AgNO3 excess. Now tell me how many moles of white PPT. Question is, how many moles of white PPT AgCl will be obtained? Now this time, kids, I will come to a house and I will start beating you if your answer is not found to be correct. A1, B2, C3, D4. This time you have to give the correct answer, kids. Otherwise I will come to a house, home, whatever you say, and I will start beating you. Yeah, definitely I mean this. I will start beating you. Very good. You got it. You got it, kids. My lovely kids. Lovely kids. Loving you, kids. There are only two ionizable valencies. These are ionizable. These are ionizable. Only two are ionizable and these are non-ionizable. Oh my God. Kids, should I tell you my way? If you give me the permission, then Baba will tell you Baba's way. Should I? See, this king has thrown away one wife, queen. One girlfriend has changed into queen. Now these are different. Whenever the king is having different types of queens, they will be known as heteroleptic. Heteroleptic. Earlier, heteroleptic ligands. That means different types of ligands. Different types. Earlier, this king was having, just see, this king was having all 6 queens homoleptic. All they were same. Homoleptic. Now see the difference. From this, one girlfriend has taken the position of queen. Just see. One girlfriend has taken the role of queen. Now chloride is in double role. I will tell you Werner's coordination theory once I am going to tell you. But before that, let me give you another question. If you are able to understand, then see another question. Another question. CO, ammonia 3, Cl3. 3 negative. Axis of AgNO3. AgNO3 axis. Now, question is, what type of color we will get? A option yellow, B option dark yellow, C option white, D option nota. Nota means none of the above. Nota, none of the above. Now, this time I will check your brain, kids. Now, give me the answer. I'm sitting in front of screen, kids. Kids, everyone, Baba wanna see your answer. Baba wanna see your answer. Oh my God. Sahana, Dar, Arfat, Vidya, everyone, kids. Wow, you are now my student. Now I can say you are Baba HSP student. You are rocking. Why, kids? Even though there are 3 chlorides, but why there is no color? Can you tell me, kids? Let me come in front of you. Let's have a talk, kids. If you would have been the part of offline, right now Baba is taking this class from Jaipur, academic head of IIT at Jaipur. Yeah, Baba is taking NEET as well as IIT both. Now, my dear students, if I would have been present in front of you, then wow, I can see the smile on your faces. Whatever Baba is saying, do you believe, kids? Just to let me know, do you believe that without telling you even a single point of Werner's coordination theory, you are able to do questions or not? I haven't gone through even a single point of Werner's coordination theory, but then also you are able to do all the questions or not? Just to let me know. Am I right? If yes, then show me green hearts. If no, then fire. Let me see. If yes, if you believe what Baba is saying, then green hearts. If you don't believe, then fire. Yes, no girlfriend is there. Wow. Thank you kids, thank you, lovely, 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 lovely. Now let me move to electrochemistry. Let me frame out question with electrochemistry. See, Baba is going to give you question from electrochemistry. Just see, rank deciding question of electrochemistry. See, electrochemistry question. Question from electrochemistry. Question is, which will have maximum conductance? A, 1 molar CO ammonia whole 6 Cl3, B, 1 molar, or this is also molar, CO ammonia whole 5 Cl, Cl2, 1 molar CO ammonia whole 4 Cl2 Cl, D, 1 molar CO ammonia whole 3 Cl3. So what's the answer? This is a question from electrochemistry. They can frame out question from anywhere. Yes, let me check it out. Wow, Tanmay, Shri, Sahana, Darshana. Wow, everyone, you are kids. You are Baba HSP's kids. Rocking, kids rocking. If you are really rocking. Now, if I want to arrange then A, then B, then C, then this D will be the answer. Am I right, kids? If you agreed, then do let me know. If you're really getting it, I want to see a smile on your face that without taking name of Werners, we are able to do all the questions. We are able to solve even a minute rank deciding questions. If you're really agreed, then I want to see green hearts. Now question from solution chapter. Solution chapter, colligative properties chapter, colligative properties. Question is, which will have maximum boiling point? Maximum boiling point. A, CO. Okay, let me change this question. Let me change a little bit. Okay, first let me give like this only. CO ammonia. Ammonia whole 3 Cl3, 1 molar. 1 molar. Arey Baba, 1 molar. Molar. B, CO ammonia whole 5 Cl, Cl2, 1 molar. Okay, 2 options, only 2 options. Tell me what should be your answer. Tell me what's your answer. Only two. Just to save time, only 2 options. Fast. Gets fast. Be fast. Oh my God, some people are going with 1. Ayyo, this time, kids. Hey, this time you are losing. This time you are losing. Now see, let me tell you. Elevation in boiling point. Elevation in boiling point is colligative property. CP means colligative property, right? Now, colligative property Means I say colligative property like democratic properties. What do you mean by democracy? In our India, whether the person is fatty, tall, dwarf, black, white, doesn't matter. One person, one vote. One person, one vote. More person, more votes. So like democratic properties, whatever the type of people are there, doesn't matter how many votes are there, that party is going to win. Just like that colligative property says, whatever the number of particles, if number of ions are more, they all are 1 molal. When they are 1 molal, then you know that Van 't Hoff factor that says more the number of ions, more will be colligative property, more will be the elevation in boiling point, more will be boiling point. Am I right? More elevation, more will be boiling point. So who is having maximum number of ions? It is having only 1 ion, and it will break to give 2 and 1 3 ions. 3 ions, it will provide 3 ions, it will have only, this is 1 only. So more ions, more colligative property, more elevation in boiling point, more elevation, so more boiling point, so will have maximum boiling point. Agreed? B is the answer. If you are agreed with my explanation, everyone, I want to see green hearts in the chat section. If you are agreed, kids, if you are agreed. If you are agreed, kids. Gotcha. Very good, Sahana. Kids, if you are really agreed, if you are really agreed, now see, the same question I will give you in a different way. The same question Baba is going to give you in a different way. See, the same question. Question is, which will show maximum boiling point? See, option A, CO NH3 CO Cl2 6 ammonia, B, CO Cl, no, let me change a bit, CO Cl3, 3 ammonia, CO Cl3, 6 ammonia, C, CO Cl3 and 5 ammonia. Now D1, CO Cl3, 4 ammonia. Now this is a brilliant question, rank deciding question. Rank deciding, kids. It's being a rank deciding question. Now, just think over it. Take your time. I want to see accuracy. Baba want to see accuracy. B. Very good. Everyone is correct. Everyone is correct. But kids, how? How you have given the correct answer? Yeah, because it will be like this. CO ammonia whole 6 Cl3, total you will get CO ammonia whole 6, 3 negative and 3 times chloride, 4 ions, the maximum ions, it's giving maximum ions, so it will have maximum colligative property, maximum CP means maximum boiling point, least freezing point, agreed. Least freezing point, agreed. Because depression in freezing point is a colligative property. Depression in freezing point is a colligative property. So maximum boiling point, least freezing point, because of maximum ions. If everyone, and maximum osmotic pressure, maximum osmotic pressure. And relative layering in vapor pressure will be maximum. If everyone agreed, kids, show me green hearts. Then now I will tell you according to Werner. Without taking name of Werner, we have done all the questions from the whole chemistry. If you're really liking it, the way Baba is teaching you each and everything, and I have promised you that I will give you 100% accuracy. If really you are agreed, if anything you want to write in the chat section, you can write. I will see the chat section. Baba, why ACD are wrong? Okay, let me tell you. Sahana's answer, why ACD are wrong. See, A is having 3 chlorine. Now cobalts, how many queens are fixed? Let me tell you. Let me explain. Let me explain Sahana's answer. See, why ACD are wrong? CO, Cl3, ammonia, whole thrice. Now, cobalts, how many queens are fixed? Number of queens fixed for cobalt king. This is king. I've told you how many queens are fixed. 6 queens. 6 queens. And king always give preference to neutral queens. King's preferences to neutral queens. King's first preference is for neutral. Neutral means without charge one, without charge queens. Now see, these are 3. So king needs how many queens? 6. So first preference to ammonia, but they are just 3. So all these 3 girlfriends will become queen. So no ionizable chloride. No ionizable chloride. All the girlfriends, they have become queen. Now kids, whenever I'm going to talk about Werner, you will say Werner knows less than Baba HSP. I will show you NCERT. I will show you Tamil Nadu board NCERT, Tamil Nadu board, state board also book. You will say Baba knows 100 times better than Werner. Yes, I will show you. Now see, this is the fix. Now let me show you. If I write down CO, Cl3, 4 ammonia. Now see, you just try to frame out cobalt. Maximum preference should be given to ammonia, but how many ammonia are there? 4. Now king wants 6 queens. 6 queens. Now how many chloride girlfriend will become? So 2 chlorides will be there, 1 chloride will be there, because 4 plus 2 becomes 6. So this number 6, this king has to manage. So only 1 ionizable chloride. So 1 plus 1, you will get total 2 ions, CO, ammonia, whole 4, Cl2, and here what's the charge? 1 chloride, negative, plus Cl negative, 2 ions, total 2 ions you got. Now how many of you understood this concept? Did you understand? Have you understood? Then show me green hearts. Sahana and all, have you got it? Kids, thank you Ritishri. Everyone just to let me know you are able to write down the complex or not. Everyone just to let me know. Have you got it? Everyone. If yes, I want to see green hearts. Wow, wow, wow. Now let me show you. Let me show you. Wow, let me show you. Now let me show you. See kids. Now see. Just see. what Baba is going to tell you, kids. Just see Baba's theory. You will become fan of Baba definitely. Today only you are going to become fan of Baba. Those who are having brain, those who are applying brain, they will become fan of Baba. See, kids. Now see, if I say I am having this compound, CO ammonia whole 6, just try to see, kids, and Cl3, just see. You must, have you studied redox? Have you studied redox? Then chloride is having -1 oxidation state and ammonia is a neutral. Just try to find out ammonia is having no charge, so 0, no charge. Okay, just try to find out this much. Then first thing what I am going to tell you, just see, if anyone is saying find out oxidation state of this cobalt, oxidation state, you must have studied in your redox oxidation state. Then how you are supposed to find out, just see, take this cobalt as X plus 6 into 0. Why 0? Because ammonia is without charge, no charge. Ammonia is not having any charge. Are you getting my point? Ammonia is without charge, so 0. Now Cl plus 3 and 1 chloride is having -1, so 3 chloride -1, and the whole compound is neutral compound. So what I will write is equal to 0. Agreed? Now X plus 0 minus 3 is equal to 0, so X is equal to plus 3. The oxidation state on cobalt is plus 3. Now who is responsible for giving this oxidation state? Who is responsible for giving oxidation state? Primary valency is always responsible for giving oxidation state. This -3, this has not given, right? This has given. Now this is responsible for giving coordination number. It's coordination number, the number of votes of this house. If anyone is coming, how many votes you are having, how many queens you are having. So these are the queens, so it gives coordination number. Coordination number is always given by the secondary valency. This is the position of secondary valency. This is the position of primary valency. Is it clear? Now I am going to move towards NCERT and to show you Werner's coordination theory. Everyone, see. Can you read this? Is it visible to all of you, kids? Let me check it out on the screen. Let's see whether it is visible or not. First of all, this font is visible to all of you. Is this font visible to all of you, kids? Do let me know first of all. Everyone? Okay. Now let me show you, kids. One mole of COCl3, don't see over here, don't see over here, don't see over here, don't see the right hand side, don't see the right hand side. COCl3, 6 ammonia, how many chlorides are ionizable? Do let me know in the first one. In the first one, how many are ionizable? Just to let me know in the first one, how many are ionizable? The first one. CO, all ammonia will be the queen of this cobalt. 6 ammonia will be its queen. The secondary valencies 3 will be outside. So 3 moles of AgCl. The first line is clear. Just to let me know. Just to let me know, everyone. The first line is clear. In the first one, 3 ionizable chloride. Is it clear to all of you, kids? Green hearts. You are so slow, kids. Everyone, if you are able to understand this NCERT's line, kids. Baba is waiting, Baba is waiting, Baba is waiting. Baba started crying. You people are not showing green hearts. You are slow. Smash the like button if you are really liking. If you are really liking it, kids, smash the like button. I want to see more likes in the chat section if you are really loving it. If you are really loving it, kids, I want to see the likes should get increased. Make it 300 plus likes, kids. If you are really loving. Till now, I have not taken the name of Werner, but we are able to solve all the questions. If you're really liking it, wow, I want to see. Oh, internet is slow. Yeah, Maitri, thank you. Thank you. Jyoti, welcome. Sahana, welcome. Naveen, yeah. Now, one question must be coming to your brain. One question must be coming to your brain. Sir, what's that question? Sir, what's that question? One question must be coming to everyone's brain. That question is, sir, these are same. These are being same. These are being same. Array, what happened? These are being same. These are being same. Why it's not? I am unable to. Okay, both of these are being same. Both are giving 1 mole of AgCl. Then why the change in color? This question must be coming to everyone's brain. This and this both are same, but this is green. This is looking green, this is looking green, and this is violet. Why? This question is coming to your brain. Hey kids, this question. So later on I will tell you, they will show GI. They will be showing GI. They will be cis and trans, and that's why, because of they are stereoisomers, that's why there is change in color. This I will teach in stereoisomerism. Everyone got it? Now, let's move ahead. Let's move ahead, kids. Let's move ahead. Where the pen has gone? Let me check it out. Pen. Okay. Now see, kids, is it visible to all of you? Is it visible? Let me see in the chat section. Is it visible? Is it visible to all of you, kids? That I will let you know. Abhinya, I will let you know when I will teach you. When I will come to this portion of color, I will let you know. Now see everyone. Just see everyone. Now see. These observations together with the result of conductivity. See, the word conductivity is there. Can you see? Can you read it out? That's why I talked about conductivity. Result of conductivity measures in solution can be explained that first one. 6 groups in all, either chloride ions or ammonium molecules or both, remain bonded with this, and with this dissociate under the reaction. Werner proposed the term secondary valency for the number of groups bounded directly to the central metal atom, the one who is more closer to the king. See the language, the one who is more closer to the king. The king right now here is cobalt, and ammonia is the queen. The one who is more closer to the king is secondary valency. See, Werner proposed the term secondary valence for the number of groups bound directly to the central metal atom. In each of these examples, the secondary valencies are 6. Are you getting my point, kids? Are you able to understand this point? The secondary valencies are 6 kits. The one who is more closer is the secondary valency kits. Are you getting my point? If you are getting this point, now see. See, where the atoms within the square brackets form a single entity which does not dissociate under the reaction condition. The point, the one who is inside the square bracket, I said the square bracket as like Lakshman Rekha, like fort, the house, the one who is in house will not dissociate. The Werner said, see, with the examples, with the experiments he studied, that the compounds are formulated as shown in table, where the atoms within the square brackets form a single entity which does not dissociate under the reaction, and Werner proposed the term secondary valency. Now he will come to the primary valency, but first of all, do let me know this point is clear. Keep on showing green hearts, kids. Between me and you, the only bond is, yeah, this is more than sufficient, but show me green hearts, kids, fast. I want to see the chat running very fast, kids, if you are able to understand each and every line of NCERT, because NCERT writes in between the line, and if you are able to understand these lines, because first I taught you and then I am moving with the NCERT. NCERT's each and every line is holding a hell lot of weightage. Wow, wow, wow. Now see. See, the conductivity table is given. Formulation of cobalt 3 chloride ammonia complex. See, this one, just see 6 queens are inside, 3 chloride, 1 raised to 3, total 4 ions. 5 and 2, 1 raised to 2, 1 raised to 1, 1 raised to 1 electrolyte. Is this table you are able to understand? Yes. Note that last 2 compounds have identical empirical formula. Already I have told you. Now see, now see, now see. Werner's point number 1. La la la. La la la. First point. Are you ready? In coordination compound, metal shows 2 types of linkages. One, the queen. Second, the GF. One, the queen. The second, the GF. Primary and secondary. First point clear? The primary valencies are normally ionizable. Oh, normally ionizable. The word normally, oh my God. What they want to show normally, normally, Rangaswamy. Normally ionizable. What do you mean by this normally ionizable? Kids, how many of you want to know the answer? Normally ionizable. Why they are talking about normally ionizable? Array. Normally, what do you mean by this normally ionizable? Should I tell you? Should I explain this point? How many of you are interested in normally what? See, assertion and reasoning, this normally holds a lot of weightage. How many of you are interested? Why they have written normally ionizable? That means it can be ionizable, it cannot be ionizable. How many of you are interested? Just write down me. Write down me, kids. Medhuba, I will let you know each and everything. Medhuba, I will explain each and everything, kids. See, why they are writing like this, normally ionizable. Why they have written, why they have written normally ionizable? Why they have written normally ionizable? Array. Normally, this word normally ionizable. Now see, what's the meaning of that? See. See, if I write like this, CO ammonia whole 5 chloride Cl2, what I said, these are ionizable, these are ionizable, these two are ionizable. This is non-ionizable. This is also non-ionizable. This is also non-ionizable. Now kids, just try to find it out. Just see. This is the original queen. These 5 are original queens. Original. But this queen, what you will say about this queen? Tell me in the chat section. What's your opinion about this queen? This queen, this queen. Write down this queen. I am writing this is the queen who was earlier the girlfriend. Earlier this queen was the girlfriend. Girlfriend has become queen. Has become queen. Am I right, kids? Right now the king is having 6 queens, but out of 6 queens, 5 plus 1. These were original. This girlfriend plus queen. It is in double role. Double role. Double role. Why I am saying double role? It is responsible for oxidation state. Why I am saying double role? This queen is in double role because it is responsible for oxidation state plus coordination number. Am I right, kids? It is in double role. This queen is in double role because it is responsible for oxidation state plus coordination number. This is responsible only for coordination number. This is only responsible for the oxidation state, but it is in double role. And this cannot move outside because it is inside this coordination sphere, so can't go outside. This is a primary valency plus secondary valency, and that's why this primary valency is non-ionizable. So that's why they have written normally they are ionizable, otherwise not always ionizable. Now you got it. How many of you got it, kids? Baba is taking a single word and explaining each and everything. Kids, how many of you got it? Just to let me know. Kids, I can see most of the people, they are writing the correct answer. Kids, break I will give you, but first of all do let me know how many of you got it. If yes, I want to see green hearts, kids, and likes for Baba's efforts. Kids, Baba is telling you more than thank you. Sahana, Arpana, Rohita, Madhu. Kids, just boost my energy. Your positive response only can boost my energy, kids. If you're really liking each and everything, see, even a single word, kids, first of all do let me know. Baba is taking care of even a single word. See how normally ionizable. They have written normally ionizable. See, the primary valencies are normally ionizable, not always ionizable. That's why Baba has taken care of this thing, that primary valencies are normally ionizable and they are satisfied by negative ions. Okay, now 1 and 2 point, both the 2 points are clear to all of you. These first is clear, second is clear. Now see the third point. The secondary valence are non-ionizable. I have told you, secondary valency, the queens, these are the queens, they are non-ionizable. These are satisfied by neutral molecules or negative ions. Already I have told you the secondary valencies is equal to the coordination number, and it is fixed for a metal. For every king there are fixed number of queens. The ions groups bounded by the secondary linkages to the metal have characteristic spatial arrangement. Now this point I will explain the coordination number. The fourth point I am going to explain. I hope this much is clear. Now let me tell you the fourth point. Let me explain the fourth point. What the fourth point they have written. Fourth point. See, if I write down CO ammonia whole 6 Cl3, my dear students, you must have studied chemical bonding. Have you studied chemical bonding? Actually, this complex is like this. That is the primary valency will go away. It is like CO ammonia whole 6 3 negative. Only this 6 that steric number. Have you studied steric number in chemical bonding? Now see, chemical bonding steric number is 6. So the hybridization will be, tell me what should be the hybridization. If steric number is 6, the hybridization will be, I want to see your answer in the chat section. If you're not writing, then I will not explain. Everyone just explain what should be the hybridization. Write down sp3d2. Very good. Either d2sp3 or sp3d2, that I will explain. d2sp3 octahedral complex, right? Octahedral complex. Am I right, kids? Now octahedral complex I will make. It is CO ammonia hybridization I will tell you in valence bond theory in detail, but just see ammonia. These are secondary valencies, so its shape is determined by secondary valencies, that it is octahedral. Who has given that it is being octahedral? Who explained that it is being octahedral? Kids, do let me know. Who explained that it's octahedral? The secondary valencies, they have explained that it is being octahedral. It is being octahedral. This is explained by secondary valencies. Now, primary valencies, they are lying far away. They are lying far away, like this one chloride. It's like this one chloride. Far away. They are far away from the king. They are far away, like chloride, chloride, chloride. These are primary valencies. They have nothing to do to determine the shape of this molecule. Shape is determined by secondary valencies. Is this point clear? Shape is given by whom? Shape is given by SV, secondary valencies, not by primary valencies. But this is not the full explanation. Now just see, if I write down CO ammonia whole 4 Cl2 and chloride, once again its steric number is coming out 6. So its shape, just see, CO 1 ammonia, 4 ammonias are there. Ammonia total 4 ammonias are there, just see. Now shape is octahedral. So just see, the chloride will be like this. Just see, the chloride will be like this. It is playing the role of secondary valency as well as it is playing the role of primary valency also. Primary valency and secondary valency. The chloride is in double role. And one chloride is far away. One chloride is far away. So I can write this chloride is far away. This is just primary valency. Now can you understand? It is in double role. These two chlorides are in double role. Can you understand? They are playing the role of Sb plus Pv. Sb plus Pv. This is only primary valency and these are only secondary valencies. Secondary valency, secondary valency, secondary valency, secondary valency. By seeing this structure, you can say this is ionizable. Just this is ionizable. It is lying far away and these are non-ionizable. Now is it clear? The fourth point's explanation, if it is clear, I want to see green hearts. Gopinath, welcome. Coordination number is giving steric number. Coordination number is responsible for giving coordination number. Steric number is given by coordination number. Kids, see whatever is written over here, this will give you steric number. Just see, Some kids are asking about steric number. 4 plus 2. 4 plus 2 is giving steric number 6, and this is giving hybridization. Octahedral shape is octahedral. See the previous one. The previous one, just see. 6 is the steric number. Got it? This point till now it's clear. Now kids, till now it's everything clear. Now let's see. Let's see fourth point. Now see, everything is given away. This point is clear. Now Werner's coordination theory is clear. Now let's move. One question we will do. Just see. This is given in NCERT example number or question number 1. PdCl2 ammonia, moles of AgCl precipitated as per mole of the compound 2. 2 moles of AgNO3 is used. That means 2 chlorides are outside. Palladium is having 4 moles of ammonia inside. So see, now just wait. No, don't go so fast, sir. Explain it properly. We want to see the correct answer. How many of you are interested in this? To find out the answer, how many of you are interested? Just see. Is it visible to all of you first? Everyone just see. Yeah, this is J mains or advanced or NEET or the best rank. Kids, everyone participate in the chat section. Then only Baba can explain each and everything, kids. Now see. Now what they are talking about, the first one, this one. PdCl2 ammonia. We don't know how many secondary valencies of palladium are there, because for everyone they are not fixed. If the king is getting changed, the number of queens will also get changed. If the central metal atom is getting changed, the number of secondary valencies will also get changed. Satisfied what I'm saying? If the type of central metal atom or ion is getting changed, the number of secondary valencies are also supposed to get changed. We don't know the palladium. Cobalt, we are well aware that cobalt will have 6 secondary valencies, but palladium, we don't know how many secondary valencies. So see, palladium chloride ammonia when treated with AgCl, then how many moles got precipitated? 2. That means 2 AgNO3 must got consumed. If 2 AgNO3 are getting consumed, 2 AgCl, so 2 chlorides are outside. That means palladium will have 4 secondary valencies and 2 primary valencies. So see what they have asked about secondaries. Secondary valencies will be 4. Clear? Nickel Cl2 6 times H2O2. So these 6 water being neutral, these are the secondary valencies. What I'm saying, what I'm talking about, you are getting, my speed is okay. I don't think it's too fast. I am thinking that you are able to understand, you are comfortable. That means 2 chlorides have gone, so these chlorides will be outside. Okay, let me write down, otherwise I don't think that you are able to understand. So let me write down palladium, ammonia whole 4, ammonia whole 4, ammonia whole 4. Here nickel H2O whole 6. How I am writing this formula? Because 2 chloride. Now see, PtCl for 2 HCl 0. That means they will be inside. COCl3 4 ammonia. 1 chloride it's outside. Rest 4 plus 2 6. You got it. Now PtCl2 ammonia, no PPT. That means all they are inside. 2 ammonia, 2 chloride, secondary valency for 5th will be 4, secondary 4. Everyone, is it clear? This table is clear, then show me green hearts. If this table is clear to each and everyone, show me green hearts, kids. Quick, fast, kids, fast. If you are unable to understand, show me fire. You can show me fire if you are unable to understand. Green hearts if you got it. If you got it, green hearts, otherwise fire. Baba rocking, thank you. Okay, some kids are asking to explain it again. Okay, Baba will tell you. Don't worry, don't worry, don't worry, don't worry. Just see, don't worry. See kids, see everyone, see. This compound is reacting with AgNO3, okay? What they have written, moles of AgCl. How many moles of AgCl got precipitated? 2 moles of AgCl. Then what information you are getting for the first one? 2 moles of AgCl says that 2 chlorides are ionizable. This is indicating that 2 chlorides are outside the coordination sphere. Coordination sphere, they are outside coordination sphere. So I have to keep 2 chlorides outside. So what will be the formula? Formula will be PD ammonia whole 4 Cl2 for the first one. For the first one, are you agreed everyone? Just do let me know for the first one. That means its secondary valencies are how many secondary valencies? 4 secondary valencies are there, and these are primary valencies. So he asked about secondary valency. If the first point is clear, those who haven't got the first point earlier, then do let me know if this point is clear. Then I will move to second point. If it is clear, show me green hearts. Now let me move towards second point. Just see for the second point. So let me remove the first point. Second point, what they are writing about the second point? Just see the second point. Let me remove the first point. The second point. Second point, they are saying that 2 AgCl we have got. That it's indicating that 2 chlorides are outside. Am I right? So 2 chlorides are outside. So how I will formulate? Nickel. All water are inside. 2 chlorides are outside. That's why 2 moles of AgCl. So its secondary valency, the 6. 6 is the secondary valency. So second answer is 6. Now let me come to the third one. Let's see the third one, kids. Now see the third one. Third one, they are saying 0. This 0 is indicating that no chloride. See, whatever the number of chlorides are there, when AgNO3 is going to react, it is given in X's. It is given in X's. So who will decide? This is the limiting reagent. This is the limiting reagent LR. You must have studied in physical chemistry. This will decide the product. So X number of chlorides. So X number of AgCl white PPT I will get. Is this point clear? They are saying 0. 0 means there is no Cl outside. That means everyone is inside. Everyone is inside. So see how many 4 chlorines are inside and 2 HCl are inside. So 4 plus 2. 4 plus 2, 6. 6 is the secondary valency for third. Secondary valencies are 6. Now see, let me explain for fourth one. Fourth one, see for the fourth one. Fourth one, they are saying 1. This 1 is indicating 1 chloride it's outside. 1 chloride it's outside. CO ammonia. How many ammonia? All 4 ammonias. How many chlorine? 1 outside, 2 inside. 2 inside, 1 outside. So 4 plus 2. Answer is 4 plus 2 is 6. So for the fourth one is also 6. I hope that now it's clear to each and everyone. Kids, tell me, kids. Yeah, yes. No. Jyoti, number of AgCl precipitated not to primary valency. No. Ionizable valencies. See, in this is a primary valency plus secondary valency double role. These chlorides are also. So number of AgCl precipitated will be given by ionizable chlorides. Ionizable. So number of ionizable chlorides are responsible for number of ionizable chlorides are responsible for AgCl. Let me write down number of AgCl precipitated will be equal to number of ionizable valencies. Number of, let me write down, just wait. Jyoti, let me help you. Don't worry. Whatever the number of chlorides which are present over here, just see. If I say this is the complex, whatever the number of chlorides present over here, X number of chlorides present over here, whatever the number of chlorides present over here, they are ionizable. These are ionizable. These are ionizable chlorides. These are responsible for giving AgCl. Number of ionizable chloride, they are responsible. Clear, Jyoti? Everyone. Thank you, Roger Mew. Egoistic gamer. Yeah, now tell me, is it clear to each and everyone? If yes, show me green hearts. If no, you can show me fire, kids. Thank you, Kavishri. Thank you, kids. Baba is really giving you the best, kids. Yeah, that X is equal to not primary valency. Jyoti, not primary valency. Not primary valency. Jyoti, ionizable. Thank you, Resagnia Kanchi. Shruti, right now don't ask for break, kids. Kids, long to go. But my focus is on accuracy, and speed will come automatically. Once the accuracy is there, speed will come automatically. Speed will come automatically once kids. Wow, now I think it is more visible. Now see, kids, the visibility got changed. Now it's more visible. I think so. Now kids, I will provide you each and everything. I'm promising you. You have to stay with me with pen and paper. I will make it interesting. See how the questions are getting solved. Each step by step, each paper by paper, concept by concept. I will let you know each and everything. But you have to be with me. With cool and calm mind. Will you remain with me, kids? I'm not so much frequent on YouTube, but those who know me, they know that how much accuracy Baba is going to give you, what type of rank Baba is always providing, kids. Those who know me, write down. My words means a lot. They hold a hell lot of weightage or not. First of all, do let me know, kids. Those who really know me, who is Baba, how many rank producer, that the rank factory Baba is there, and this is all because I go line by line. I will let you know each and everything. First of all, do let me know, kids, Baba is true or not. I want to see in the chat section. If yes, if you are agreed, I want to see likes. Hit the like button. I'm not that much frequent on YouTube, but yes. Thank you, Dar Arfat, love from Kashmir. Wow. Devadarshini, yeah, thank you. Break I will give, but not right now. At 2 p.m. I will give you break. At 2 p.m. I will give one break. At 2 p.m. lunch break I will give at 2 p.m. Okay? At 2 p.m. I will give lunch break. How many are you from Jaipur? How many of you are from Jaipur? Write down. How many of you are from Jaipur, kids? Let me see how many are from Jaipur. Matri GK, love from Karnataka. Thank you. Jyoti, now you got it. Thank you. Sir, how should we know? If not mentioned in the question, no one can understand how many queens a king holds. Very good question I got. One kid is asking that one king can hold how many queens. How to understand? We cannot we cannot find it out. It should always be mentioned in the question. Otherwise, we cannot find out how many queens the king can hold. Such type of questions will give you the information about how many queens can be held by the king. Okay, now let's move. Let's move ahead, kids. Difference between a double salt and a complex. This already explained. We have already done it. Difference between a double salt and a complex. Already done. Now see kids. Now coordination entity, central atom. Already I have explained what do you mean by central atom kids. Central atom. This is the central atom. This is the central nickel, cobalt and iron. They are Lewis acid. Have I explained or not? So already explained definitions of some important terms, and this central atom, they act as Lewis acid. Already explained ligands. The queens, they are acting as ligands, and ligands are electron donors. So donors, now we have to understand about these queens. They hold a hell lot of weightage. If you are able to understand these queens, very, very important, you will be able to understand whole chapter. So we have to find out these ligands in detail. Are you ready? If yes, I want to see fire in the chat section if everyone is ready. If everyone is ready, because types of queens, they hold a hell lot of weightage. So let's move and try to find out types of queens, types of ligands. Now our story is with types of ligands. Everyone, are you ready? Are you ready everyone? Types of ligands. Our story will move with the type of ligands. Is everyone ready kids? So types of ligands. Ligands type. These are of three types. These are of three types. Three types of ligands are there. Three types of ligands. There are total three types of ligands kids. What are these three types of ligands? Just see kids, everyone. Division of ligands. First is being based on denticity. Based on denticity. Denticity means number of donor site. That is number of donor sites. Second division is on the basis of, just do let me know, second division should be on the basis of what? Charge. Charge. These ligands can be neutral, they can be negatively charged, sometimes they can be positively charged also. My God, sometimes even positively charged. Wow, this is interesting how they can be positively charged. Now third type of division is classical ligands. This is very new. Classical ligands and non-classical ligands. Now I will explain what is the difference between classical and non-classical, but let me write down a little bit over here. Only donor, but these are donor as well as acceptor. Donor plus acceptor, and they will be responsible for synergic bonding. If you have heard about synergic bonding, then they will be responsible for synergic bonding, my dear friends. They will be responsible for synergic bonding. So these type of ligands are there. Let me explain one by one. Everyone agreed? Everyone ready? Okay, let me explain one by one each and everything, kids. Okay, now see, based on denticity, see kids, this part is very very important, so you can't ignore it. You have to go with this and you have to answer it in the chat section, whatever I'm going to tell you, kids, right? Denticity. First one is denticity based. Denticity based. Just see, if I write down ammonia, one lone pair is there, so its denticity will be 1. One donor site, one donor, I'm teaching you from the 0 level. One donor site, that is one lone pair. It is having one lone pair. So its denticity will be 1. Denticity is 1. Now you will say, oh sir, so you want to say, sir, that if water is having 2 lone pairs, so its denticity will be 2. No, my dear friends, it will not 2. Its denticity is also 1. Why, sir? Its denticity is also 1. Can't be 2. Now question arises, why, sir? Why? Ask me, पूछो क्यों? Ask me why can't be 2. पूछो क्यों? Let's see in the chat section. I will teach you in a different way. Yeah, back bonding, that is synergic bonding. Ask me why it can't be 2. Water is having 2 lone pair, then also why it can't be 2. पूछो क्यों? पूछो ना पूछो ये क्या हुआ? कोई ना ये जाना. Just ask me why can't be 2. ये तो मुझसे पूछो. Yeah, everyone, see, पूछो क्यों? Now, if I say this is central metal atom and water is over here. Water is over here. Now, if it is donating 1 lone pair, then it will form coordinate bond like this. It will form a coordinate bond like this. Am I right, kids? Now, if it is donating its second lone pair also, then coordinate bond will be like this. How many membered ring? Can you see how many membered ring? Oxygen, cobalt, oxygen. How many membered ring? This, let me show you once again. If you're not able to understand, this is cobalt. This is oxygen, water, one lone pair. If it is forming like this, how many atoms ring? 2 atoms ring. This ring is unstable. Just see, is this ring? Will you say this ring is stable? Will you say this 2 atom rings is stable? Doesn't mean 2 atoms ring 3. How many atoms ring are stable? Ring must be of 6, 5 or 7 membered, then only stable. If I talk about another ring, just see, if I say this is cobalt and if I say there is ethylene diamine, NH2, CH2, NH2, this denticity will be 2. Why its denticity is 2? Just see why its denticity is 2. 1 atom, 2 atoms, 3 atoms, 4 atoms, 5 atoms, 5 membered ring. This is okay. It is stable. Now you got it. How many you got it? Yes, the way Baba is teaching is different from the whole world. Do let me know. Now you got it. Why water cannot donate to? Now you got it, kids. Everyone got it. Just do let me know. Now, the second point I am going to tell you. Now, the most important, some kids are writing 5-membered, then 6-membered like this. Now, see kids, one more thing, let me tell you, one more thing, very, very important thing. See, you have studied organic chemistry. You must have studied organic chemistry. Organic chemistry ring stability is like this. Ring stability, 6-membered ring, then 5-membered ring, then 7-membered ring. This was the stability of ring. Am I right? Am I right, kids? But in coordination chemistry, rule is different. But in coordination chemistry, just see, be aware of it. 5-membered ring is more stable with saturated ligands, saturated ligands. Remember that. If ligands are saturated, then 5-membered ring is stable. Just remember what I am talking about. But on the second hand, I will say 6-membered ring is more stable with unsaturated ligands. Now, unsaturated ligands must be doing what? They must be doing resonance, conjugation, whatever they must be doing. This is the reason, because of conjugation. So what I am saying, both are having their own criteria for stability. This is something new, and I hope that you must have not studied. From wherever you have studied, these 2 points holds a lot of weightage, and I know that you have not studied these 2 points. Have you got these 2 points, new points? If yes, show me green hearts. If really you have got these points new for coordination chemistry, then show me green hearts, kids. Everyone, kids, those who really, and hit the like button if you're really liking the way Baba is teaching the new things, kids. Kids, if you're really liking the way Baba is teaching the new things, kids, I need energy, kids. You are the only source of. Thank you, Kavishri. Very good, very good, very good. Now, let me explain. I was over here. I was telling you that they are monodentate. Whether I talk about ammonia, whether I talk about water, their denticity will be 1. Now, let me tell you. Their denticity will be 1. Now, see. So, denticity of all these will be 1. Unidentate, I can say unidentate. So, like chloride. Now, chloride is having number of lone pairs. Then also it is unidentate because it can donate just 1. Chloride, bromide, iodide, and ammonia, water. Even they are having 2 lone pairs. Ether, 2 lone pairs, but then denticity will be 1 at a time, only 1. Alcohols, etc. etc. Now let's come to the bidentate. Bidentate, just see bidentate. Bidentate. Now try to keep it in your brain. Otherwise you won't be able to understand coordination chemistry with exact brain. Try to keep it in your brain. Hippocampus, bidentate ligands. So their donor sites, how many donor sites? 2 donor sites. They will have 2 donor sites. Am I right, kids? Now see, if I write down ethylene diamine CH2 NH2. What's its name? Once they have asked its name, see in the name ethylene, there is no double bond, then also its name is ethylene diamine, no double bond, but then also name is or ethane 1,2-diamine or diaminoethane 1,2-diaminoethane, or this can be written like this also. See now how many donor sites? Just see first of all, this is one donor site, this is one donor site, okay, this is one donor site, this is one donor site. Suppose there is metal in the central, they will come like this and they will come like this, NH2 lone pair, CH2 NH2 lone pair. So they will donate like this. Are you getting my point? So this can be written like this, or simply they can give you like this also. See, the same thing they can give you, they can write like EN, ethylene diamine. Simply they can write like this, or they can also write like this, N. They are saying that we are not going to show carbon. They can write like this also. All they mean same. If clear? Now want to see green hearts, kids, if it is clear to each and everyone. Denticity, bidentate. Now bidentate can be glycinate, glycinato they will write. Why they are writing O, I will let you know. But NH2 CH2 COO negative. So 2 donor sites you can see clearly, one donor site, another one donor site. Can you see 2 donor sites? Right. Now see, kids, oxalate, oxalate, you know oxalate is C double bond O negative, C double bond O negative. So negatively charged are better ones. So this donor site, this donor site, 2 donor sites, they all are going to form 5-membered ring. I hope that this point is clear to each and every one. My dear friend, just to let me know. Now one is ACAC. What is ACAC? See the name ACAC. Have you heard this name ACAC? ACAC. Have you ever heard this name ACAC? Acetyl acetonato. Now let's see, no need to cram it. Have you heard this name acetone? So see, acetone is this one, CH3 C double bond O CH3. This is acetone. Have you heard the name acetyl? Acetyl is CH3 C double bond O. This is acetyl. This is acetone. Let's combine them. Let's combine them. When they are going to combine, what they will form? I have to remove one hydrogen and let's paste over there. So CH3 C double bond O. Let's remove one hydrogen from here. So they will combine like this, CH2CO and CH3, right? Now you know that this will show tautomerism. So one hydrogen will go away from here, so it will get negatively charged. Now this will do resonance, so this will come over here and this will shift over there. So see what I am going to tell you, kids. Now see how you can frame it out. This will go over here, or you can say resonance or tautomerism. Now see, you will get CH3, C double bond O, CH double bond CO negative, CH3. So this is ACAC, acetyl acetinato. No need to cram it, kids. Just try to apply your brain. Now you can see this is donor and this is donor. So one negative charge bidentate. I hope this is clear to all of you. Till now it is clear. I want to see green hearts. Kids, keep on showing green hearts if it is clear. If it is not clear, then you can show me fire in the chat section. At 2 p.m. I will give you break. One break, lunch break I will give you at 2. Wow, very good. Toiba. Toiba is there. Hey Toiba. Welcome, welcome, welcome. Toiba, you know, have you seen at Jaipur? Toiba is there, and Toiba has once visited this Jaipur. Toiba, I want to see Toiba. Lavanya, Abhinay, Nayana. Now, ACAC is clear to all of you. Wow. Madhu, I will explain. Toiba is from Kashmir. Okay, Toiba, you're from Kashmir. Okay, now see, tridentate. Just see tridentate. Now just see, focus over here, tridentate, very, very important. Now see, they will write like this. See what they will write. They will write like this, diene, diene. Now can you expel it? What is diene? Diene, what is diene? Now see, that means 2 ene are there. Ene stands for ethylene diamine. One ethylene is there, diamine. Now its name is diethylene amine. Diethylene triamine. Triamine. Diethylene triamine. Now how will you make it? Just see. Just see. NH2, CH2, CH2, and I was having NH2. NH2 I was having like this. This is ene. This is ene. Now I will replace one hydrogen from here and I will add once again CH2, CH2, NH2. Now just see how many donor sites, kids. Just focus. One donor site, second donor site, and third donor site. Now this is really awesome. This is really awesome. How they will capture, how they are going to capture the metal. Just see. Let me show you how they are going to capture the metal. Suppose this is central metal atom. Now how they are going to capture it? Just see, kids, everyone. NH2, CH2, CH2, NH, CH2, CH2, NH2. Now see, kids, how they are going to capture. Kichak, kichak, kichak. Oh my God, how many rings? 1 ring and 2 rings. Yay, yay. Are you getting my point? They are capturing from these sites. Diethylene triamine. It's really nice. Now see another one. You got it? You got it? Now see imida. Have you heard the name imida? Imida. Imida. Now what's the charge on imida? I don't know. Imida. Imida 2 negative. Now see what is imida 2 negative. Have you ever heard this name imida? Now see what is imida. NH, you know ammonia. This why this was unidentate. Ammonia was unidentate. Now what I'm going to do? Let me put here acetate. CH2, COO minus, CH2, COO minus. Now see, just see how many denticity. 1, 2, 3. So actually it was amine. Now it is, its name will be imida. Imida means amino diacetate. Amino diacetate. Can you see? Imida. imida, imino diacetate. Two acetates are there and denticity is 3. Can you see, everyone? Is it clear? No need to cram it. I'm teaching you, kids. Do let me know you are getting it or not. First, your understanding is very, very important for me. Kids, imida, yeah, Bahubali movie, that imida was there. Imida. Everyone say imida. Now see, NTA. Now Baba is going to write down NTA, but that will come in tridentate. It will come in tridentate. So let's keep rocking. Tridentate ligands. Understanding of ligands holds a hell lot of weightage, otherwise you won't be able to understand coordination chemistry. NTA 3 negative. What is this NTA? Have you ever heard this NTA? Now see, what is NTA? We know that nitrogen is having 3 hydrogens. If I talk about what? Ammonia. If I talk about ammonia, this nitrogen, amine it is. Now see what Baba is going to do. CH2COO minus, CH2COO minus, CH2COO minus. Now see, oh my god, tetradentate. Tridentate already I have explained. This was tridentate, so it's tetradentate, not the tridentate. Tetradentate. Tri already I have covered up. Tetradentate. Tetra. See how tetra? 1 donor site, 2 donor sites, 3 donor sites, 4 donor site. So its name is nitrilo triacetate. Have you ever heard this name? NTA 3 negative. Have you ever heard? Its full form is nitrilo triacetate. Those who have heard it for the first time, NTA 3 negative, tell me its denticity is 1, 2, 3, 4. 4 donor sites. Those who have heard it for the first time. Yeah, chai biscuit wala NTA, national tea agency. Oh my god, east of best, Baba is best. Thank you kids, thank you kids. Now another example, kids, hit the like button if you are really liking it. If you're really liking Baba's session, kids, then Baba will teach you each and everything, kids. This is the way Baba is not leaving even a single stone to be unturned. But that's why Baba is going to give you the accuracy. Now see, try in. If somebody is writing try in, what do you mean by try in? Triethylene, tetramine, triethylene, tetramine. See everyone, tetramine. What is this? Just see, triethylene. So see, CH2 NH2, right? 1 ethylene, NH, CH2 NH, 2 ethylene we got. Now one more, CH2 NH2. So you just see how many ethylene we have got. We have got 1 ethylene, 2 ethylene, 3 ethylene. So triethylene tetramine. How many lone pairs we have got? We have got 4 lone pairs. So see, 1, 2, 3, 4. I hope this is clear. So denticity is 4. Tetradentate. Now I'm going towards pentadentate. Just see the pentadentate, everyone. Pentadentate. Pentadentate ligand. Pentadentate ligand. Just see, its example is EDTA. EDTA 3 negative. Just see EDTA 3 negative. EDTA 3 negative is CH2 You must have seen ethylene diamine. I'm making everything from ethylene diamine so that there is no need to cram it out. Just see. I'm making it from ethylene diamine only. CH2COO minus, CH2COO minus, CH2COO minus. Now see what's the denticity. If you see the denticity 1, 2, 3, 4 and 5. Is it clear, kids? Do let me know. Is it clear? Lone pair and negative charge. So denticity is 1, 2, 3, 4, 5. Werner, Rana, Monu, Nale, Anche, 1, 2, 3, 4, 5, Anche, 5. Kids. Now, hexadentate ligand. Baba is moving towards hexadentate ligand. Kids, just see. Hexa. Dentate ligand, just see, kids. What's your writing, sir? Write it properly. Sorry, kiddo, kid. Sorry. Hexadentate, EDTA. Oh, negative. What is this? Once again, I will make it from there only. Just see, ethylene diamine. Remember that CH2, NH. Now what Baba is going? Oh, where your nitrogen has gone, sir? What are you doing? Sorry, kids. Forgive me, please, bacha. Okay. CH2COO minus, CH2COO minus, CH2COO minus, CH2COO minus. Kids, now just see, just chill. EDTA, la, just chill. Now, people, just to save time, they draw it like this also. And na, oh, just looking like cockroach. They write it like this, or simply they will write EDTA 4 negative. All they are same. Can you see? They are writing, oh, here donor atoms. We are just interested in the mangoes, not whatever the thing is left behind after mango. They are writing like this. Oh, we are not having that much of time. So just to save time, they can donate like this also. Is it clear to all of you, kids? Hey, bacha. Just to let me know, kids, if everything is clear, crystal clear like Sprite, easy peasy, lemon squeezy, do let me know, kids. Just after a few minutes, you will get a one break. Everyone. Ethylene diamine tetraacetate. What is the name? Name is also important, kids. Yeah. Just see. Its name is ethylene diamine tetraacetate. What is the name, kids? What I'm talking about? What's the name? Hey, what's your name? Dude, kids? Ethylene diamine tetraacetate. Ethylene diamine tetraacetate. Ethylene diamine tetraacetate. EDTA. Got it? So this was the first division on the basis of denticity. Are you ready for the second division on the type of charge? Is everyone ready on the basis of charge, kids? Do let me know. Kids. Okay, Baba is never talking to you. Never talking about anything. How are you, kids? Kids, if you enjoy your studies, really you are going to rock. If you're just thinking about, oh, let's do all the questions without going through the theory, kids, there are a number of kids, those who are really following Baba. Now, if you want to tell me my shortcomings, you can tell me. Most welcome. That Baba first do this and that. And if you're really liking it, tell everyone in the group, because Baba is never doing publicity. Baba is never posting anything anywhere. Baba is just to the point teaching you kids each and every point, that you can have that much of faith that whatever Baba is telling you will come from my notes only. That I'm damn sure that each and everything will come from my notes only. And once the ligands clarity is there, once you are able to understand the ligands, mark my words, you will be able to understand each and everything. Each and everything will become like easy peasy lemon squeezy. Arpudham. In Tamil, I would like to say the things which are looking idiyappam muruku, they will convert into romba sulubham. Arpudham, romba sulubham. Each and everything will become really easy. Kids, do let me know. सब कुछ आसान हो जाएगा, चंगा हो जाएगा, आपको सब समझ में आएगा. Thank you, Shobhan. Oh, Jyoti is asking, it will be single M or double M. Okay, see, it will be single M. Good question. Only in ammonia you will write double M. Only in ammonia you will write amine. Just focus, double M. Double M will be only in ammonia. Only ammonia, there will be double M. Only ammonia, only in ammonia. Remember this point to be noted by lot. Rest of other places it will be single M. You can check it out. Rest in all means like RNH2, R2NH, R3N, etc. will be single M only, will be single M. Ethylene diamine, etc. Everywhere there will be single M. If they are using double M, that's wrong. Will be single M. This point is very, very important. Got it? Very, very important point. See? Jyoti, you got it? Everyone, you got it? Very, very simple, very, very important. Is this point clear to each and everyone? Single and double M story. Let me see what you're writing in the chat section. Now I will tell you, the questions will be asked in IUPAC nomenclature. Just Baba is preparing you for IUPAC nomenclature. Is it clear, kids? Now on the basis of charge. Now see, second division on the basis of charge. Now kids, remember that first I will deal with negatively charged. Now, one more thing I would like to tell you kids here. One point I would like to add. Whenever the ligands are inside the coordination sphere, they will have different names, unique names. Remember that. When the ligands are acting as queens, they will get different names. See. One point, note you can write down. Whenever ligands are inside coordination sphere, they will have special names. And these names we have to become familiar with. So remember that whenever they will be the part of the coordination sphere, they will get different names. Let me tell you those names. See, just see, focus. If I write carbonate, you know this is carbonate. Simply we call it carbonate. Generally we call it what? General name is what? Carbonate. Carbonate. Everyone say, wherever you sit it, carbonate. But its special name will be what? Just remove E. Just remove this E. Just focus on this E and put O. Carbonato. Carbonato. Remove E, put O. O. बेबो, बहती हवा सा था वो, कहा गया उसे ढूंढो, यार हमारा था वो. ओ ओ ओ, got it? Oh, now see, if I write down, its simple name is sulfate. Sulfate, so its special name will become sulfato. Sulfato. Its simple name is chloride. Its name will become chlorido. Its simple name is sulfide. Its name will become sulfido. Sulfido. Are you getting my point? Its simple name is sulfite. Its name will become sulfito. 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 Are you getting my point? Everyone, are you getting my point? Now, this page is clear. If this page is clear, I want to see green hearts in the chat section. Everyone gets very good, very good. Neto, good, good, good. Just after a few minutes, you will get break, kids. You are really awesome students. That's why chlorido is preference. Out of chloro and chlorido, who is having more preference? Remember that chlorido is having more preference. This is more appropriate. More appropriate. Remember that. This one is more appropriate. Now see, kids. If I write this cyanide, now who is the donor site? This is actually like this C triple bond N, and carbon is having negative charge, nitrogen is having lone pair. At a time, only one can donate. Both cannot donate. Both can't donate. Now ask me, only one at a time can be donor. Either carbon or nitrogen, and that's why they are known as ambidentate ligands. Ambidentate, you must have studied in your organic chemistry also, ambidentate nucleophile, ambidentate ligand. Now ask me, pucho na pucho kyun? Kyun only one can donor, either this or that? Why not both of them? Ask me, pucho kyun? So answer is, let us suppose that there is central metal atom, and if both are donating, just see, if both are acting as donor, then what you will see? What you will see? Just see. What you will notice? Just tell me what you will notice. This and this. How many membered ring? How many membered ring? 3 membered ring. Is stable or unstable? 3 membered ring is unstable. It is highly unstable. Highly unstable. Now number of questions will get solved. Your number of questions will get solved by glycinato. This is glycinato. Both can be donor. CH2, COO negative. Just see, both are donor. Denticity is 2 over here. But here denticity will be 1 only. Why? This is the reason. Denticity will be 1. If everyone got it, the reason behind it, you got it. Then I want to see green hearts. If the reason is clear to each and everyone, Baba wanna see green hearts, kids. Kids, do let me know if this point is clear to each and every one of you. Do let me know, kids. Now see. So this cannot be formed. This is wrong. I would like to say this is wrong. So this is wrong. Absolutely wrong. Now see, kids. The cyanide, if I talk about cyanide, so cyanide both can be. Now see, if I talk about nitro, nitro. Now see, NO, now it is, let me put negative charge, N double bond O, O negative. So even this can be donor or that can be donor. So I will write, if central metal atom is there and if O is donor, if O is donor, then I will say nitrito O, nitrito O. And if nitrogen is donor to the central atom, if nitrogen is donating, then what I will write? What I will write, kids? Nitrito N, nitrito N, nitrito O, nitrito N. Like this, if I write Sachin, SCN, and there is metal, and if sulfur is donating, what I will write? Thiocyanato, thiocyaнаto, nachos. If I write nachos, NCS, nitrogen is donor, then I will write isothiocyaneto. Everyone, is this clear? They are the isomer ambidentate nucleophile. They are being ambidentate. I hope this is clear to each and every one of you. Ambidentate ligands. So this is the basis of charge. They all are being negatively charged. I hope this point is clear to each and every one of you. How to write down their name. No, everything will not end with O. I will let you know that no KNOW, no. So everything will not end with O. Just see, if I talk about, see, neutral ligand. This content you will never get anywhere, kids. First of all, do let me know, this type of content will you get anywhere on any channel? Is there anyone who is going to give you this type of content in inorganic chemistry? Have you ever seen? If you are agreed that yes, you are right, then I want to see green hearts. Now, if water is the ligand, this is neutral, no charge. Neutral ligands means without charge. Aqua, we will write aqua. Ammonia, I have already told you, amine. Remember that double M, amine. Now if I write down what to write down? Yeah, CH2, NH2, it's being neutral. So I will write ethylene diamine. Ethylene diamine, single M. Remember that, single M. It will be single M. So these are neutral ligands. Their name will be written like this only. We are supposed to write down their name like this only. Are you getting my point? Are you, everyone? Everyone, are you getting my point? Now, you must be thinking how, Baba, the positive charged ligands are present. Just see, positively charged ligands. Suppose if I write down like this, NH3 plus CH2, NH2, its name is, yes, either this one, or I can write NH3 plus and NH2. See, it is having lone pair, hydrazinium ion, hydrazinium ion. Now, you got it? This will be acting as donor site. Although positive charge, but they are having donors, so that's why they are like this, ethylene diaminium ion. Now see, some names are confusing, that you will get confused in your examination. So let me clear that, those names, confusing names. So you will get marks without getting confused. Confusing names. See, if I write down O2 negative, O2 2 negative, maximum students are getting confused over here. Am I right, kids? O2 single negative. See, A, B, C. These are the three compounds where mostly people are getting confused. So remember that. Its name is actually oxide. So we will write oxido. Oxido or oxo. Both are equally correct. This is peroxide. So we will write peroxido or peroxo. This is superoxide, so we'll write superoxido or superoxo. So how will you remember awesome? Oops, OPS, OPS, oops, OPS. Now these three are very, very important. Now if I write down, ammonia, 3 hydrogens will go. So ammonia, so N3 negative. Amide, so amido, remember that, amido. But same time if I write N3H, hydrozoic acid, so N3 single negative, azido. Azido. These are confusing names, so get command on these, right kids? These holds have a lot of weightage. Are you getting my point, kids? Do let me know if you're getting it. Everyone just do let me know. Green hearts I want to see, kids. If everyone is able to understand, Baba want to see green hearts. Kids, if you are really getting it and really your doubts are getting cleared, Baba wanna see green hearts, kids. Very good, very good, very good, very good. Nitridone. Okay, yeah, this one is wrong. Amido is wrong. This is wrong. This I have written wrong. It's nitrite, nitrido. This I have written wrong. See, nitrido. It should be nitrite, nitrite, nitrido, nitrido. Sorry, kids. This I have written wrong. It's not amido, nitrido. Everyone make a correction. This I have written wrong because see, ammonia. When 3 hydrogens are leaving, this was nitrido, okay, and this is like hydrozoic acid. From hydrozoic acid you will get azido, azide, azido. Do correction, make a correction, kids. That was nitrido, nitrido. Now you will say, what is nitrito and nitrato? Just see, nitrito and nitrato. If I write down NO3 negative and NO2 negative, this is nitrite. Just see, nitrite. This is nitrate. So just remove, you will get nitrito and nitrato, nitrato. I hope that everyone is getting familiar with all these concepts. all these concepts kids. Now, one ligand exists in two forms, NO, NO plus, neutral. Generally it will be neutral, generally neutral, but one place it will act as positively charged. Its name is nitrosonium ion, nitrosonium ion. Can you let me know where it acts as positively charged? This act as positively charged in Brown ring test. Brown ring test is FeNOSO4. Do you remember FeNOSO4? This is Brown ring test. In Brown ring test, both the iron acts as an +1. Iron oxidation is +1 and its oxidation state is also +1. Remember that. Brown ring test. The formula Brown ring is correct. Just to let me know, Brown ring formula is correct or wrong. Do let me know in the chat section. Yeah, I'm going to give you a break. So kids, now it's 14:10, 2:10. So after break, I will start IUPAC nomenclature. So 2:10 to what time kids? Yes, break time. What should be keep break time kids? Just to let me know. I will talk to you after the break, but let's make it 2:15. For 3 to 4 minutes I will talk to you. 2:15 to 3. 2:55, okay? 2:55 p.m. After break, we will start what? Do let me know. After break, we will start what? IUPAC. IUPAC, right? We will start. Oh, what is this? IUPAC. So it's my humble request to come with ATPs. So humble request to come with what? To come with lot of ATPs. Lot of ATPs. Right kids, it's a humble request to come with lot of ATPs. Will you follow that? Everyone just do let me know. Will you follow what Baba is saying, what Baba is requesting? Kids, do let me know. Make a promise. Everyone just make a promise. And tell everyone how much hard work Baba is doing, kids. After having lunch, tell everyone to follow this. Okay kids, okay. Hello. Hey everyone. I'm 2 to 3 minutes or 5 minutes got late, kids. If everyone you can hear me, can see me, just to let me know. I'm sorry for late, kids. Baba is always very punctual towards each and everything. This first time I got late. Let me see, kids, are you there? If you can hear me, can see me, just to let me know in the chat section. I want to see green signal. Everyone, kids, everyone, I want to see green signal so that I can start with IUPAC. Everyone, hey, bacha party, my all dear students. Let me see in the comment section. Lot of ATPs. Madhu, light blight. Wow, great name. Gautami, Ananya, Vidya. That's really awesome. That's really. And those who are new, just smash the like button to show your. Make it 400. At least make it 400. So that let's go on. Let's move here. Let's move here. Let's move here. Hi. Let's move here. Let me take a new one, new slide with new color. So which color should I take? Okay, let me take on this color, this color, this color, this color. Which color? This color is fantastic. So next slide of the IUPAC with this color slide. This is for IUPAC, and let's move on. So show me fire if you're ready. Everyone, if you're ready, I want to see fire in the chat section. IUPAC, this slide is going to deal with IUPAC of compounds. So let me write down IUPAC. Okay, ready? Oh my God, really awesome, kids. I can understand each and everything. These signals speaks a lot about, sometimes silence speaks better than the words. That's really awesome. I can see everyone's love and support. That's really fantastic. Now, complexes are of three types. I would like to say complexes are of three types. Three types of complexes. Just see. Just remember one thing. If I write salt, the common salt which you see, that the table salt, this is our table salt. Just do let me know what's the name of table salt that you know. NaCl. You know this normal salt, NaCl. First one is cationic part and the second one is anionic. Am I right, kids? Am I right? This one is cationic entity and that one is anionic entity. Is that clear? Now, suppose if I write complex compound K4 Fe CN whole 6. Now, this part is complex. And this is counter ion. Now, these are two different areas. This area is different, that area is different. These two are different areas. So this is your cationic part. So your complex is what? This complex will become anionic. So the complex is anionic. Is that clear? Now, this is the first type. Now, if I draw the second type, CO ammonia whole 6 Cl3. Just see Cl3. This complex is the cationic part. First one is cationic, whatever is present at first cationic, and that is anionic. So complex has become what? Cationic complex. Complex is anionic. Complex is cationic complex, and this is being anionic complex. Am I right, kids? This is being second type. This was the first type. This is second type, and the third type. Just see the third type. Ag ammonia whole twice. Ag CN whole twice. Now what you will say, kids? What you will say? The first one is cationics. That means both are being complex. Cationic complex as well as anionic complex, both the complex, that cationic as well as anionic. These are the three type of complex compounds. So here the complex is anionic, here the complex is cationic, here the complex first is cationic, another one is anionic. Is it clear? Do let me know, kids. If it is clear, I want to see green hearts in the chat section. Let me check it out. If it is clear to each and every one, kids. No, it will not end at 11 p.m. Let me complete 2 chapters, coordination chemistry and then DNF. So it will get completed near about 8 p.m. Somewhat 7 to 8 p.m. like that. It will not go that long. 2 chapters are there. These holds have a lot of weightage. So this much type. Now, how to write down their names? So let me consider first the first one, that anionic complex. Let me tell you how to do the nomenclature of anionic complex. So this is, I'm going to write anionic complex naming. What I'm going to write? Anionic complex naming. Okay, right? Anionic complex naming. Now see, anionic complex naming. Anionic complex naming. Okay, kids? So see, just see everyone. K4 FeCN6. K4 FeCN whole 6. Now, before writing the name, if you want to prepare some vegetable like chola bhatura, veg biryani, mutton biryani, chicken biryani, then things must be prepared. That means you need, if you want to prepare veg biryani, so vegetables should be chopped, washed, dried, and like that. So things should be prepared. So let's prepare the things, then only we can write down the name. The first preparation is that this element's oxidation state we should know. We should know the oxidation state of central metal atom. First thing is that we should know oxidation state. First thing is oxidation state we should know. So how to find out? Potassium, we know that one potassium is having 1 plus charge. 1 plus charge is on potassium. So 4 potassium. So 4 into 1. Let us suppose this is X. One cyanide. Cyanide is having 1 negative charge. How to find out 1 negative charge? You can see HCN, hydrocyanic acid. It has donated its proton. It's like this. So cyanide is having 1 negative charge. So how many cyanide? 6. So 6 into -1. And this compound is neutral. It is being neutral compound. Is it clear? Neutral Neutral compound means 0. So what is the oxidation state? X is equal to 6 minus 4, that is plus 2. So the oxidation state must be written in Roman numbers. Roman means if this is Fe plus 2, this will be written as 2 like this, Roman. Just you was studying in your school, just remember 7th A, 7th B. So this is a Roman. First preparation you have done. Now you can find out its name easily. Just see how and what should be the name. K4 FeCN whole 6. Now the second thing, first thing was you have done preparation, oxidation number you got, oxidation number. Second, the official name of that central metal atom, official name, you know. Suppose if I Champa is name given by Auntie Ji, but Champa's official name is Shalini Singh, Dr. Shalini Singh. This is the official name, and Champa is, you know, nickname. So nickname is iron. You see, Fe has nothing to do with iron. That is the nickname. So find out official name of metal, and remember that whenever the complex is anionic, in case of anionic complex, the name will have 8. That means its name will be ferrate. Actually it is ferrum. Ferrate. 8 should be added. 8 must be added whenever the complex is anionic complex. The name of central metal atom will be ending with 8. Remember that, 8, and then its oxidation state. 8 and then its oxidation state. Till now I haven't done the nomenclature. These 2 points are clear. The official name of that atom, like gold, Au is gold, gold is aurum, aurate. I will tell you each and everything, everyone's names, those who are required, right? Now if this much is clear, now one more thing you should know. K4FeCN whole 6. This is one entity, and that is another entity. These are 2 entities, but this central metal atom says ligand's name must be followed. First we'll write the cationic part, whatever the cationic part's name plus ligand's name, and if different ligands, in case of different ligands, then alphabetical order. In case of different types of ligands, then in alphabetical order. Names will be written in alphabetical order. This much. Cationic part, ligand, and then central metal atom plus 8 and plus oxidation state. Got it? Cationic part, ligand, central metal plus 8 plus oxidation state. Now I am going to write down its name. Just see, this is the order, this is the way. Is it clear? If it is clear, then I want to see green hearts. Kids, I'm telling you in a very systematic manner. If this much is clear, I want to see green hearts. Then only I will write down the name. Yeah, many people, they have written the correct name, but what I'm saying, kids, what I'm saying. Alright, kids, hit the like button, smash the like button, make it 400. At least make it 400, kids. What are you doing? So, K4 Fe Cn whole 6. So first letter will be capital. First letter will be capital. Potassium, this number will not be indicated. No need to mention this number. This number, no need to mention this number. No need to mention this number, right? Now, how will you get this number? That I will tell you, okay? How will you get that number? I will let you know. Now, potassium, hexacyano, no gap will be there. Hexacyano, ferrate 2. Those who got their answer correct, do let me know. If your answer is like this, do let me know, kids. If you have got this answer, do let me know. Everyone, if you have got this answer, do let me know. Those who got this answer, do let me know that your answer is correct. Let me see the chat section. If your answer is correct, I will be the most happiest person on this earth. Cyanido, yeah. Either you can write cyano or cyanido. Either cyano or cyanido, both are correct. Cyano or cyanido, both are equally correct. Okay. Now, one I am going to give you. One you are supposed to do it. Just do it. K3 Fe Cn whole 6. Write down. Let me check it out. Whether your answer is right or wrong. Write down. Potassium hexacyano ferrate 3. If your answer is correct, show me green hearts. If you got wrong answer, then fire. Then fire. If your answer is correct, show me green hearts. If your answer gone wrong, then fire. Now another one. K4 Fe Cn2 Cl Br I2. Now what should be the name? Just check it out. Potassium bromo या bromido chlorido chlorocyano. Okay, dicyano या dicyanido diiodido ferrate 2. Just check it out, kids. Just check it out. It's right or wrong, yours or mine. If both are getting matched, then both of us are correct, otherwise wrong. If the answer is coming same, then both of us are correct. Do let me know. Vishesh Sharma, welcome Vishesh. Do let me know, kids. Everyone just do let me know. Everyone just do let me know. And make it 400. Ditri will not be considered in the name. Remember that. Let me tell you. Note. Di, tri, tetra, even bis. Bis is also not included. If I talk about organic chemistry, in organic chemistry IUPAC naming, bis was considered in the alphabetical order, but here bis will not be considered in the alphabetical order. Will not be considered in the alphabetical order. Got it, kids? This anionic complex part is clear to each and everyone. Just to let me know if it is clear. If it is very much clear, then I will move ahead towards cationic complex. Now Baba is going to move towards cationic complex. Just see, after anionic complex, let's see the nomenclature of anionic complex. Cationic. Now let's move towards anionic complex naming. Anionic complex. Oh, sorry. Anionic complex already we have done. Cationic complex. Okay. Cationic complex naming. Cationic complex naming. Now see kids. If I write compound like this, if I write down compound like this, CO ammonia whole 6 Cl3. Now kids, anion is saying I am on the first position. You know 8, when to 8. Let me tell you the story so that you can remember. Otherwise, most of the people you will forget when to add 8, when not to add 8. If anyone, you know, if there is, suppose there is, let me tell you, there is, suppose Pandu is there. You know Pandu? Pandu. Mr. Pandu. Mr. Pandu. Mr. Pandu was always thinking I am this and that. But Pandu died. Pandu died. Pandu died. Now, what will you say? Mr. Pandu or what? Late Pandu. Late Pandu. Am I right? Late Pandu. So, in case of human beings, once somebody is dead, we say late. Now, in case of chemicals, these complex compound, if they are coming on second position, we will say 8. Now see, if I talk about anionic complex, this was on the first position, he was on the first position, and this was on the second position. So the center metal atom king was saying, hey, just add 8 after my name. Human beings are adding 8 just before the name, and chemicals are adding 8 after the name. So he was on second position, he got second rank. Oh, just add 8 after my name. But if the complex is coming on the first position, this complex is coming on the first position, so he will say, oh, I am the first. So don't add 8. Don't add 8. Do not add 8 after my name. Simply the name, and this name can be official or it can be nickname. Whatever you want to write, you can write. Now see the difference. Their official name and then 8. Whenever somebody is going to make certificate, then official name 8, then its oxidation state. In the earlier one, certificate, official name plus 8 along with oxidation state. But here, do not add 8. Name can be official or nick. Both are correct. Both will be correct. Are you getting my point? Both will be correct. Is this point clear to all of you, my dear students? Now, let me tell you the name. How to write down. See, CO ammonia whole 6 Cl3. So how to write down the name? Now ligand's name. First ligand's name, then central metal atom, oxidation state in Roman, plus anionic, primary valency. You know primary valency? This number is not indicated number. No need to write down this number. No need to write primary valencies number, right? Now see how to write down its IUPAC. Tell me. Hexaamine, double M, remember that, double M, hexaamine cobalt, not cobaltate, cobalt. Now how to find out the oxidation state? Just see. X plus 6 into 0 minus, or you can say 3 plus 3 into minus 1 is equal to 0. So X is equal to plus 3. Got it? Plus 3. So cobalt 3 chloride. I hope everyone got it. Just do let me know in the chat section. Let me see. Let me sit in front of screen and to try to find out everyone. Everyone, you got it or not? Just to let me know, kids. Everyone. Just to let me know, kids. Do let me know, kids. Everyone got it? Just a second, kids. Just a second. Just a second. Beta. Okay, kids. So you got it. Everyone got it. Everyone got it. Now, the third one. But in this, let me tell you some more complexes. Just see if the complex is given like this. If it is given like this, suppose COEN whole thrice Cl3. Now how will you? It is ethylene diamine. This ligand is already having di name, so we cannot use tri or di. How to do the name? Just see. Tris ethylene diamine tris ethylene diamine cobalt 3 chloride. Is it clear, kids? Just to let me know, is it clear? Because already its name is having di. So suppose if I give you another compound like this, COEN whole twice ammonia whole twice Cl3. How will you do the nomenclature? Then you will write diamine bis ethylene diamine cobalt 3 chloride. Am I right or not, kids? Am I right or wrong? Do let me know if you got it. If your name is matching with my name, then I want to see green hearts or fire if you are not able to understand. If you are, oh, very good. Tris ethane 1,2-diamine also is correct. That is also correct. Very good, kids. Well going. Fantastic. Kids, do let me know. If you are able to understand, do let me know, kids. Do let me know, everyone. Very good. Now see, kids. Now, third type of complex, I would like to say the third type of complex. Just see, third type of complex. Complex is cationic plus anionic, right? Now, for example, if I write down like this, Ag NH3 whole twice, Ag Cn whole twice. Now see kids, everyone just see. First thing is that how to find out the oxidation state. So see, this is X plus 2 into 0 plus X plus 2 into minus 1, and whole compound there is 0, no charge. So X and X will become 2X minus 2 is equal to 0. So 2X is equal to 2. So X is equal to plus 1. Distribute. Both oxidation state are plus 1 plus 1. Now see kids, this is the cationic one. First one is the cationic and second one is anionic, whose name will be written as 8. Its name, official name plus 8. Its official name plus 8, and its any name, simple name, right kids? Simple name, you are supposed to write down simple name, that's it. So it will be diamine silver 1 dicyanide argentate 1. I hope this is clear to each and everyone. If it is clear, do let me know in the chat section. If it is clear, I want to see that my kids are able to understand or not. Kids, do let me know if you are able to understand. Show me green hearts if you really got it, kids. If you have really understood, I want to see green hearts. Diamine silver 1 dicyanide argentate 1. Very good, very good, very good. Madhu, Rohita, fantastic, fantastic kids, really fantastic. Wow, Abhinay, Arpana, Roshita, Rashagnya, Anil Kumar, very good. Now this point is clear. So let me show you NCERT. Let me now show you. It's a time to show you NCERT, that once you got it, now time to show you NCERT. Just see. Now see everyone. See everyone. See everyone kids. See everyone. Once you are able to understand, now let's see nomenclature from here. Nomenclature starting, and let's do the questions directly. If you are able to understand, then you will be able to do the questions also. See, now tell me first of all, this complex is cationic or anionic? Do let me know, this complex is cationic or anionic? The first one is cationic and then anion. So cationic, this is on number 1, the cationic. So its simply name will be normal name. So this is aqua, this is amine, triamine. Now first letter is small, it's okay. If 4 options are given and all the 4 options name are starting with small letters, then also okay, right? But the in between, after this, all the letters will be small, right? The first letter can be small or capital, doesn't matter. Triamine, triaqua, chromium. See, chromium, not chromiumate. It's chromium. 3 and chloride. Is this first one is clear, kids? Do let me know. If this first name is clear to each and everyone, I want to see green hearts. Kids, if you got it, do let me know in the chat section. This is win-win position. If it is looking easy peasy lemon squeezy, I want to see green hearts kids in the chat section. Everyone kids. Now the second one, let's see the second one. Now see the second one. It is ethylene diamine, you can say, and it is di 2 times and sulfate. Okay, so 2 times ethylene diamine. Okay, or you can write ethane 1,2-diamine. So see 2 times. So 2 times or 3 times. So see, leave that, it's 3 times. So we'll write tris. We'll write tris ethane 1,2-diamine cobalt 3 sulfate. Is it clear? Tris 3 times, right? Now another one. Now see what I was teaching you. Just see to it. Ag, same compound, diamine silver 1 dicyanide argentate 1. See kids, are you able to understand or not this one? Do let me know. This one is clear, kids. Clear. The same complex you got of NCERT. Let the chat running if you are really liking it. Let the chat running, kids. Now see, kids. So see these names. Let's check it out. I will also do, and I will also check myself. This is cationic. This is chloro. This is nitrito, and this is diamine. So its name will be diamine chlorido nitrito N. Why nitrito N? That holds a lot of weightage. See, nitrito N. See, this is central metal atom, and who is pointing toward this side, nitrogen or oxygen? Nitrogen is more closer to this platinum. Nitrogen. If it has been written like this ONO, then I would have written nitrito N, but see, nitrogen is pointing with metal, so we will write nitrito N, and this is capital letter because it stands for metal element. It is indicating element, and that's why its name is letter with capital letters. Clear, kids? Let me have some tea, kids. Everyone, is it clear? Now this is tough one because the complex is on second number, so its name will have 8. Potassium trioxalato. Now one oxalate is having 2 negative charge, so its oxidation state will be 3 into 1 plus X, and this is 3 plus 3 into minus 2 because one oxalate is having minus 2. So check it out. X will have plus 3. So chromate 3. Potassium trioxalato chromate 3. So 2 are clear to all of you. Now see this one, COClEN2 ethylene diamine and chlorido. So this will come first, dichlorido, and this is, I think this is not full one. Now see, yeah, now this is on number 1. So dichlorido bis ethylene diamine cobalt, now 3, cobalt 3 and chloride, cobalt 3 chloride. So dichlorido bis ethane 1,2-diamine or ethylene diamine, you can write cobalt 3 chloride. I think this is clear. All these are clear to all of you kids. Just to let me know everything is clear or not. If all these names are clear, just show me green signal in the chat section so that I can move ahead. Wow, Arpit Shantia. Hello sir, I am here from Unacademy IT JEE. Oh ho, tell everyone to show me some fire in the chat section. Everyone from Jaipur Center, everyone come on. Hit the like button, kids, now. Now, after this IUPAC, let's see what is there in NCERT. After this IUPAC, let's see what is there in NCERT. Okay, kids? Isomerism. After this, how they can start isomerism? I can't understand after IUPAC how they can start isomerism. No, they should not start isomerism. After this, we have to go with something else. Then we will come to isomerism. Let me check it out. Valence bond theory. Now, how many of you are ready for the valence bond theory? I will teach from my side, then we will come to NCERT. If everyone is ready, I want to see some fire in the chat section. Yes, if everyone is ready, let's move here with valence bond theory. Everyone is ready for the valence bond theory? Before I start valence bond theory, let me tell you something, kids. Before I start valence bond theory, let me tell you something. What's that? What's that? Valence bond theory. Kids, this you must have studied in your inorganic chemistry, but I'm going to tell you in detail, okay, the valence bond theory. And just to understand this theory, we should know one thing. What's that? To understand the hybridization, and to get all correct answers, and to get all correct answers, you have to move according to me. First of all, tell me how many of you are getting stuck in hybridization. Sometimes it's coming correct and sometimes it's coming wrong. If it is like that, you have to show me some fire in the chat section. I will tell you, first of all, we should have good command on spectrochemical series. And second thing we should know, this is the first point. The second point, we should know D block elements. We should have knowledge of D block elements. Are you ready? Everyone, are you ready? So first of all, Baba will start with the spectrochemical series, and you have to remember the trick for spectrochemical series, and I'm going to give you the trick for spectrochemical series. Just see, kids, everyone just see. Baba is going to give you trick for spectrochemical series. Everyone ready? Is everyone ready for the spectrochemical series? You have to sing along with me whatever Baba is going to sing. I'm going to give you a trick for a spectrochemical series. Spectrochemical series experimentally determined its trick. Baba HSP's trick. With this trick, you can find out hybridization as well as the color of any compound. This will help you to find out. will help to find out two things. We'll have to find out two things. What are these two things? First, hybridization. Second, the color of any complex compound. These two things. Okay, kids. So my focus will be in next 1 hour. My focus will be in these two things. Are you ready? Let me check it out. The chat section. What you people are saying? Everyone ready? Wow, Abhinay. That's really awesome that you kids are able to understand each and everything. Wow, that's really fantastic. Wow, great. Number of students are from G3 batch. Tell everyone, G3 batch students, to smash the like button. Tell everyone, G3 batch students, tell everyone to hit the like button. Now see, kids, what is the series? What's the series is? Yes, let's move here. Spectrochemical series. Let's see. First line elements are I negative, weak field ligand, Br negative, SCN negative, chloride negative, sulfide negative. This is the first line. This is the first line, kids. I would like to say first line. This is the order in which the strength of ligands is increasing. Strength of ligands is increasing. Ligands strength is increasing. This is the weakest ligand. This one is the weakest ligand. They all are weak ligands, first line. Now the second line, let me write down first. The second line, F negative, OH negative, oxalate. What is oxalate? C2O4, 2 negative, water, and NCS. This is SCN, this is NCS. So it's moving like this, in this way, and the arrow is like this. All these two lines, they are of weak field ligand. All they are weak field ligand. Remember that. What I'm teaching you, just remember that they are known as weak field ligand. WFL, just keep it in your brain. WFL, weak field ligand. Just put it in your brain, weak field ligand. And the last line, last but not the least, this is strong field ligand, which I am going to draw. That is EDTA, ammonia, EN, CN negative, CO. This line is of strong field ligand, SFL, strong field ligand, and it's increasing like this. So some spaces I have left. First, let me give you the trick for this. Then why the spaces has been left, that I will tell you, because some ligands are missing and they have been given in Tamil Nadu State Board. But first of all, I would like to tell you the trick for this. Should I tell you? See, Indian bro Sachin's child Sara. Indian bro Sachin's child Sara. Sara is the name of Sachin's daughter. First line, Indian bro Sachin's child Sara. Everyone say Indian bro Sachin's child Sara. Let me check it out. You are writing or not? Indian bro Sachin's child Sarah. Everyone just repeat. And if you're liking, smash the like button. Indian bro, Sachin's child Sarah. Everyone write down in the chat section. Then only I will tell you the trick. Indian bro, Sachin's child Sarah. Everyone just say Indian bros, Indian bro. Indian bro, Sachin's child Sarah. Everyone just say, repeat it. Indian bro, Sachin's child Sarah. If everyone is repeating, then only I will tell you the trick. Indian bro, Sachin's child Sarah. Let me write down over here. Indian bro, iron bro. Indian bro, Sachin's child Sarah. Let me write down. Indian bro, I am also writing, you also write. Write down Indian bro, Sachin's child Sarah. Have you written? Indian bro, Sachin's child Sarah. Have you written, kids? Indian bro, Sachin's child Sarah. Everyone, I want to see the number of students, those who are present over here. They are supposed to write down, then only I am going to tell you the next one. Indian bro, Sachin's child Sarah. And try to dissolve it in your brain as well as blood. It should get dissolved in the blood. Indian bro, Sachin's child Sarah. 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 Now see, is fond of oxalate and water in nachos. Is fond of oxalate along with water and nachos. Is fond of oxalate in water with nachos. NCS, nachos. Is fond of oxalate in water with nachos. Nachos, see, this is Sachin, this is nachos. Nachos, you know, nachos is fond of this and that with nachos. Everyone write down nachos. Indian bro, Sachin's child Sarah is fond of oxalate in water with nachos. If this much is clear, then only Baba will move ahead. If this much is clear, then only Baba is going to move ahead. Everyone fond of oxalate in water with nature. Wow, nachos or nature. Nachos is the best because everything is coming over there. Nachos. Now, the third line of strong field ligand, educated. Hey, educated. Educated. EDTA is educated Neha. Educated Neha is teaching English. Educated Neha is teaching English in Canada and Colombia. Canada and Colombia. Educated Neha is teaching English in Canada and Colombia. Canada and Colombia. So this is strong field ligand. Educated Neha is teaching English in Canada and Colombia. After this. This is the line of strong field ligand. Now, number of questions must be coming in your brain. I will solve each and every question. The spectrochemical series, whatever I have told you, requires lot of knowledge. More and more I have to explore it, but I will explore it once you say 3 lines are clear. They have gone to your hippocampus or not. Let me see in the chat section. If all the 3 lines they have gone to your hippocampus, then only. Wow, DJ Tillu. But see kids, now I will explore it. I will tell you something more once this is clear. If this is clear, then do let me know kids. If this much is clear, then only Baba is going to tell you. Show me green hearts if till now it is clear, if it has gone to your brain. If this has gone to your brain kids, then I will let you know more and more. More and more I will let you know. Very good, very good, very good. Smash the like button, smash the like button. If you are really liking it, smash the like button, hit the like button kids. Now see, let me tell you something more about it. See kids, see, now see kids, see, first of all I will write down whatever I have told you in the starting, that I will write down. Indian bro Sachin's, everyone repeat along with me, Sachin's child Sarah. Okay, now in this I will add something. I will add something. That added one is nitrate. Nitrate, this I have added in the first line. This has been added. Okay, will you remember? Nitrate was not there, so I have added. This is given in Tamil Nadu board, Tamil Nadu state board. If you check Tamil Nadu state board, those who are from Tamil Nadu, they will get it that yeah, it's given over there, and examiner will definitely ask this. Am I right? Tamil Nadu state board students, you can check your NCERT. It must, your state board, it should be given over there. Now the second line, fond of oxalate. Urea is also given over here. Urea in Tamil Nadu state board, urea is given. Oxalate water with nachos. Okay, second line, I have told you second line kids. Now the third line, educated Neha is teaching English. Now here nitrite is given. This is very, very important. There nitrate, here nitrite. Canada and Colombia. Now see kids, this is missing your NCERT, and that's why I have told you that I will let you know. These 2 and 3 things, these 3 things are missing your NCERT, and they are given in Tamil Nadu state board, and that's why most of the time you are losing your marks, and teachers are shouting that everything will come from NCERT. No, how everything will come from NCERT? See, this is out of NCERT. These are weak field ligands, and this is strong field ligand. Now kids, till now if it is clear, if it is gone to your brain, just to let me know, then I will enhance it. I will add something more to this spectrochemical series. Once the spectrochemical series is very much clear, you can do everything. Now those who know English, their night is right, their night will become right. So how to remember? Indian bro Sachin's child Sarah. And this English, once you know English, your night will become right. You can do, you can teach, you can do whatever. Night will become right. Just a memory add. Night is right because of English. Night will become right because of English. Just a memory add. I'm going to tell you how to learn it. This is clear, kids? Now see. I'm going to give you the latest one, latest spectrochemical series, and what is that? Just see. Just see, kids. Indian bro Sachin's child Sarah nitrate, right? This is the first line. Second line. Yes, tell me. Tell me, kids. This is clear, kids. Is this point clear to all of you? Now see, kids, what I am going to tell you. Just see. I am saying these are weak field ligands. These are weak field ligands. These are weak field ligands. But remember that these two, which two? These two, oxalate and water, remember that, with cobalt 3 plus act as strong field ligand. Once again, let me tell you, these two ligands. Which two ligands? These two ligands, although they are being weak field ligands, but what I am talking about, with cobalt 3 plus, they will act as strong field ligand. This point, remember, mark my words. Categorically, I am telling you this particular point. If you want to get selection and for the this government seat, if you want to get rank, you should know this point, that with cobalt 3 plus, they will act as strong, although they are being weak field ligand, but with the cobalt 3 plus, these two will act as strong field ligand. And it's not completed. Now see, kids. EDTA ammonia, En nitrite, CnCO, all these are strong field ligands. All of these are what? These are strong field ligands. These are being, this line is for strong field ligands. Strong field ligands. But remember that this ammonia will act as, although these all are being strong field ligands, all of these are strong field ligand, the whole line is strong field ligand. With ammonia, with coffee man, CO2 plus, Fe2 plus, Mn2 plus, Ni2 plus. Ammonia also, although being a strong field ligand, but with these four, CO2 plus, Fe2 plus, Mn2 plus, nickel 2 plus, coffee man nickel will act as weak field ligand, I will give you the statement, but till now it's clear. If it is clear, do let me know, kids. See from where I have started and where I have gone. See, kids, from where the spectrochemical series I have started and where I have reached. Just see to it, kids. Kids, do let me know. Do let me know, everyone. Till now it's clear. Till now, is it clear? Thank you, Diya. Thank you, Madhu. Amita, thank you. Kids, really thanks. But now let me know, till now it's clear. Clear with each and everyone. Now, let me tell you some important points so that you can get full marks. Baba is teaching you for full marks. Just see. After this, first let me make it fair. Let me tell you in another page. Just see what I have written. Let me write down the first point. First point. Although C2O4 2 negative oxalate and water are weak field ligands, are generally weak field. Why to write generally when I am writing with whom or whom not? Are weak field ligands. WFL, WFL. But with cobalt 3 plus, what I am writing, cobalt 3 plus, C2O4 2 negative, and water will act as strong field ligand. Now how to remember it? You know, cobalt 3 plus, you have seen Om, Shiv, he is having cobra and trishul, and this is oxalate, Nandi, Gaia, and this is water, Ganga. By seeing cobra and trishul, Nandi and ox, they have become safal. Other words, they were bifal. This is the trick. Trick is what? You know, ox is bifal, weak. But once ox is with cobra and trishul, Shiv, Om Shivoy Nama, you know, Shiv, that destroyed Vinashak, you know, Shiv, Bhagwan, God Shiv. So his cobra and trishul, by seeing cobra and trishul, Nandi, who is Nandi? Ox is known as Nandi. Nandi and Ganga, they have become safal. This is the trick. Cobra, Trishul, Tridev's cobra. By seeing Tridev's cobra, Nandi and Ganga, they have become safal. Otherwise, they were bifal. How's the trick? By seeing Tridev's cobra, water and oxalate, they have become safal. Thank you, Dhanya Santosh. Thank you, Dhanya Santosh, for liking this much. Kids, what happened to you? You are getting it or not? The trick is, I have told you the trick. By seeing Tridev's cobra. So the trick is, what is the trick? Trick is, Baba HSP's trick. What is the trick? By seeing Tridev's cobra, what is that? Cobalt 3 plus. By seeing Tridev's cobra, the weaker water and oxalate have become stronger, have become stronger. Now you are able to understand they were weaker with everyone, but by seeing Tridev's cobra, they have become stronger. That means always remember that these two ligands will act as strong field ligand with cobalt 3+. One thing is clear. Now the second trick, by seeing, first let me write down, ammonia act as strong field ligand with most of the ions, but ammonia will act as weak field ligand with coffee man nickel, What is that? But remember that their charge must be 2+. Coffee man nickel. Is it clear to all of you? These 2 points. The first point, this was the first point. This is the second point, and I'm going to tell you the third point. All ligands with 4D and 5D transition series (4D) lies in where? 4D belongs to 5th period and this belongs to 6th period, right? In long form of periodic table. All ligands with 4D and 5D transition metals will always act as strong field ligand. Remember that. Now these 3 points holds a hell lot of weightage. Remember that. So these 3 points, if you remember, your coordination chemistry will become rocking. Kids, do let me know. Thank you, Charan Yadla. But kids, you are not consistent. If you are not consistent, no one can give you rank, kids. You have to be consistent, kids. You have to show your consistency. Kids, first of all, make a promise. First of all, everyone make a promise. This type of content, because this type of content you will never get anywhere, kids. Why the strength is not remaining consistent? I am giving you golden notes. Nowhere you will get these type of notes, kids. First of all, make a promise that you have to show your dedication. You have not to become rabbit. You have to become, not to become tortoise. You have to become revoice. Rabbit and tortoise, hybrid species, entity. Your hard work, your consistency should be like tortoise and your speed should maintain like rabbit. So be wise, just revise like revoice, which means something made up of rabbit and tortoise. Revoice, kids. Make a promise. Let me see in the chat section, you are making a promise or not? Kids, this type of notes, this quality content you will never get anywhere. I will show you your all the questions are getting solved within fraction of seconds. I will show you, kids. Yes, very good. So call everyone, all your friends, kids. Very good. Now let me show you, kids. Hybridization in octahedral complex. Okay, hybridization. So see, if what I'm going to tell you, hybridization. Okay, everyone ready for the hybridization? So first we will see hybridization. BBT, we are studying right now valence bond theory. And valence bond theory is saying that the hybridization in octahedral complexes, right? Octahedral complex means coordination number will be octahedral complexes. Hybridization in octahedral complexes, right? Hybridization in octahedral complexes. And octahedral complexes means their steric number will be 6, and with 6 steric number, two possibilities are there. Either it will be D2sp3 or it will be sp3d2. This you have not studied in your what? In your chemical bonding, because you have studied only sp3d2. What is the difference in between these two? Let me tell you. Suppose if I say that S belongs to 4s, P is 4p and D is 3d, and there 4s, 4p and 4d. So can you see, if we consider S, so this is one orbital less, that means it is n minus 1d, so it is known as inner orbital complex. That means D is used one less, and that is known as outer orbital complex. Now kids, who will make inner orbital complex, who will make outer orbital complex, that I will tell you in detail. You are ready? Then show me some fire in the chat section. If with full on Josh, if you are ready, I want to see some fire in the chat section. Everyone. Now to understand it more clearly, we should know what? We should know one thing. What's that? We should know one thing. What's that? What's that thing? We should know one thing. What's that? We should know one thing, kids. What's that? We should know D line. What is that D line, kids? Have you ever heard D line? Have you ever heard D line? Have you ever heard D line? If I talk about fourth period element, potassium and calcium, fourth class का science teacher, very crazy man. Fourth class fourth class का. Science teacher very crazy man. Everyone say science teacher very crazy man. First of all, say everyone. Science teacher very crazy man. Science teacher very crazy man. Felt cold at night with cousin. Felt cold at night with cousin. Felt cold at night with cousin. Now, I would like to say that here D1, D2, it will go like this. You know that it is 4s2 is common everywhere. 4s2 is common, and it's 3d1, 3d2, 3d3, and 3d5, 4s1, right? 3d5, 4s2. Now everyone's here. You can say 3d10, 4s1, 3d10, 4s2. Now, how many of you are feeling difficulty in writing the configuration? First of all, do let me know how many of you feel difficulty in writing the configuration. Then I will solve it. I will solve it. Just see how to solve it. I will solve this problem also. Just see, kids. I'm a great teacher. I'm a great teacher. Now see, I will solve even this one also. First of all, sing a song. Science teacher, very crazy man. Felt cold in night with cousin. Felt cold in night with cousin. Now see, atomic number. If you remember the atomic number is 21. 22, 23, 24, 25, 26, 27, 28, 29, 30. There are two exceptional cases, so leave them. This is exceptional case, so leave it. 3d5, 4s1, and 3d10, 4s1. Leave them. Now just reverse these number. Except those, just reverse these number. 1, 2, 2, 2, 3, 2, 5, 2. Got it? 6, 2 like this, 7, 2 like this, 8, 2. You got it? Now see, any elements configuration you want to write. For example, scandium. So this is 2, leave it. 3d1, 4s2, leave it. 3d2, 4s2, leave it. 3d3, 4s2, leave it. 62, 3d6, 4s2, leave it. So this one, 3d8, 4s2, leave it. Got it? It has become simple or not? First of all, do let me know how to write speedily this thing. Then only you can get the actual zeal, actual knowledge. First of all, do let me know, kids. Now you tell me you're liking it, how the way I'm telling you, kids. The way I have told you, you're really liking it or not? Tell me, kids. Those who are really liking it, those who are really feeling confident. DIA, wow, amazing. Thank you, Maunika Baba. Chat is running very slow, kids. Why is like that? Okay, now let me show you. Now let me show you the hybridization. Once you know this thing, let me show you the hybridization, how to find out the hybridization. Just see. If I write K4 FeCN6, if I write down K4, first let me tell you the D line, information about D line. Okay, first D line will come later on. D line, let me tell you something about D line. D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. Now I have divided in three parts. Why I have divided in three parts, I will tell you, kids. First of all, see, I have divided in three parts. One part, second part, and third part, right? So see, if I talk about d orbital, d subshell, in how many parts it has been divided? How many orbitals d subshell is having? Just see, it is divided in 5 parts. Am I right? 1, 2, 3, 4 and 5. Am I right? Now if I say that if no electron is there, or 1 electron is there, or 2 electrons are there, 3 electrons are there, up to 3 electrons, these 2 orbitals, if I say this is of 3D, these 2 orbitals will always remain vacant. So the ligand will come, ligand will be having how many lone pairs? 6 lone pairs. So it will start filling from here only. So it will start always filling from here only. So the electrons will get filled like this. The 3D, then 4s, and then 4p. Am I right? So it will donate its lone pair like this. So D2sp3, always their hybridization, always their hybridization will come what? Always it will be D2sp3. Am I right or not? Whether the ligand is strong field ligand or weak field ligand, doesn't matter. That doesn't matter, ligand doesn't matter. Now if I talk about D7, D8, D9, 10, just see. If I say D7, so 1, 2, 3, 4, 5, 6, 7. If it is going to shift it over here, then also 2 orbitals will not be vacant. So it will always be sp3, because here filling will not take place. sp3 d2 always. So don't worry about those 4, don't worry about those 4, always worry for this. These will depend on the type of ligand. D2sp3 with the strong field ligand, I will explain, and sp3d2 with the weak field ligand. And ligands we know very well, so everything is sorted. I will explain it, but everything is sorted with D line. See, just check it out, everything is sorted. Now tell me, kids. Thank you. One kid is writing 650 plus is possible now. Thank you. Telegram, leave that, but focus on studies. I will let you know. But first of all, this part is clear, kids. I will explain. Once I explain, you will get a feel about it. Let me explain. Some kids are asking, sir, explain it. Let me explain this with the help of example. See, with the help of example, I will explain. See, kids, if I say 2 examples I am taking, K4 FeCN whole 6, one example. Second example, I am going to take K4 FeCl6. Okay, these 2 examples I have taken, A and B. Directly I can tell you its hybridization will come D2sp3 and its hybridization will come sp3d2. Now you will say, sir, how, sir? How you are telling us? How many of you want to get this command, this field? Write down in the chat section, show me green hearts if you want to get this command, that how to do it so fast. Yes. Now let me show you. K4 FeCN6. First of all, you should know iron. Central metal atom is iron. Iron's atomic number is 26. Write down 62. So 3d6, 4s2. But iron's oxidation state, just see. 4 into 1 plus x plus 6 into minus 1 is equal to 0. So x is equal to plus 2. It has lost 2 electrons. So ferrous, how I will write ferrous? I will write 3d6, 4 as 0, right? So 6, 4, 5, 6. Now 6 electrons I'm having of its own, 6 electrons, 1, 2, 3, 4 and 6. Now see 6 electrons, 1, 2, 3, 4, 5 and 6. But cyanide is strong field ligand or weak field ligand? Just to let me know. Is cyanide is strong field ligand or weak field ligand? Cyanide is strong field ligand. So under the influence of cyanide, under the influence of cyanide, the strong field ligand, cyanide will say, hey, I want to go closer to the nucleus of central metal atom. This is central metal atom and I want to go very close to the central metal atom's nucleus. Iron is mine. I want to approach up to the nucleus. I want to go towards iron's nucleus. Are you getting my point, kids? Everyone? So cyanide will say, hey, just go and shift, get shifted. So they will get shifted. They have to shift. Are you getting my point, kids? They have to shift. Just make it empty for me. So these 1, 2, 3, 4, 5, 6, they have to remain like this. So this will become empty. Who has done it? Strong field ligand. He will push. Hey, just go away. Iron is mine. Just go and get shifted. So they have shifted under the influence of cyanide. Now it's vacant. Now cyanide will start filling its electron over here. 2 lone pair. Now let me say here in the S, 4s, 2 electron and 4p, it's more lone pairs like this. So it has captured which one? See, D, 3d2, 4s1 and 4p3. So its hybridization has become D2 of 3d, S of 4s and P3 of 4p. Can you see? So D of inner one. So it is known as low orbital or inner orbital complex. That's why it is known as inner orbital complex. Are you getting my point? Low spin. And cyanide acting as hyper ligated complex. So I will say this complex is what type of complex? Inner orbital complex. Low spin complex, hyperligated, and no unpaired electron is there, so it is dimagnetic, because no unpaired electron, see, no unpaired electron, so dimagnetic. Now you will say, why this is dimagnetic, sir? Explain again. Let me explain. First of all, do let me know this thing is clear to each and everyone. Till now it is clear. Muhammad Irfan is saying, sir, I can't understand. Hey, what you are writing? You can't understand and teach faster. What type of student you are? Get see. Muhammad Irfan is writing, sir, I can't understand your teaching. Teach faster. Or I am teaching faster, or should I teach faster? What are you writing? What? What he is writing? Kids, can you understand what he is writing? He's a spammer. Thank you, Raja Ramu. Now see, kids, what should I write? The paramagnetic character formula is, how to find out magnetic character. Magnetic character means under root n into n plus 2 Bohr magneton. Where n is, this is paramagnetic character, n is equal to number of unpaired electrons, right? I hope this point is clear. Now, same thing if I write down like this, K4 FeCl6. Now see, kids, Fe2 plus we already know, 3d6 4s0, so let me write down it, 3d6 d 4s 4p and 4d, right? 4d. Now 1 2 3 4 5 1 1 2 1 2 3 4 5. Now see, 3d6 means it's 6 electrons, 1 2 3 4 5 6. Now chloride is weak field ligand. Do you think that chloride can shift? Chloride can't shift this electrons. Chloride being weak field ligand can't shift because its power is less, can't shift electrons. So it will say, okay, whatever the seats are remaining empty, I will start filling electrons from there only, because I am unable, I am not that strong, I cannot shift these electrons, so I will start filling from here. So 2 electrons, 2 2 2 2 2 2 2 2 2 1 2 3 4 5 6. So sp3 d2. Can you get it? So d is of 4s 4p 4d. That's why it is outer orbital complex. Now unpaired electrons, the value of n is equal to how much? 1 2 3 4. So Bohr magneton will be square root of under root n into n plus 2, 4 into 4 plus 2, 24. So whatever the value will come, Bohr magneton will come something 4 plus 4 point something. So 4 see, square of 5 is 5 5s are 25. So it is near about 4.9 something, 4.9 something will come out. Got it? Whatever the number of unpaired electrons, add point something. Number of electrons, whatever the number of unpaired electrons, point something, you add point something. Everyone got it? Paramagnetic. This complex is being paramagnetic in nature. Paramagnetic. It is being paramagnetic. Got it, kids? Everyone got it? Everyone got it? Just do let me know, kids. Everyone, just do let me know. Any doubt to anyone? First of all, do let me know, kids. Is it clear? Really clear, kids? Is it really clear, kids? Very good, very good. Now let me show you something. Very great example. See, very great example Baba is going to show you, where most of the even teachers are getting failed. I will show you that example. See, where teachers are getting failed. See, cobalt C2O4 3 negative. One is this, another one cobalt F6 3 negative. Can you directly find out their hybridization? Can you directly find out their hybridization? Can you? Now see, kids, they will have different hybridization. How to do it? Just see. Cobalt's atomic number is how much? Science teacher, very crazy man, felt cold. Iron is 26, so this is 27. So what I am supposed to write? 72. And 72 once I have written, so I will write 3d7 4s2. But cobalt is in 3 oxidation state. Why? X plus 3 into minus 2 bidentate ligand is equal to minus 3. So X is equal to plus 3. So this is cobalt 3 plus, am I right? Cobalt 3 plus 2 electrons I have removed from here and 1 from here. So it is 3d6 4s0. Once again it is the part of 3d6. Now with the strong field ligand D2sp3, weak field ligand sp3d2, with the cobalt 3 plus cobra, Tridip's cobra, ox has become strong field ligand. So strong field ligand, so it is D2sp3, D2sp3, and this is weak field ligand, so sp3d2. I have solved it immediately. If you are able to understand, then do let me know, otherwise I will solve it in detail. I will go in detail, and if you got it, now see, this is acting as strong field ligand with this, and this is acting as weak field ligand just with this. So it's so simple. If you got it, do let me know, otherwise I will solve it. It's the magic of spectrochemical series only. Muhammad Irfan is asking how to find out. Okay, oxidation state. Just see oxidation state. Let me tell you the oxidation state. First see oxalic acid. This is oxalic acid. It has donated 2 protons, so it has become like this, oxalate. So how much negative charge on oxalate? C2O4 2 negative, right? Now just see, CO C2O4, I have written like this, CO C2O4 thrice, I have written like this, and 3 negative. So see, I will say this is X plus 3 into 1 oxalate is having minus 2, and on the whole compound 3 negative, so 3 negative. X 3, 1 oxalate is having minus 2, you can see, and the whole compound is having 3 negative, so 3 negative. So X minus 6 is equal to minus 3. So X is equal to 6 minus 3. You got it, Irfan? Is this point clear? Just to let me know. Thank you, Jyoti Jain. Thank you. Really, thank you. Just to let me know. Now, everyone, this point is clear to each and everyone. Now, let me tell you one more important thing. Whenever Bohr magneton is given, whenever this is a note, whenever Bohr magneton is given, then how to find out number of unpaired electrons immediately. Just see, kids. Just see the trick, Baba's trick. Let me tell you the trick. Suppose if Bohr magneton value is given 5.92, then whatever the number given just before point, so the value of n will be 5. If the Bohr magneton value is given 2.73 like this, so the value of n will be 2. Bohr magneton value is given 4.90, so the value of n will be 4. You got it? Just before the point, whatever the value is given, that should be the value of Bohr magneton. Is it clear, kids? Do let me know. It's rocking. It's really a magic or not? Do let me know it's really a magic or not, kids. I want to see your comments in the chat section. If really good trick, then show me green hearts. Green to go. Go ahead. Kids, do let me know. Do let me know. Everyone got it. It's Baba's trick. Rashagnya Kanchi. Wow, thank you. Now, kids, now let me show you NCERT. Now it's a time to show you NCERT, right? Let's see NCERT. But before, okay, first I will show you the NCERT, then I will give you one compound which is really most studied compound, and then I will let you know. But first of all, let's see NCERT, what I have taught you. What's this? Okay, the valence bond theory. See, cobalt ammonia, first example, or any other example also given? No, they have not given. Just see, this is the first example. Just see, cobalt ammonia. Ammonia is strong field ligand or weak field ligand? Definitely ammonia is strong field ligand, so hybridization will come D2sp3. D2sp3 within fraction of seconds. Just see, its answer is what? Just see, kids, if you can see, if you are having NCERT, you can see in your NCERT also, the answer is given D2sp3 with all strong field ligands. How to find out ligand is strong field or weak field? What you are supposed to do to find out strong field ligand or weak field ligand? Just see spectrochemical series. Just see spectrochemical series and see inner orbital or low spin or spin paired complex. See, and if the same thing I am taking COF6, this is weak field ligand, you will see sp3d2. You will get sp3d2, kids. Am I right? See, the hybridization will be given as sp3. So see, misprinting is there. sp3d3 wrong. sp3d2 is correct. Is misprinting. See, kids, in NCERT also misprinting sp3d3. No, sp3d2 will be the answer. Outer orbital complex, high spin. Till now it's clear. Till now it's clear. Now all the questions you can do in this way only. Nickel cyanide, each and every question you can do. And paramagnetic character, let me show you paramagnetic character also, whatever I have told you. See, they have shown that its Bohr magneton is 5.9 bm. Bohr magneton, predict the geometry of the complex. Definitely it will have 5 unpaired electrons. Now, if till now it is clear, then before moving towards limitation, I would like to explain one most important example. But before that, let's take a simple small break. Okay, Should we take or should I explain? Wow, Amita, should I explain or should we take one small break? Then we will deal with only 5 minutes break. Okay, explain. Yes, break, explain, explain. Maximum students are with explain. So they are liking what Baba is teaching. See, the most studied example is, let me show you most studied example. See, coordination number 4, square planar complex. Now with coordination number 4, two possibilities are there. It should be either tetrahedral or it will be square planar, right? Now if it is being found to be tetrahedral, then it will be sp3 hybridized, and here two possibilities are there, either dsp2 or sp2d, right? These two possibilities are there. And so let me move ahead with the same thing with the coordination number 4 and the most studied example, right? So Baba is going to take and consider that most studied example. Just see, kids, just see, everyone, see to it. Coordination number 4. Okay, now the example is CuNH3 whole 4 2 plus. You must have seen number of places that in organic chemistry Valence reagent, you must have seen in Valence reagent. If I talk about copper, atomic number 29, exceptional case 3d10, 4 as 1. So this is Cu2 plus, that is cupric, 2 electrons have gone, one from here, 3d9, 4 as 0, right? 3d9. Now let me draw 3d9, kids. 3d9, 4 as 0, 3d9, 4 as 0, 4 as 0, 4p and 4d also, 4d also. So let me draw it. 1, 2, 3, 4 and 5. SP1, 2 and 1, 2, 3, 4, 5. Now see, let me fill 2, 4, 6, 8, 9. So according to rules, ammonia can't shift them. So it will start filling 4 lone pairs from here. 4 lone pairs from here. Just see what I'm saying. Let me copy it because I need 2 copies, right? So let me copy it. Where you have gone? Yeah, here. Now it will start filling its 4 lone pairs from here. 1, 2, 3, 4. Oh my God, what is this? It's coming like sp3. It's coming like sp3. So according to hybridization, it is supposed to be tetrahedral. According to hybridization, its nature must be tetrahedral. But scientists, they have studied through spectroscopy that tetrahedral is wrong. Which is spectroscopy? Tetrahedrally spectroscopy. They have studied through X-ray crystallography and through spectroscopy. Its structure was found to be square planar. So this is wrong. Why? Experimentally they got what? Experimentally, which experiment they have done? Experimentally, that is through spectroscopy, the instrument spectrophotometer, spectroscopy. They have got its structure was found to be square planar. So only two options are possible. What are these two options? Either sp2d or dsp2. So this structure was found to be wrong. Then what they said, they said then one electron, this one electron, let's shift it to there. This electron, what happened? This electron should get shifted over here. Then what will happen? It will go from here. Now it will start filling its electron, 1 lone pair, 2 lone pair, 3 lone pair, 4 lone pair. Oh, where? It is only S now. What are you doing, sir? Sorry, this is only 1. 3D, 4S, 4P. Now, here and here, that electron, its electron has got shifted over here. So see, D, S, P2, the hybridization is DSP2. You got it? Kids got it? Its one electron has been shifted over there, and copper's nucleus is over here. Nucleus is present over here. Got it, kids? You got it? Everyone till now it's clear? Just to let me know in the chat section. Is it clear or not, kids? Do let me know, kids. Everyone do let me know. Do let me know, kids. Hurry up, show me the green signal. Break, I will give you after 5 minutes because till now it's not got completed. Now kids, after some time one scientist named as Huggins and its friends, the group of scientists et al., it is known as ETL et al., Huggins et al., main was the Huggins. He said, if this electron has gone too far away from the nucleus, it has shifted, it has gone so far away from the nucleus, so cupric should lose one electron easily. Are you getting my point? What Huggins et al. Said, if that electron has shifted that far away, so anyone can capture it from there, and Cu2 plus should get changed into Cu3 plus, but we know that this doesn't happen. So Huggins et al., according to Huggins et al., whenever the question is asked according to Huggins et al., if they are asking question according to Huggins et al., remember that. So if question is asked according to Huggins et al., see name, what type of name he is having. According to Huggins, oh my God, Huggins et al., this electron will remain over here. This will not shift. They will start filling from here sp2d, sp2d. According to Huggins et al., this is the hybridization. It's really amazing or not? It's really amazing or not? So both are correct. For its hybridization, sp2d or dsp2, both are being correct. Both are correct. dsp2 is also correct. sp2d is also correct. This is more correct. If they are giving both and they are asking for one, then this is more correct. Huggins et al. 1. Otherwise, both are correct. You got it, kids. Really, it's awesome example or not? Do let me know. So, kids, let's meet at 5:30. Okay. Okay, kids. Let's meet at 5:30 and then we will start color theory. I will tell you the amazing color theory. Okay. Let's meet at 5:30 and then I will tell you amazing color theory. Okay, kids, will you come with your friends if I'm really teaching very well? Okay, kids. Okay, say yes. Everyone say yes. You have to come with lot of energy, right? Along with your friends. Welcome back once again, my dear students. Very good evening. Just to let me know if I'm properly audible as well as visible to all of you. I want to see green signal in the chat section. Now, my dear students, I'm waiting for the signal that, yeah, 2-3 lines I have seen that I'm properly audible as well as visible. Now, to understand the color, this color, we should know crystal field theory. We have studied, first of all, I would like to say that we have studied valence bond theory. VBT, valence bond theory, we have seen. Now, to understand the color, to understand this color theory, color of any compound, if we are interested in color of any compound, to find out color of any compound, in between this VBT does not explain about the color. So, we should understand crystal field theory. So, this crystal field theory will give you the color. Are you getting my point? Thus, valence bond theory does not give any information about the color. No information about the color. This is not giving no information about the color. This is a drawback. So, if we want to find the color, we should know crystal field theory. We should understand crystal field theory. Crystal field theory. Now, let me show you in the NCERT what's the relation. These three are interrelated. Now, let me see whether you are there with lot of energy, everyone. Wow, Jyoti. Successfully shifted house. Oh my God. Mindman, Baba, you're looking awesome today. Thank you. Oh my God. Kids, nice comments. And Jyoti has shifted house also. Oh my God. That's so great. Looking great. Now, kids, I want to see the consistency. Whatever the number of students are sitting over there, Baba would like to see the A, B, C. A, B and the C. C is color. Now, let me show you the drawbacks of valence bond theory, or the shortcomings. Drawbacks. Okay. Now see the drawbacks. Limitations of valence bond theory. First, it involves a number of assumptions. Now, kids, you will say, sir, it's written over here that it involves a number of assumptions. Where they have involved number of assumptions? You might be the question. The first point, it involves a number of assumptions. This is the limitation, shortcoming or limitation. Limitations, shortcomings or drawbacks. Now you will say, sir, there was no limitation, but why they are talking like this? Kids, Baba has given you one spectrochemical series with those things, almighty things. That's why we have not assumed. Otherwise, once ammonia is acting as strong field ligand, other times it is acting as weak field ligand. Cobalt is acting as, with cobalt, 3 plus oxalate and water are acting as strong field ligand. With others, oxalate and water are acting as weak field ligands. These are the assumptions. But I made one spectrochemical series and I've told you each and everything over there. That's why they are not looking like that. Are you getting my point? Otherwise, before I have told you, you might getting confused all the time. That's why they are saying. Now, it does not give quantitative interpretation of magnetic data. It does not explain color. I have told you color theory To understand the color, we should know what crystal field theory, and does not give interpretation about thermodynamic stability of coordination compound, and it does not distinguish between weak field and strong field ligands. That's the theory given by me. That's why you have done all the questions. Otherwise, balance bond theory is not having that much of power so that you can solve all the questions. Are you getting my point? Now, crystal field theory. Now, crystal field theory, according to crystal field theory kits, I'm going to tell you the crystal field theory. Should I? Before telling you all these points, let me tell you crystal field theory according to my side. Crystal field theory. Let's start. Crystal field theory. Everyone ready, kids, for the crystal field theory? Do let me know. Crystal field theory. CFT. Crystal field theory. Now this is very, very important, kids. What is the full form? CFT. Crystal field theory. Just try to understand, kids. This holds a hell lot of weightage. Number of questions will come from here. Now, to understand this crystal field theory, first of all, I will talk about CFT in octahedral complexes. CFT in octahedral complexes. But before I start CFT in octahedral complex, let me talk about what CFT says. CFT says that if I talk about FeCN whole 6, 3 negative, right? This is central metal atom or central metal ion, metal atom or ion, and this is the ligand. It says that in between these two, the type of interaction, you know, the relation. Somebody is having brother, girlfriend, boyfriend, mother, father, sister, daughter. They are having what type of relation? So the relation is ionic bond. That is electrostatic force of attraction. Electrostatic force of attraction. Electrostatic force of attraction between these two, and they are treated as what? Point charges. These negatively charged ligands, are considered as point charges. Point charges and neutral ligands, suppose if they are present neutral ligands, they will be acting as dipoles. Neutral ligands will be acting as dipoles. They will be acting as dipoles. Now let's start. Let's it go. Let's move ya. Always study with joy. Enjoy your studies. Don't get nervous. Don't take it so seriously that your mind should stop working. Are you getting my point, everyone? I'm talking with you. Yeah, somebody is writing still single, Baba, no girlfriend. Make your studies to be your girlfriend or boyfriend. I do so. I'm married, I have kids, but then also my studies are my girlfriend. My first love is my studies. Remember that. Everyone, my studies are my girlfriend. My books are my girlfriend. They are my first love. In Hindi, there is one song. तू मेरे ख्यालों का पन्ना है वो जिसको मैं खोलूं जो कभी तो उसमें जाऊं खो दिन रात तेरी मोहब्बत में पागल से रहते हैं पढ़ने वाले भी मुझको पढ़ने वाला कहते हैं. Got it? Got it, kids? Got it? Everyone got it? Just do let me know. Just do let me know. Got it? Yeah. These are super awesome Veera level boyfriend or girlfriends. And that's why they are always tough to understand. Now see kids, crystal field theory. Now in octahedral complexes, if I talk about any octahedral complex, then its steric number will always be what? Its steric number will be 6. Right? Whether it is G2, sp3 or it is sp3, D2. Now let me tell you kids, if you want to understand this, you should understand 5 orbitals atomic structure. To understand this, we should have knowledge of what? To understand this, we should know 5d orbitals, space orientation. Now space orientation plus the ligand approach, if you are able to understand these two things, you can easily understand A and B point, right? So let's understand these two things so that we can get the clarity. Now see kids, if I write down 5d orbitals, I would like to say these are the 5d orbitals. Do you think these 5d orbitals are same? No, I would like to say they are not same. So I will divide these 5 like this. Just see how. 1, 2, 3, and these two are different. These two are being different. Just see why they are different. I will show you. Right now I will say they all are having same energy. If I draw the energy level, I would like to say the energy is like this. They all 5 are degenerated. All 5 orbitals have same energy. So the word is used degenerated. These are degenerated. Now if I go to atomic structure, its name is dxy, dyz, dzx. Now here we will call them, what we will call them I will tell you, but see, this is dx square minus y square and this is being dz square. Why they are different? Let's talk about these three are same. Same. Let me draw dxy. If I try to draw dxy, suppose if I say this is being x-axis this is being y-axis, then if I want to draw dxy, I will draw like this. In between x and y, dxy will be like this. Everyone satisfied? The lobes of one d orbital, this is dxy, I would like to say this is dxy, they are in between the axes. These are in between the axes. Clear? If I say this is yz, dyz, zx, I will say dzx. So all three are like same. The orbital lobes are lying in between the axes. Lobes are present in between axes. In between axes. Is it clear, kids? Is it clear? Do let me know first point. Let me see in the chat section. Is it clear to each and everyone? Thank you everyone. Abhinay, Manoj, Jen, everyone, kids. Do let me know first of all. Now if I talk about dx square y square, then see where it will lie, dx square y square. If I talk about dx square y square, then the lobes will lie, they will lie just on the axis. They will lie just on the axis. This is x-axis and this is y-axis. The lobes are lying exactly on the axis. Can you understand, kids? This is x-axis, this is y-axis. Lobes are lying directly on the axis. Lobes are on axis. And let me draw dz square. Just see dz square. Dz square. So this is z-axis. This is dz square, kids. This is dz square, my dear friends. This I would like to say it's dz square. Now it's fused over here. Two conical nodes, dz square. This is also lobes are on the axis. Can you see? Lobes are directly lying on the axis. So these are. So in octahedral complex we will give the names, but till now it's clear. Fast do let me know till now it's clear. They are directly lying on the axis. They are directly lying on the axis. Yeah, the Hoya siblings, they are more than enough. All the questions will get solved. I will show you all the previous year questions. Now I think this is clear. Now if I club all these orbitals, just see where they will be lying. Just it will become a little bit tough. It will become a little bit tough, but try to understand. Then only you will get the clear feel of this theory. You will get clear feel of this theory. So if I say that this is axis, this is x-axis, this is y-axis, and this is, if I say, z-axis. Okay, all three axes, x, y and z. Just try to understand the floor, your floor. If I say where to say, what to say, if I say this is your floor, this is your floor, this is your floor, this is x-axis, this is y-axis, and this upper one is z-axis. You can see the floor, your floor, just where the room you are seated, the room floor is x and y-axis, and the upper one, this one is going is z-axis. Can you just try to visualize, everyone? Are you visualizing? No, you are not able to visualize. Let me draw it in another way. Just see, if I say the floor. This is the floor. Let me draw the floor. Just see. I will try my level best to draw the floor. This is your room. This is your room's floor. This is your room's floor. Just try to understand, kids. I will try my level best. This is your room's floor. Can you get it? Room's floor. This is your room's floor where you are sitting. This is your room's floor. Are you getting my point? Room's floor. These are the tiles. I can say these are the tiles or the brick or the mud, whatever it's there. This is your floor. Are you getting my point, kids? Do let me know. Are you getting my point, kids? Do let me know. This is the floor. Are you getting my point? This is the floor. Or let me draw like this also. Tiles are there in your floor. Bricks are there. Bricks are there in your floor. So this is your floor. Just see, kids. Now can you get this is your floor? Floor, everyone. Now if I say, let me draw x-axis. So if I say this is x-axis, this is x-axis and this is y-axis. The floor is made up of two axes, x and y, x and y. If this much is clear, then only I will go towards any other axis. X-axis, y-axis. Is it clear, kids? Now I will say the thing which is going above this is your z-axis. I will say, hey, this is going z-axis. Can you see now? Z-axis. Now is it clear, kids? This is being z-axis. Are you getting my point, kids? Everyone, first of all, do let me know. Are you getting three axes clearly? Three axes clearly you are getting or not, kids? Do let me know. If yes, show me green hearts. Then only you can understand. First of all, do let me know. 3D diagram I have tried. I have tried to show you three axes. Just do let me know in the chat section, kids. Okay. Now see, let me show you five orbitals. Five orbitals. Now if I say this is dxy, this is dxy. So if I draw something dyz in between dyz, dzx like that only, okay? dxy, yz, zx only. Now before drawing any other, this is the metal without the ligands. All the 6 ligands to form octahedral complex, the ligands will come from which direction? Octahedral. This is the way through which ligands are bringing their electrons. This is the way which ligands will donate their electrons. This is the way through which ligands, suppose if I draw FeCN6 4 negative. So I will say this is iron located over here. This is the iron located at this position, I would like to say. This is the central metal atom located at this place, iron, and this is iron, and these ligands are coming from 4 ways. From 4 ways. What are those 4 ways? 1, 2 ligand is coming from here also to donate its lone pair. Are you getting my point? Ligand is coming from here also. 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 These are the 4th position, and ligand is coming directly from which position? These 2 positions also. Ligand is coming from here also, and ligand is coming from here also. These are the 6 positions. Ligands are with electrons, and electrons are negatively charged. Till now it's clear. Electrons, they are negatively charged. Now dxy, yz. Now let me draw. Till now is it clear or not? First of all, do let me know it is clear or not. Now let me tell you dx square y square. Dx square and y square will be lying over here. Metals dx square y square will be lying over here. Am I right, kids? And they are also having electrons. So who is feeling more repulsion? dxy is feeling more repulsion, or dx square y square is feeling more? They are colliding. This is metals electron, and this is ligands electron. Who are feeling more repulsion? Metal and ligands, they are coming head-on collapse, head-on repulsion. Are you getting my point? Direct repulsion they are feeling. Who is feeling direct repulsion from head-on, headshot? They are feeling dx square y square and ligand. And if I draw dz square will be like this. This is your dz square. It is also feeling repulsion directly. dz square is also feeling. So dz square and dx square, they are feeling more repulsion than dxy by zx. Now this point is clear, kids. What happened? Am I audible and visible to all of you? Just to let me know. Am I audible and visible, kids? Just do let me know. Till now it's clear or not? Everyone do let me know, kids. If yes, show me green hearts, kids. Toiba, very good. Koithmi, very good. Devika, Vinaya, very good. Now see, by considering this thing, I would like to say, now I would like to say that out of these 5 orbitals, dxy, dyz, dzx, these 3 are feeling less repulsion, and these 2, dx square y square dz square, they are feeling more repulsion. So kids, these will be known as, they are calling it easy. They have separated in 2 groups, easy, and these are known as T2Z. G is related with the symmetry. I will tell you, their energy will increase. And definitely if somebody's energy is increasing, so their energy will decrease. 3 orbitals, energy decreasing, and 2 orbitals, energy is getting increased. Till now it's clear. Just to let me know, till now is clear. Do let me know in the chat section. Till now is it clear or not? Yeah, we don't worry. My speed will get increased. Don't worry. I will tell you both the two chapters. Don't worry, but I cannot compromise with the accuracy. Quality, I cannot compromise. Okay, now see it. See. Now see. Just see. Just see. So I would like to say, now if I say this is energy level, this is energy, I'm talking about CFT in octahedral complex. This is energy. This is energy in octahedral. If I say the 5 orbitals energy was like this, 5 orbitals energy was over here. This was the energy of 5 orbitals. 1, 2, 3, 4 and 5. This was the energy of 5 orbitals without ligand. There was no ligand. No ligand was present over there. But as soon as the ligand started approaching, as soon as the ligand is going to approach, what will happen? Without ligand, this was the energy without ligand. Are you getting my point? Without ligand, all they were degenerated, dxy, dyz, dzx, dx square, y square, dz square. They were happily living, all 5 brothers. All 5 brothers were living happily with the same energy. Now, under the influence of ligand, when the ligand started approaching, ligand is like girlfriend. You can consider like girlfriend. These are the boys, all 5 friends. These were the 5 friends with different attitude. 5 friends with different attitude. Ligand is like girlfriend. Under the influence of girlfriend, their energy level got increased. They are excited. When somebody has entered in their town, they got excited, and all the 5, their energy got increased. Now they are with more energy. They are really super excited to meet that one, somebody, the girlfriend. Girlfriend can be your books, anything, whom you love. Still, one thing is common, they all are still with degeneration. Degeneration means they are all together. Degeneration was there, degeneration is here. Now, degeneration means same energy. They are having same energy. They are with the same energy. Same energy, kids. Same energy. But once the ligand is going to approach, when they are going to meet with that girlfriend, now they are saying, oh no, we are with different energy. They will split. Girlfriend always split friends. Friends got splitted. Hey, what happened? They got splitted. They got splitted, and head-on collision, 2 of them, they are with more energy. 2 got energy increased and 3 got energy decreased. 3 got decreased energy because girlfriend collided with these 2. They are having hug. Hey, my girlfriend. So their energy got more increased and they got splitted. Hey, you have broken my heart. You have broken my heart. You are not my friend. You have broken my heart. Broken heart. And this is known as splitting. This is known as splitting. Splitting is there, and the splitting is denoted as del naught. This is known as del naught. Del naught means octahedral splitting. And in between them, this is barycenter. The middle point is known as barycenter kids. And this is higher energy and this is with lower energy. Still, they are with each other. Their energy is same. That's why symmetry is there. They are known as EG. G means symmetry. G stands for symmetry is there. Still they are with same energy level, 2 are same, and these are T2G. Now T2G is dxy, dyz, dzx, dx square, y square, dz square. Now this is the splitting. They have got decreased energy and they have got increased energy. These two got increased energy on behalf of these three. The three got decreased energy. Three got decreased. That means I would like to say that their energy got increased 0.6 del naught, and I will say there got decreased, so decrease minus 0.4 del naught. I can write like this, or I can say 3 by 5 energy got increased, or I can say 6 by 10 that of del naught, octahedral, same. Anything you can write, anything you can write. So is this point clear to all of you kids? First from here and then splitting is there. Now this point is clear. Just to let me know in the chat section why T2G's energy got decreased and EG's energy got increased. Kids, do let me know. First of all, tell me, kids. Yeah, Prithvi, you got it. Prithvi, heartbroken ones are down and couple is up energy. Wow, Prithvi, really great. Have you ever seen in this way, Prithvi? After CFT, I will tell you how to find out the color of any compound. I will tell you the trick, scientific trick to find out color of any compound. But first of all, do let me know, Prithvi. Wow, Prithvi, very good. Now one kid, Prithvi, is there and he is there to understand. Now, if this thing is clear, now how the electrons will be filled, that is the most important point. How the electrons will be filled, just see. The filling of electron in these 5 orbitals will follow APH rule. What is APH rule? Filling of, now let me draw this on next page, but they will follow, filling of electrons will follow, filling of electrons will follow APH rule. What is that APH? APH rule, Aufbau, Pauli and Hund's rule. Aufbau, are you getting my point? Aufbau, Pauli and Hund's rule. Now what it says, that if I fill one electron, then it will come over here. If I fill second electron, that will come over here. If I fill third electron, it will come over here. But fourth electron will come over here or will go to that depends. Fourth electron. Are you ready what I am saying? First electron will come and join over here. Second electron will come and join over here. Third electron will come to this. Now fourth electron, where it will go, that will be decided by whom? That will be decided by whom? The type of ligand. Now let me tell you this splitting. You know the girlfriends are of two types. Girlfriends are of two types. Sir, what do you mean by girlfriends are of two types? Let me tell you. If the girlfriend is so sophisticated, IITian or MBBS, means high attitude, then the splitting will be more, or the girlfriend is weak girlfriend. So see, if the girlfriend means ligands are here, the girlfriends. If the ligand is super class, SFL, suffles, in Hindi suffle, English is successful, strong ligand. If strong ligand is there, then the splitting will be more. Remember that splitting will be more high. He has got a better girlfriend, so the splitting will be like this. Splitting will be more. So this is Eg and they will be T2G lying over here. And if I say this is the energy, just see, if I say this is the energy, this is the energy going up, energy is increasing. If I say this is energy, so this much of splitting is there in between T2G and Eg. This much splitting is there. Just try to understand how much splitting is there. This much splitting is there. This much splitting, right? This much of splitting is there. This is strong field ligand has caused this much of splitting. If I say the weak field ligand is there, if the weak field ligand is there, so this is T2G and this is Eg. I will say this is T2G and this is Eg. Only the difference in energy is this much. This much of energy is there. Only difference of energy is this much. Whose splitting is more? Who has done more splitting? Do let me know who has done more splitting. This is weak field ligand. The weak girlfriend has done splitting, and this is strong field ligand who has done maximum splitting. Two types of splitting is there. This is caused by strong field ligand and this is caused by weak field ligand. And how to find out which is strong field ligand, which is weak field ligand, you can see I have given you the trick. Where the trick is provided by me, just see strong field ligand and weak field ligand. I have given you the trick long ago. Which trick? It's where the trick has gone. This trick I have shown you. Indian bro Sachin child Sara is fond of oxalate in water with nachos. Educated Neha is teaching English in Canada and Colombia. Strong field ligand and these were weak field ligands. Do you remember? If you remember these strong field ligands, weak field ligands, then you can understand each and everything. Indian bro Sachin child Sara is fond of oxalate and water in nachos. Idiot or educated Neha is teaching English in Canada and Colombia. Do you remember, kids? Do you remember? This line is strong field ligand and they are weak field ligand. If you remember this, you can easily find out strong field ligand causes maximum splitting, and then you can understand the color theory also. Maximum splitting is caused by strong field ligand and less splitting is caused by weak field ligand. Less splitting. This point is clear. Is this point clear to all of you kids? Do let me know in the chat section. क्या कर रहे हो? क्लास चल रही, तुम आवाज कर रहे हो यहाँ पर. अरे बच्चा लोग बात नहीं करो, क्लास चल रही है. Now kids, what I was telling you, just see kids. Till now, let me see the chat section. Is it clear to all of you kids? Is it clear? Is it clear? I want to see green hearts. Now see kids. Just see, you know, to make a pair, too much adjustment is allowed or applied. Remember that here, the energy of octahedral is more, del naught is more, the splitting is more, than the P. P stands for pairing energy. It's more than pairing energy. P for pairing energy. You know that to make a pair, paisa, money is required, energy is required to make a pair. Girlfriend will say, hey, I want this gift, that gift. So here, pairing is not easy. Pairing is not easy. I will tell you what is the meaning. And here, this is less. This is less than pairing energy. So here, it's like this. Are you getting my point? Here pairing energy, less energy is required to make a pair. Just see, less energy is required to make a pair. This is less than this, so less energy is required. Less energy is required, that means pairing is easy. So pairing will be easy. Here pairing is easy, and here you see this much is less, so the electron will say, oh, this is the mountain, I will go away and I will live on mountain like ship. I will not form a pair. So to reach from this place to this is like mountain. So to be like ship, to go up to that mountain is not easy, but the mountain is near. So this electron will say pairing energy is high. When pairing energy is high, so the electron will say, I will climb to the mountain. I can easily reach to the mountain and I will live over there alone. So which side people will go to the mountain? This barrier is easy to cross and this barrier is not easy to cross. So people will filled first here. All the 6 electrons will filled first here. So are you getting my point? So if I tell you about whenever the strong field ligand is there, 1 electron, 2 electron, 3 electron, 4, 5, 6, 7, 8, 9, 10. But here 1, 2, 3, the 4th electron will go to that 4, then 5, then 6, 7, 8, then 9, 10. This point you are getting or not getting? Tell me you are getting or not, otherwise I will explain it. Tell me, kids. Tell me, kids. Thank you, Adeline. Thank you, Azilin. Okay, let me tell you. See, kids, let me draw it once again. Let me draw it once again and just see. Let me draw one compound K4 FeCN whole 6. This is strong field ligand. Another compound, let me draw K4 FeCl6 weak field ligand. Now just see, let me draw the orbitals also. T2G, EG, let me change the color. T2G, EG, here T2G and EG. Now see, if I say electron number 1, if I say electron number 1, electron number 2, electron number 3, electron number 1, electron number 3, all 3 will get filled, same filling. First let me write down the splitting energy, where it is more, where it is less. Here the splitting is this much. Here the splitting is only this much. Now see, kids, the fourth electron will get filled over here, fourth electron over here, fifth electron, sixth electron, fourth, fifth, sixth. But here the fourth electron will come over here, fifth electron will come over here. Just see, are you getting my point? Because this is weak field ligand. In weak field ligand, pairing energy is less or more. Pairing energy here is more. Pairing energy is more than this. That means to pair, to form a pair, more energy is required, more money is required, more money is required. We'll say, oh, I will not pair, I will go up. You know, to get married, if lakhs rupees are required, he will say, oh, I will not marry, I will not form a bond, I will go, I will increase my energy, I will qualify exam, IIT or NEET. They are saying, oh, let's form a pair, the IIT, to cross this energy barrier. This is entrance exam. This entrance exam, energy required to qualify the entrance exam is too much. So pairing is easy here. Pairing is easy for these kids. Pairing is easy because they are not able to cross this exam, because this is strong field ligand. But here pairing is not easy for these people. Pairing is not easy. Pairing is not easy because too much energy is required. So they will say, oh, we will cross this energy barrier, we will cross this entrance exam, we will increase our energy. Now you are able to understand. Sixth electron is over here, seventh electron will come at this place, eighth electron will come at this place, then ninth and 10th. Then here 1 2 3 4 5, sixth electron will come over here, sixth electron will come over here, then seventh electron, then eighth electron. Now you are getting my point, kids. Now do let me know, kids, those who are able to understand this for the first time, do let me know. Do let me know how many of you are able to understand pairing energy concept for the first time. Okay, once again, Monica, I will tell you, those who are able to understand this concept for the first time. Babas, please hit the like button if you are joining for the first time. Those who are watching this lecture for the first time, kids, hit the like button, smash the like button, kids. Oh, Manoj Jain, wow, Manoj. Clear for the first time, very good. Prithvi, done, very good. Now see, kids. So let me move ahead. If I'm talking about tetrahedral splitting, this was the octahedral splitting, but if I talk about tetrahedral splitting, just see CFT in tetrahedral. Let's talk about tetrahedral. Now after this I will tell you the color theory, then you will really say, wow, Baba, it's great. Tetrahedral splitting. Now see, tetrahedral. If I talk about tetrahedral, then any one metal which is forming tetrahedral complex, so metal must be forming a bond like this. Just see, one bond over here, one over here, one at this point, another one like this. Just see, it's like this. Am I right? Now see, this is the approach of ligands. Ligands will come with their electrons like this. Ligands will come with electrons like this. Now kids, can I say they are lying in between? If I talk about their d orbital, 5d orbitals, 5d orbitals, they are like this. 5d orbitals, they are like this. 1 2 3 4 and 5, they are like this. dxy, dyz, dzx, they will be like this metal. This is the ligands approach. Now dxy, if I say where the dxy will be located, so let me draw first x-axis. This is the x-axis. Okay, let me change the color, kids. white color I am taking. This is dxy, this is dxy, okay, and this is z-axis. If I say this is z-axis, and let me draw like this is z-axis, so the ligand is not approaching dx square y square. If I draw dx square y square, where should I draw? This is dx square y square. Are you getting my point? This is the orbital of dx square y square, this one, dx square y square, and dz square. If I draw dz square will lie over here. This is dz square. Let me draw properly. This is dz square. Now no ligand is colliding with the dx square y square dz square. Now if I draw dxy, if I draw dxy, there dxy will lie in between x and y axis. First let me write down, otherwise you will forget. This is x axis, oh my god, this is x axis, this is y axis, this is z axis. So if I draw dxy, if I draw dxy, so in between x and y, so I will draw dxy will be like this, dxy, dyz will be like this. So who are nearer to the ligand's approach? Who are more nearer to the, no one is colliding, but who is nearer? These are more near to, more nearer to what? More nearer to ligand's electron. So now this time T2, I will say T2 energy will increase and E energy will decrease. So their splitting will be like this. This point is clear why this is happening, kids? Everyone, are you getting my point? Till now it is clear, then only I will draw the diagram if this is clear. Very good, Avanya. Everyone hit the like button, make it 500. Those who are not, smash the like button. Everyone got it? Just do let me know. Make it 450, 442 it is night right now. Now, let me tell you, kids, let me tell you. Now the splitting order will be like this. If I say this is the energy order, this is the energy. Earlier the 5 orbitals are like this, then they are like this, still degenerated. 1 2 3 4 5, 1 2 3 4 5, right? They are degenerated, they are all together. Now the splitting is there. After splitting, now T2 are there and EG are there. EG, not say G, T2 and E. These are T2 and these E, right? Now the splitting is less. I would like to say splitting is less. So let me draw less splitting one, less splitting one. Let me draw less splitting one. So they are more nearer, more nearer, more nearer. So the difference in splitting is less. This splitting is less because no one is lying on the correct approach. So they are like this. So these are T2, no symmetry is there. These are E. And remember that the difference of tetrahedral splitting is 4 by 9 times that of octahedral splitting. This is very, very important for doing numerical. 4 9 4 9 4 9, 4 by 9 of this. So less splitting is over here, less splitting is over here. Kids, you got it? Now after this I will tell you the color theory. If this is clear to each and everyone, just do let me know so that I can tell you the how to calculate the color. Those who want to know scientifically how to find out the color, just do let me know. Yeah, still coordination is going on. Now those who are really interested in finding out color, just do let me know. I will tell you how to find out any color. How to find out any color, I will let you know, kids. Then I will tell you how to find out isomers, number of isomers. Show me green hearts and write down me. But whatever I taught you, let me show you first in the NCERT. The same thing let me show you in the NCERT. See, they have shown barycenter 3/5 or 6/10 of octahedral, and they have shown Indian bros Sachin Child Sir are fond of oxalates in water with nachos. Educated Neha is teaching English in Canada and Colombia, spectrochemical series. The same thing as I told you, if this is less than pairing and this and all, already I've taught you kids. Now see the splitting, you can see this is in tetrahedral. Just see 5 were all together, then increased energy, then the splitting is there. This is in tetrahedral T and T2 is there, E is there, T2 and E, and octahedral splitting I have told you. Now let me come to this color. How many of you want to know how to get any color within fraction of second? 1, 2, 3, 4, 5, 6 and 4 compounds. This 10 compounds color is given in your NCERT. 10 compounds. How many of you want to calculate the color, not to cram the color? I will tell you how to calculate the color. If you want, then everyone come with your one friend. Call your one friend. Right now the strength is 72. 72. Everyone call your one friend and ask him or her to join. I want this 72 to the how much? 144. I want to see the strength to be 144. Everyone call your one friend. Everyone call your one friend. Then I will tell you the color trick. How to calculate the color. How to find out any color within fraction of second, I will tell you. Make a promise that everyone is going to call one of your friend. Make a promise that you are going to do that. Call your friends. Helping others, sharing is caring. If you are helping others, Almighty God is going to help you, kids. Everyone call your one friend. Your is already there. Then his friend, the one who is already there, that will call two friends. Dar Arafat is saying, sorry sir, oh my God. Just after this chapter, I will teach DNF. Okay, kids, are you going to call? Are you going to do that? Then I am going to tell you the amazing thing. Amazing. No one can tell you. No one can tell you this thing. Baba is the one only who can tell you this color theory. Baba is only the one. Baba is going to tell you how to calculate color, not to mug up the color, not to cram the color, how to calculate color. I will tell you how to calculate color. Color calculation. Okay, ready kids? Everyone ready for the color calculation? Is everyone ready? Just see. First of all, learn this color wheel. Color wheel you have to learn. Let's divide into number of parts. How many parts I have divided? Now Vibgyor. Vibgyor is violet, indigo, blue, green, yellow, orange, red. Okay, remember it. This is red, this is orange, this is being yellow, this is being green, this is being blue, violet, indigo or purple, VIP. Okay, now what are the complementary colors? First try to remember this, then I will show you the complementary color. Who is the complementary color of whom? I will let you know, kids. Just see. So just see who's the complementary color of whom. Just see, I'm going to tell you, kids. Violet deals with yellow, or I can say the complementary color of yellow is violet, indigo, purple. This point is clear. This point is clear. Now I would like to say that green is red and the complementary color of red is green, or I can say blue, green, red. Blue or green is also red. Blue, green, in between blue and green, that is red. This is like this, and exactly the blue one is going with the orange. So blue's complementary color is orange and orange complementary color is blue. Just see what I'm talking about. Blue's complementary color is orange and orange complementary color is blue. Now in this way you won't be able to understand. Just see, if you see the traffic light after green, once the green you will go, and once it is becoming red you will stop. Red and green, they are complementary color. Or you can remember beggar. Beggar means what? Beggar. Just try to understand beggar, the meaning of beggar. Blue, green, complementary color is red. Now is it clear, kids? Blue, green's complementary color is red. If tomato is green, one day it will become red. Chili is green, one day it will become red. One thing is clear. Blue, orange. Shivji is blue, Shiv God is blue, and Hanumanji is orange. Blue and orange, you must have seen blue and orange, they are complementary. Shivji is blue, Neelkant, the blue color is referring to Shiv God, and orange color, his founder is orange, that is Hanumanji. Now can you remember these complementary colors? First of all, do let me know. If you are able to understand how to learn complementary colors, then also it is going to help. Once complementary colors clear, then only I can move ahead, kids. First of all, do let me know if complementary colors gone to your brain. If they are fixed in your brain, then only I can help you. Show me green hearts along with fire if they are fixed in your brain, kids. If they have been fixed, then only I can help you, kids. Now, color theory, if I say, then do let me know if you have seen rainbow, Bivgyor. You have seen rainbow, Bivgyor. Then do let me know who is having maximum energy. Which color is having maximum frequency? Maximum energy, which color is having? This is maximum energetic. Maximum energy. Am I right, kids? Or I can say least wavelength. Least wavelength. Am I right, kids? Least wavelength. Am I right or not? This is least energy. Maximum wavelength. Am I right? That is 720 nanometer approximately. So 720 marks paper of NEET, and bio paper is of 360 marks. You can remember in this way, nanometer, bio marks 360, total marks NEET 720. One point is clear. Maximum energy, maximum frequency, least wavelength, least energy, maximum wavelength, maximum wavelength, least frequency. Clear? Clear to each and everyone till now? Keep on showing green heart along with fire if everything is clear now. Let me divide this color wheel in two parts. Let me divide this color wheel in two parts. East or west? HSP is west? Can I say? No, I will not say. Let me divide into east and west. Can I divide? East and west. This is east area. This is east. Let me say this is east. This is east. East area. East area. This is east. And this is west. This is west. This is west area, right? West. Which side people are more energetic? We are saying western people are more energetic. So the earth I have divided in two parts, western culture, eastern culture, right? Western, more energetic. So they will be least energetic. Most energetic, light absorber. Most energetic, light absorber. Light absorber. Light absorber. Right? Least energetic, light absorber. Kids, tell me first of all. Roy, R-O-Y is least energetic light absorber, and VBG is most energetic. East and west, the whole earth have color wheel I have divided in two parts. First of all, do let me know. Till now it is clear. Just it should not remain in the copy only. Shraddha, good evening. Abhinay, very good, thank you. Till now everything has gone to your hippocampus or not? First of all, I'm not saying it's in your copy only. If it is gone to your hippocampus, then only tell me, kids. If it is gone to your hippocampus, then kids, then only if it is gone to your hippocampus, then only. Okay, now see, kids, remember that what I'm saying, just see what I'm talking about. Just see what I'm talking about. Just see what I'm talking about. Just see to that only. More energetic, the compound or the complex absorbing more energetic light will emit out which color? Emit means eyes can see. Emit out. Emit means eyes. The color which will be seen by eyes. The color which will be seen by eyes. Emit will emit low energy light, which we can see with our eyes. Our eyes can see only the emitted color. Are you getting my point? Our eyes can see only the emitted color. And this side, complex compounds complex compounds absorbing low energy light will emit out high energy light. The eyes which can see, which can high energy light which can be seen by our eyes. Are you getting my point? Only the emitted color our eyes can see, the color which is emitted. Now this point is clear. If anyone is absorbing this area light, will reflect this area light. If anyone absorbing this light, will reflect this light. This point is clear. I'm moving step by step, kids. I'm moving step by step, kids. Do let me know what happened. Most of the students, kids, P block will be taken by ma'am, right? I'm teaching today 2 chapters of class 12, D block, F block 1 and coordination chemistry. Right now coordination chemistry is going on. Kids, don't try to just finish it off. Just try to do it completely. I'm not going to skip even a single thing. I'm not focusing only on completing. I'm trying to give you 100% things so that you can do all the questions, kids. Those who know, those who can understand what Baba is teaching, you can't get these things anywhere, kids. You won't get these things anywhere, kids. First of all, do let me know, kids. It's not the platform where people are not like other channels where people are completing each and everything within 4-5 hours. Baba is telling you each and everything in a decent way, kids. You are getting, now see. Remember that one point I am going to tell you. What's that point, kids? See. Who will absorb maximum energetic light? Which compound will absorb maximum energetic light? Okay, which compound will absorb maximum energetic light? The answer will be given like this. Just see, the answer will be given like this. Which compound will absorb maximum energetic light? For this, first charge on metal will be maximum. What is maximum? For example, M3 plus, this is maximum. Second, ligand must be strong field. Shuffle. Ligand must be strong field ligand, right? Maximum charge, strong field ligand, then maximum energetic light will be absorbed. One thing is clear. Only this point you have to keep it in your brain. Then everything will become simple. Can you keep? More the charge on central metal atom and a strong field ligand. This is the complex compound. 2 people are there. One is central metal atom or ion must have maximum charge, and the ligand must be strong field ligand. Just this much. Okay, now I'm going to take first example of NCERT. Everyone ready? Is everyone ready? Just see the first example of NCERT. See, everyone, just see, kids. This is the first compound. Just see, COCN6. Can you see COCN6 3 negative? Everyone, just do let me know. Is it visible? COCN6 3 negative. Do let me know. Now it's your time. Do let me know. Can you see COCN6 3 negative? Ready everyone? It's like we are going to fight. We are having a world war. We are just going to appear in paper and Baba is going to tell you the trick. Magic will begin now. Now, cobalt is having what oxidation state? Cobalt's oxidation state is here cobalt X plus 6 into minus 1 is equal to minus 3. So, X is equal to plus 3. Am I right? X is equal to plus 3. Am I right? Cobalt and cyanide is strong field ligand. Cyanide is strong field ligand. All ligands are strong field. So this will absorb maximum energetic light. So see UV light, not even visible. It is absorbing ultraviolet region light, ultraviolet UV light, or you can say violet. If you can't say ultraviolet, you can say violet, and the one who's absorbing violet light will appear which color? Will emit out which color? The one who is absorbing maximum energetic light will emit out which color? Do let me know in the chat section. Will emit out which color? I'm waiting. Baba is waiting, kids. Do let me know. Will emit out which color? Baba is waiting, kids. Where are you gone? Where have you gone, kids? The one who is a yellow dirty fellow. Now see kids, now see yellow. Very good kids, you are my dear Kuti Chetan. You are rocking kids, you are rocking. See COCN6, just see. Oh, where you have gone, my dear. Yeah. La 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 la. COCN6 is absorbing UV region and looking like yellow color, light yellow. See, hands clear kids, hands clear. COCN6 is absorbing this region light and looking light yellow. Is it clear? Got it or not? Do let me know. No need to cram it. You got it or not? You got it now. Now see the second compound. If I say ammonia with cobalt, ammonia. If I say ammonia is there with cobalt. Now with cobalt, ammonia act as strong field ligand or weak field ligand. With cobalt 3 plus. With cobalt 3 plus. Ammonia will behave as strong field ligand or weak field ligand. Answer is strong field ligand. Am I right? Now strong field, but not like cyanide, a little bit less side. The color wheel just after violet indigo, who will lie? If you see the color wheel, after violet VIP color, which color is there? Blue color. And if somebody is absorbing blue color, he will look like, that compound will look like which color? If somebody is absorbing, I don't know whether it is going to absorb this color or it can also absorb this color also. So it will look like in this area, either this area or this. Orange will be there, either orange or yellowish orange. Either orange or yellowish orange. Am I right? I don't know if somebody can absorb this color also in between these two, or can absorb blue color. If it is absorbing blue, orange. If it is absorbing over here, orange is yellow. Agreed? Let's see. Ammonia is absorbing blue color, and blue, not exactly blue. The blue must be in between violet and blue and yellowish orange. Am I right? Am I making sense, kids? Just to let me know. 100% no need to cram this thing I have told you, this thing I have told you. It is absorbing blue. Actually, it is not absorbing blue or violet, and that's light. It is in the area of yellow orange. It's a miracle or not? Kids, I don't know whether you are able to understand or not. Baba with cobalt, ammonia weak. No, Abhinya, I taught you Tridev's cobra. Oh, it's not cobalt 2 plus. See, it's 3 plus. It's 3 plus, not 2 plus, 3 plus. Cobalt 3 plus. Ammonia will... Ammonia to strong field ligand only. Ammonia is always strong field ligand, but weaker than this cyanide. Ammonia is always strong field ligand. With cobalt 2 plus, it was acting as weak field ligand. Kids, ayyo, Rangaswamy. Ammonia will act as weak field ligand with cobalt 2 plus. With cobalt 2 plus only, ammonia will act as weak field ligand. Now clear? Now. Is it clear to each and everyone, kids? Do let me know. Now, kids, I will tell you whatever cobalt will do, whatever the ligand is going over there, cobalt 3 plus will always absorb color in this area only because it is having maximum charge. So its range is like this. Its range is like this. It will absorb color in this area only. Now, if I say nickel 2 plus, nickel is having more charge or less charge? Less charge. So nickel will absorb this area color only, this area color only. Less charge. Less charge. Nickel will absorb this area. Now if I say nickel is with water, if I say nickel H2O whole 6. Now kids, do let me know. This is having less charge and this is weak field ligand. Which area color it will absorb? Least energetic color. Who is least energetic color? Least energetic color. Who is least energetic color? Do let me know. Red is least energetic. So if it is absorbing red, it will look like blue-green, either green or blue. So I say red. If it is absorbing red, it will look like greenish blue or green. Am I right or wrong? First of all, do let me know. Nickel 2 plus, once the charge is less and along with that the ligand is weak, it will absorb least energetic color, that is red. So it will look like green. Let's check it out. What's the color of this compound? Everyone, let's check it out. What's the color of this compound? Nickel H2O, just see. Nickel H2O, green colored. It's looking green. That means it must have absorbed red color. The color of NiH2O whole 6 2 plus is green. I was right or wrong? I was right or wrong? Just to let me know. I don't know whether you are able to understand or not, kids. I'm not sure whether you are able, if you are able to understand, show me green hearts, or you're thinking that what Baba is teaching, oh my god. Do let me know. I should know at least you are able to understand or not what I'm telling you, what I'm teaching you, kids. Kids, do let me know whether you are able to understand or not. Maximum people, oh, Roger Mu is not able to understand. Don't worry, I will make it possible. Don't worry. Don't worry, let me make it possible. See what I'm saying. Nickel is having 2 plus charge. Nickel is having 2 plus charge and this is weak field ligand. So it will absorb least energetic light. So it will absorb red color, and the one who is absorbing red color will emit out green color. That's why it is green. Now see, if I say Ian educated Neha teaching English. 4 are weak field ligand, 1 is strong. So it will absorb a little bit more energetic light. So after red color, which color is there? After red, more energetic than red. That is orange. So either orange or in between orange and red. So it will look like little bit blue. So it is looking like little blue. Not able to understand. See what I'm saying. Let me draw the color wheel. Just see. I will draw 4 compounds. Just see. First compound I am going to draw over here. NiH2O, NiH2O whole 6 2 plus. It will absorb red color, absorb, emit. The emitted color only we can see. Absorb red, emit green, right? Now if I write NiH2O whole 4 En, this is strong field ligand, this is weak field ligand. Strong field ligand will absorb a little bit more in between red and orange. This color it will absorb red orange. So emit out in between them light blue. So if I write down NiH2O whole twice En2, this will absorb little bit more energetic. Suppose if I say orange, then it will look like dark blue. So it will absorb orange, emit out dark blue. Now if I write down Ni2 plus En whole 3, En is strong field ligand, but nickel is saying I'm 2 plus. I will absorb this area color only, but this is saying I'm strong field, so it will absorb yellow color and will emit out purple color. Purple. Am I right? These 4 compounds color I have shown you. This area is increasing. Now let me show you in NCERT. Am I right or wrong? Just see. This is green. This is light blue. This is blue or purple. See, blue or purple. How anyone can tell you blue or purple? Only Baba can tell you. And now NiEN3 violet, because it has absorbed yellow color, that's why it is looking like violet. If anyone is there who can understand what Baba is teaching you, so you will say you are genius, Baba. Is there anyone who can understand what I'm teaching you, kids? I don't think there is anyone, because number of things are required to understand the color, to calculate color. Is there anyone? NUL, love from Tamil Nadu, thank you. Is there anyone? I want to see in the chat section. Is there anyone who can understand what I'm teaching? Is there anyone, even a single student is there who is able to understand, who got it? Did you understand? Have you understood, kids? Roger, Remu got it. Oh my God, kids. No one in this world can teach you how to calculate color. I am the only one. But is there anyone to understand what I am saying, kids? Abhinya, thank you. Nirmal Ram, wow. Parma, Baba rocking today. Shravan, I knew it. Okay. Everyone is able to understand. Baba is having really joy, enjoying each and every moment. Wow, thank you. Now, once the color theory is clear to you, now Baba is going to move towards what? Just see, I will let you know isomers. But before that, isomers. Okay, limitation, crystal field. Okay, effective nuclear charge, synergic bonding. So first I will tell you this one. Yeah, first I will tell you effective nuclear charge. Okay, effective, no, not effective. What I'm going to tell you, effective nuclear charge or something else, effective atomic number. I'm going to tell you effective atomic number. Are you ready? But before that, let's solve some questions. Based on color theory. Okay, let's do some questions. Let's see how many of you can do that. Let's see whether you will be able to. First of all, those who have not, smash the like button, like and share. And before moving ahead, before doing questions, let me tell you something for your, you can share it with your friends. relatives, classmates, that Unacademy Resolve 2025, we will crack IIT together in 2025. This is for your juniors also, kids. You have to share it. Flat 60% off on all NEET UG subscriptions with assured success. Crack NEET 2026-27 or your next year preparation is on us. For 18 months and above, subscription offer is getting ended tonight, and today's day or night is more important. You can get 60% off. Just use code is HSP10. What is the code, kids? Let me write down. HSP10. What is the code? Which code you have to apply? HSP10. You can tell it to your juniors for subscription. Flat 60% off if you are using this code, and this offer is going to end tonight only, right, kids? This is for today only. So hurry up and you can share it with your juniors, because sharing is caring. If you are helping others, Almighty God is going to help you a lot. Kids, will you help? Will you help? Now, second, Resolve 2 is flat 60% off on all NEET UG subscriptions. You can see, thus apply code HSP10. Will you apply, kids? Tell me. Will you tell your juniors to do this? Because it was for 3 hours, but I have asked the management to extend it tonight. Actually, this was for 3 hours only, but I asked them for 3 hours, right? Okay, my dear students. Now, let me move towards questions. Then I will tell you isomerism. Let's see whether you are able to solve the questions or not. And kids, this year paper will come tougher. So I have prepared questions on the tougher side, and these questions, they have been asked in IIT also. So let's see whether you are able to solve IIT questions or not, because this time they are going to ask tough questions. Now, this is the first question. Just see. Which of the following complex ion is expected to absorb visible light? Wow, very good question. Remember that to absorb light, they should have at least one unpaired electron. That will go up and then it will come back, because only the electron has to go now to climb to reach to that mountain. At least, I'm giving you hint, at least n should be equal to, or n, at least one unpaired electron. At least one unpaired electron is needed. That only combine, otherwise who will climb? So n should be equal to greater than 1. Just to let me know what's the answer in the chat section. I'm waiting for your answer, kids. Baba is waiting for your answer. Yeah, I will give you 10 minutes break, but first let's complete it. D. Most students are going for D. Let me check it out. What's your answer and what should be the answer, correct answer? Let me see. Now, see, kids. If Baba would have been there, how Baba would have solved this question? Let's see. Can I solve this question? Science teacher, very crazy man, felt cold in night with cousin. Teacher, TI 4. Shakti 2, all 4 gone. N is equal to 0. Naka. Chromium. Science teacher, very crazy 24. 3 plus 3d5. 4s1, 1 has gone. Yeah, it's n is greater than 0. Zinc 2 plus 3d10 4s2, n is equal to 0. Scandium 3 plus n is equal to 0. So the answer will be B. B is the answer. Hey, calculator, computer, solve it. Yay! Baba is rocking. Baba has solved this question. Kids, even Baba has solved this question or not? No, it's not D. Shravan. Kids, first of all, do let me know Baba has solved this question or not. Is Baba genius or not? Is Baba genius or not? Kids. Another question. Yeah, this is the solution. Now, which of the following complex ion is not expected to absorb? Not expected to absorb visible light. Once again, let's do together. Nickel. Science teacher, very crazy man, felt cold in night, felt 26, 27, 28, 28, let me reverse, 82, 3D8, 4S2, 2 negative, cyanide 2 plus, so these two have gone 8, but cyanide is strong field ligand, so 8 will combine 1, 2, 3, 4, 5, 6, 7, 8, no. Only 4 ligand, 4 DSP2, so they are the value of n is equal to 0. Cyanide being strong field ligand, so it will combine DSP2 hybridization. Chromium 3 plus. Chromium is how much? Science teacher, very crazy man. Chromium is 4s1 3d5 3, 4s0 3d3, so unpaired electrons 3. So this answer to we have got is not expected to absorb light. Its value of n is equal to 0. So this should be the answer. Let me see what answer you have given. What answer is given by you? Baba, when will you start it? DNF, I will start. Only one kid has given the answer. Let me check it out. Yay! Baba is rocking. Kids, first of all, do let me know Baba is solving in that very, very decent way or not. Kids, you are asking whenever you are going to start D. I will start very soon, very soon. But do let me know what's the answer. Now another question. Oh, this is the explanation. Leave it. Which of the following compound is not colored? Simple, not colored. Zinc, cadmium, mercury, copper, Fe6, UCl4. Zinc, cadmium, mercury, Jad and cadmium, mercury, zindagi, kaddu, zini Canada hogi, zindagi, ZNCD, all they belongs to copper, zinc, they all are having just like 3D10, 4s2, so Zn2 plus, so 2 plus, they have given filled electron, 4D10, 5D10, you are the answer, let me check it out. Yay! Baba has done it. Kids, first of all, do let me. Baba is rocking or not? Baba, you're a kid. Kids, Baba is rocking or not? First of all, do let me know, kids. Hey, kids, you're not writing anything. What are you doing, kids? Baba is rocking or not? Okay, now see another question. These are IT questions. Wavelength of red light. Oh, red light is absorbed by the complex. Red light, who will absorb? Metal should have less charge and weakest field ligand will absorb. 2 plus. So weak field ligand, where is weak field ligand? Cyanide strong. Ammonia is strong, cyanide is strong. I think this CuSO4 is blue color. It is absorbing right light. Which wavelength of red light? Oh, this is blue color, I know. This is blue vitriol. Its name is blue vitriol. So its color is blue. It must have absorbed which color? It must have absorbed red light. So I think this is going to be the answer. Oh. This is also blue colored, but CuSO4 dot 5 times H2. That is blue. Otherwise, CuSO4 is white only. I got failed. Mamma mia. I got failed. It is white. This is blue. This is phalanx solution. You know that phalanx one. And this is deep blue solution. But they have given only blue wavelength of red light. Deep blue. It is deep blue solution. I got failed, kids. Yo, I too got failed. Now what should I do? Kids, I got failed. Now another question. See, deep blue solution, already they have written. The wavelength of light absorbed is highest. Wavelength highest, that means least energetic light. Least energetic, once again my fundamental thing, least energetic, cobalt 2 plus. But 3, this is 3 plus, cobalt 3 plus, cobalt 3 plus, cobalt 3 plus, everywhere 3 plus. Least energetic light. Ammonia, 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 En. So water with cobalt is strong field ligand. They are strong field ligand. Only this one. I will go with this, kids. In the previous question I got failed. What to do now? Am I right or wrong? Now tell me, am I right or wrong, kids? I will go with A. Now this time, hey God, save me. Let my answer be correct. Yeah! Correct. Now see, are you able to understand what Baba is saying? This is the explanation given. Whatever I have told you, taught you, it's given like this only. Now, the correct order for the wavelength of absorption in the visible range. The correct order of the wavelength. I don't know the wavelength. I will see the correct order of for the increasing wavelength. That means this side most increasing wavelength. This side maximum wavelength means least energy. Least energy one should lie, then only maximum wavelength, and this side maximum energy. Now for maximum energy, what I have told you, for maximum energy, maximum charge should be there and strong field ligand will be there. Maximum energy, nickel 4 negative 2 plus, leave them 4 negative 2 plus 2. The correct order for the wavelength of absorption in the visible. Correct order for the wavelength of absorption. So wavelength is increasing, energy is decreasing. Least energy, which will be least energy? Nickel. Who is the weakest field ligand? Weakest field, nitrite is strong field ligand. Ammonia with nickel 2 plus. These two are weak. But water is even weaker. So it should be there, then it should be there, then this should be lie. So I will go with A. Kids, this question was a really tough question. Kids, do let me know. Will you go with A or not? I to go with A. Now let me check it out. Baba is genius. Now you have to say Baba is genius. The explanation is given over here. I have told you the spectrochemical series and each and everything. Then only you can solve this question. Now you can solve it. Now this is homework. Which one of the following is the outer? This you can do, outer orbital complex at your home. Okay, these questions you can do at home. Now let me teach. Should I teach you right now or should I give you a break? Break is required or should I start teaching? Do let me know. You need one break or should I start teaching? Kids, do let me know. 10 minutes break. You need everyone. So after half an hour I will give you. Break. Oh, everyone is asking for break. So 10 minutes break you need. 7:23. Let's meet at 7:35. Now here I will start isomerism, okay? I will start with isomerism. First I will teach you effective atomic number EAN, and then I will start isomerism. Okay, then I will start isomerism. First I will teach effective atomic number and then isomerism. Okay kids, first effective atomic number, then isomerism, right kids? Everyone okay? Come with lot of energy and with friends. I will give you the best trick. No one would have given this trick for this. This is the real thing, and I will make it clear. Baba will give you number of tricks. Three tricks, and along with visualization, I will make it super easy to do any question of GI and optical isomerism. Okay. Hey everyone, just to let me know, am I audible as well as visible to all of you? Kids, this is your Baba HSP once again, Magical Chemistry Group Baba HSP. Can you hear me? Can you see me? If yes, I want to see green signal in the chat section so that speedily I can tell you effective atomic number and then isomerism. What is the meaning of effective atomic number? And then isomerism, the most required. Let me check it out. No green hearts. Oh my God. Everyone, where are you? I can't see green hearts. Oh, coal is back. Wow, that's really awesome. Kids. I want to see the chats running fast. Effective atomic number. What is the meaning of effective atomic number? Let me show you. Effective atomic number. So let's move here time. Effective atomic number. Where are you going? Effective atomic number. How to find it out? Just see, everyone. Just see it out. Now, let me give you the visualization. Then I will give you the formula. What is the meaning of effective atomic number, kids? Generally, people are writing. People are just trying to complete the syllabus, complete the chapter. That's not very much required. Actual, very good. Now, let me tell you what is the meaning of this, kids. We want to qualify IIT exam, we want to qualify a NEET exam, we want to become doctor or engineer. Why we want to do that? Because we want stability. Everyone is searching for stability. Everyone is searching for what? Everyone is looking for what? Everybody is just looking for stability. Am I right, kids? Just looking for stability. So like we human beings, when everyone is just looking for stability, these elements are also helium, neon, argon, krypton, xenon, radon. They want to become like these elements. Noble gas configuration. They want to acquire noble gas configuration. Now there are two ways how they can get noble gas configuration. Let me tell you the atomic number of these elements. Let me change the color, kids. Now, I will focus on Arya and Karya. I would like to focus on these two. Why I'm talking about like this Arya and Karya? Arya is Arya and Karya. Now let's see. If I talk about element chromium, just see chromium. How many electrons it is having? 24. If it is donating out 6 electrons, it has lost 6 electrons. Loss of how many electrons? Loss of 6 electrons. Then it will form chromium 6 plus 24 minus 6. How much, kids? I don't know maths. Do it. 24 minus 6, how much? How much? 18. Now, whose noble gas configuration it has acquired? Just see. It has become arena. It has become arena. It's looking like arenas, like argon. Actually, arena is argon. Argon's noble configuration is acquired, but it has got charge. It's charged. Charge is like some disease. But it has acquired this configuration. But if I'm moving toward this side, this will lead me towards which block? This will lead me towards D block. I will teach you this chemistry in D block. This is really going towards D block, but it is going to combine with CO, 6CO. CO is a ligand, two electron. That means lone pair donor, one lone pair donor. Now see kids, one lone pair donor, 6. Now it will form CO whole 6. Now just see kids, it was having 24 electrons of its own. 24 plus 6 into 2. 6 into 2, that is 12. 24 plus 12, this is 36. It has also noble gas configuration of whom? That is arena. This is carina. He has become carina. Krypton noble gas configuration and no charge. Who is better one? So this one is going towards coordination chemistry, and that is giving feel of D block, and this is giving feel of coordination chemistry. Is there anyone who is able to understand my logic? Now, what is this 36? I will tell you with the effective atomic number. I will tell you, but this was the visualization how elements are trying to get stability. Is there anyone who is able to understand, kids? Is there anyone who got it? My sense, my visualization. Kids, is there anyone who got what I am talking about? If yes, I want to see green hearts, green color, green to go. Now I will explain this with the help of effective atomic number. The formula of effective atomic number, EAN. This is atomic number minus oxidation state plus twice of coordination number. This is the formula. Z is atomic number minus oxidation state twice of coordination number. Got it, kids? Got it? Now the same example which I have solved, let me show you. CrCO whole 6. Just see what is the atomic number of chromium. So EAN, atomic number is 24, no charge, so 0 plus twice of coordination number, it's coming out 36. Same thing you got. Those who are able to understand, I want to see green hearts, then I will move further, tell you each and everything. Just to let me know, everyone, those who are able to understand, kids, do let me know. Yes. Now if I talk about, there is science teacher, very crazy man, felt cold at night with cousin. Just try to understand, you will get science teacher, very crazy man, felt cold. This is cobalt, that was carbonyl, felt cold in night. Now see kids, why I am writing like that. 24 even, 25, 26 even, 27, 28 even. So to make 36, it is in need of 6 CO, it is in need of 5 CO, it is in need of 4 CO. Just see, just try to understand, then I will let you know what is written in NCERT, NiCO whole 4, it will become 36. FeCO whole 5, it will become 36. CrCO whole 6, it will become 36. All their EAN is 36. If you are able to understand, if you calculate, but if I combine with 5 or 6, they will not be able to become. So if I write down Mn, because its Mn is 25, this cannot become 36 because they are lone pair donor. This is what, why I'm writing 20, yeah, this is 27, they can't become. So what they will do, let me tell you what they will do. If I write manganese and it is combining with 5CO, just see MnCO whole 5, what is the En will come out, just see kids. Atomic number minus oxidation state 0, twice of coordination 2, 5 is 10. So it will become 35. It's not 36. So what it can do? It can do two things to acquire stability. One thing is that MnCO5 can undergo reduction, gain of 1 electron, so it will become NnCO whole 5, 1 negative. So its effective atomic number will become 36. So it is undergoing reduction. So it is acting as oxidizing agent. It is acting as oxidizing agent. Am I right, kids? The second thing, it can dimerize. Twice of MnCO5 will dimerize. So 1 electron will be common. So it will become Mn2CO whole 10. Its effective atomic number is also 36. Now I hope you are able to understand. Kids, do let me know. Then I will show you in NCERT why they are undergoing dimerization to get stability. Just do let me know, kids. Everyone, you are able to understand or not? Just to let me know. Kids, do let me know. Everyone, just do let me know. And this thing I will show you in NCERT. Just see why they are undergoing dimerization. Just see, kids. Mn2CO10 written. Mn2CO10. Why with manganese only they have written? Cobalt also they must have written. Cobalt 2CO4. Because by dimerization they will get stability. Are you getting the feel, kids? With nickel CO4, it's okay. FeCO5, it's okay. But CrCO6, okay. But they are undergoing dimerization. Why they are under? Are you getting the feel, kids? Do let me know. Are you getting the feel? Why manganese dimer they have shown? Why not Mn single? Are you getting? At least show green hearts, kids. This. Getting, kids? Are you able to understand? Is there anyone who is teaching like this? Kids, you are always thinking which chapter is completed, how much is completed. You are always thinking like that. You are not able to understand what sir is teaching you, how much dedication he is giving, kids. Clear? Okay, now let me move towards isomerism. Baba is moving towards isomerism. Just see isomerism. Just see, everyone, isomerism. Let's see. Let me give you a table for isomerism so that each and everything will become clear. First thing, to cram it out, Baba is going to give you a table. Isomerism. The toughest part of isomerism, I will tell you, GI and OI. GI and OI. Let me write down compounds. First, the compounds, okay? First, let me write down compounds. See, compounds I am writing over here. Na6, all 6 type of ligands are same. Na5, this is octahedral, 5 are same, 1 is different. Na4, then B2, Na4, then BC. Let me write down other compounds. Na3B3, Na3B2C, Na3BCD. Now Na2B2C2, Na2B2CD, Na2BCD, BCDE, NABCDEF. How many types of compounds I have written? Just to let me know. How many types? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Full cricket team I have written. Just to let me know. Just to let me know, kids. Full cricket team I have written or not? Do let me know, kids. Everyone, just to let me know. Okay. Is it okay, kids? So I will write over here number of geometrical isomers. Is it visible, kids? And here I will write enantiomeric pairs. Enantiomeric pairs number. Enantiomeric pairs number. Number of enantiomeric pairs, right? Now just see. Right now I am going to give you a cramming part. Cramming part 0, 0, 2, 2, 2, 3, 4, 5, 6, 9, 9 and 6, 15. Okay. 0, 0, 0, 0, 0, 0, 1, 1, 2, 6, 15. Now kids, if you want to cram it out, you can go with this. And if you want to understand how I have got it, then it will require time. Now just to let me know, how many of you want to visualize how I have done like that? If you want to visualize, I will give you. Thank you, Chinna Pagu, Jonah Raquel. That's awesome. Kids, do let me know how many of you want to really visualize. You want to use your brain. This is the way I have given you. But if you really wants to understand it, do let me know. Okay. Okay. Thank you, Sahana. Welcome. Now, see kids, I will make it possible. Let me explain the last one, the toughest one, okay? Let me explain the toughest one. See, just see. Let me explain the toughest one so that you can understand each and everything. To understand MABCDF, let me tell you first, A, B, C, D, the square planar complex. Square planar complex. So that you can understand each and everything. First, I will tell you GI, geometrical isomer. So if I write down M, here if I have written A, then what I can do? In front of this I can write B, then once again M, A, M, A. What I can write? What I can write in front of B, then I can write C, then I can write down D. If I have written B over here, then I will write down C and D over here. Then I write down B and D over here. Then I will write down C and B over here. So how many GI I have got total? How many GI I have got? Just to let me know. How many GI I have got? Everyone do let me know. How many GI I have got, kids? Soon, very soon, you will understand what. Before that, first of all, let me know, kids. Let me know. MAB 3 GI I have got, total 3 GI. All total 3 GI I have got, and they are optically inactive. They all are optically inactive. Why, kids? If you cut like this, see, if I say here is M, here is A, B, C, D. If you cut it like this, slice cut, whatever is going up will go down. They have plane of symmetry, so none of them is being optically active. Are you getting my point, what I'm saying? None is optically active. None is optically active because they all have plane of symmetry. Everyone till now is clear? Just to let me know. Till now if it is clear. So optical activity, square planar complex. Square planar complex can never be optically active. Why they can't be optically active? The reason is very simple. Why square planar complex? Square planar complex can never be. Square planar complex can't be optically active. Can't be optically active. Can't be optically active. Never they can be optically active. Never ever they can be optically active because they will always have plane of symmetry. This is central metal atom, and whatever you write over here, here, anything you can write. If you cut, slice cut any atom that is spherical, what is going up, that will go down. Like if I say, I think you are able to understand. If I place over here this thing, whatever is going up, the same thing will go down. If you cut like this, are you getting my point? First of all, do let me know. Let me see in the chat section. You are getting it or not? Just after few seconds, not few seconds, after few minutes, I will start. Just to let me know. Are you getting my point or not? Kids can't understand. Green hearts. Just to let me know, you are getting it or not. Square planar complex can never be optically active. Yeah. Now one thing is there. Whatever I'm placing at this point, if the upper part is different from, if this upper part I am making different from lower part, if this upper and lower, if upper is this and lower is this, now you do sandwich cut, slice cut. They are different. Now upper thing is different and lower thing is different. There is no plane of symmetry. It will be optically active. You are able to understand. Now if I am going to cut it like this, the upper side there is pen and lower side there is bottle. They are being different, so no plane of symmetry. This is the case of octahedral, 4 ligands in the plane and one above and one below. If they are different, then there is no plane of symmetry. Are you getting my point? First of all, do let me know. Now, by using this point, let me tell you the same thing in octahedral complex. Just see. If I write down, if I take this compound M, A, B, C, D, E, F. So what I'm planning, I have written M, I have written A, I have placed B, I have placed C, I have placed D. This is fixed. Now what I'm going to do, there is E, and in front of E I'm going to change. I'm going to put F. Now this will have 3 GI, and there is no plane of symmetry because this is different from this. Plane of symmetry is being absent, so this is optically active and it will form 3 GI because in front of A, once I will keep B, in front of A I will keep C, D. Are you getting my point? 3 optically active. No, 3 optically active. First write down 3 GI. First let me, are you getting my point? 3 GI. If you're not able to understand, do let me know. 3 GI and 3 GI's mirror image will be there. 6 optically active. All they will have enantiomers. 6 optically active. Is this point clear? It will have 3 GI because A I will fix. I will make A fix like earlier I have told you. A fix, I will rotate B, C, D. By fixing A, I will E and F, they are fixed. A fixed, B and C I will rotate. I will get 3 GI, and all 3 GI will form 3 enantiomeric pairs. That means they are 6 optically active. One point is clear. Is this point clear? Do let me know in the chat section. Then only I can make you. Kids, do let me know in the chat section this point is clear, or I will explain once again. First of all, do let me know, is this point clear or not? Is this point clear or not, kids? Do let me know. Arey Baba. Fast. Do let me know if it's clear. Green hearts. Kids, if it is clear, I want to see green hearts. Rajaram, you not able to understand, okay? Okay, I will repeat once again. Just see. Don't worry. Don't worry. Just see. What I have told you. If I keep this central metal atom fixed and A fixed, and in front of A, let me put B. Once let me put B, M, A, let me put C, M, A, let me put D. Okay. And the position of E and F is fixed. In front of E, who is there? In front of E, I have placed F. Now A, B, C, D in one plane. A, B, C, D in one plane, just like A in front of A, B, C, D. A, C, D and B. M, A, D, B, C, and their position fixed. E and F. E and F. E and F. E and F. Are you getting my point? So these are 3 without plane of symmetry, and this will form its mirror image. Its mirror image, suppose if I say this is A, B, C. These are 3 GI, and its mirror image will be A dash, its mirror image will be B dash, its mirror image will be C dash. All these 6 are optically active. This is clear. 3 GI and their 3 mirror images. So in all there are total 6 optically active compounds. 6 optically active compounds. Got it, kids? This point is clear. First of all, do let me know. Now I want to see. Now I want to see, kids. First of all, do let me know. Then I will explain. Then I will tell you 30, all total 30. Once, show me green hearts if you got it, kids. If you got it, really, if you got it, do let me know in the chat section. Kids, do let me know in the chat section if you really got it. If you really understood. Now see, kids. Now see. Now I'm going to tell you. You will rock. You will rock. Really, you will start rocking. See. M, A, B, C, D, E, 1, 2, 3, 4, F. We know that it is having how many? 15 GI and 15 enantiomeric pairs. Pairs means one pair is having how much? Enantiomeric pairs. That means all total 30 optically active isomers. This we know. Now let me visualize it. Now just see what I'm saying. What I'm saying, just listen carefully. Listen carefully. 1, 2, 3, 4, 5. What I'm saying, kids, I will always keep on rotating this A. I will always keep on rotating with A, B, C and D. This A and B, C, D I will rotate over here. But let me fix one thing. Let me fix out one thing. What's that? Let me fix out here one thing. The central metal atom, just see. Central metal atom, just see. Central metal atom, just see, kids. Central metal atom, just see, kids. Everyone, just see. This is central metal atom, central metal atom, central metal atom, central metal atom, central metal atom. Now, what I'm saying, I will rotate these, whatever the 4 things I will rotate over here, A, B, C, D or whatever I will rotate. So let me remove what I'm going to rotate, that's different thing. Once let me fix one thing, that in front of E, I can keep F. Then A, B, C, D I will rotate, I will get 3 GI and their mirror images means 6 optically active isomers. Now I will keep E and in front of E I will put, already F is there, I will put D. D I can put. Now once again I will get 3 GI, 3 mirror images, so 6 optically active isomers. Now E is fixed. E is fixed everywhere. E is fixed so that you can understand. Now after D, what I can place? Over here I can place C, over here I can place B, over here I can place A. Rest of the 4 I will rotate. Once again 3 GI. I will get 3 GI, 6 optically active isomers, 3 GI, 6 optically active isomers, 3 GI, 6 optically active isomers. So total how many GI I have got? 3 plus 3 plus 3, 3 plus 3 plus 3 plus 3 plus 3, 3 5s are 15, 3 5s are 15 GI I have got, and 6 5s are 30 optically active isomers. Now you are able to understand, this is the visualization part. Have you ever seen such a great visualization? Kids, do let me know. Everyone, you got it? So show me green hearts along with fire in the chat section. This is all about coordination chemistry. Now Baba is going to start with D block, DNF block. I will start with DNF block if it is clear, kids. Wow, amazing, kids. Now Baba is going to start with DNF. Now I'm going to start with DNF. This is all about coordination chemistry. Each and everything I've touched, kids. Each and everything. Now see, I'm going to start with DNF. Now see, kids, DNF block. Ready, kids? Everyone ready for DNF? Yes, kids, DNF. Baba has completed, Baba has told you each and everything in coordination chemistry without skipping even a single thing, kids. Now those who are waiting for DNF, smash the like button, make it 500, kids. At least that much you can do, make it 500. Making 500 is easy. So DNF. So in DNF block, two things are very, very important. First thing is the oxidation state. First thing is oxidation state. So let me go through oxidation state. DNF block oxidation state. Just see, kids. And DNF block oxidation state. Oxidation state. First, I'm going to move with the oxidation state. That is very, very important thing. Oxidation state. This is very, very important. Without this we can't do anything. So first of all, try to understand the oxidation state. Now what they are trying to do, let me tell you, as I have explained earlier, just keep on eye on one point. They want to have configuration like helium, neon, argon, krypton, xenon, radon, augie. Remember that. No need to cram this chapter. Just focus to now. Their focus is mainly on arena 18. They want to have 18 electrons. So who is trying to have 18 electrons? Just see. Science teacher, very crazy man. Just remember, science teacher, very crazy man. I've told you, felt cold in night with cousin. Felt cold in night with cousin. Now see, kids, it is having 21 electrons. So how many electrons it can lose to become 18? Definitely it can lose 3 electrons. So it will become Sc3 plus. This can lose 3 as well as 4. This can lose 3, 4, 5. This can lose 3, 4, 5, 6. This can lose 3, 4, 5, 6, 7. This is maximum. This is maximum. It's maximum. It's maximum. It's maximum. Are you getting my point? Now, my dear students, up to here, 2 oxidation state is unstable. This is having only one type of oxidation state. Now, plus 2 oxidation state, stability starts from here. Manganese plus 2. Their plus 2 oxidation state are stable. Plus 2. Now, after losing these many electrons, they will say I'm to losing highly electrons. So due to their high Z effective, effective nuclear charge, high Z effective, they don't want to lose many electrons. So they are plus 2 and plus 3. This will show only one oxidation state, but zinc is not considered as transition element. Very soft, so not considered as transition element. Now see, kids, they can show coffee man plus 2 plus 3 plus 2 plus 3 plus 2 plus 3. Now, if I talk about manganese, plus 2 oxidation state is most common and plus 7 is most common. If I talk about chromium, then plus 3 is most common and plus 6. Now, question will come from here. Why it's plus 2 is more stable, why it's plus 3? Question will come from here. Those who want to visualize it, just to let me know in the chat section. I will make it visualization possible. Do let me know how many of you want that visualization of that why oxidation state of manganese plus 2 is stable, whereas chromium is having plus 3 oxidation state is stable. Those who really interested in this point. Now see kids, let me make it possible. Just see everyone. Question will be asked, why manganese 2 plus is more stable and why chromium plus 3 is more stable. That means why they are stable, or the question can be asked, why Mn3 plus, if you keep Mn3 plus, it will take one electron and it will convert Mn2 plus. Then how they will say it is good oxidizing agent or reducing? It is reduction. It is undergoing reduction. So why Mn3 plus is good oxidizing agent? They can ask like this. Now this is redox chemistry, good oxidizing agent. Now they can ask question like this also. See, they will write chromium plus 2 and it will try to become chromium plus 3. So it is oxidation. So they will say why this is good reducing agent. Are you getting my point? It's a physical chemistry only. It's a physical chemistry only. They can ask question like this, and this question already has been asked. Number of times they have asked this question in number of types of examination. If I talk about IIT, AIMS, whatever the type of examination, NEET examination, but we have to understand actually what they are talking about. We have to feel, we have to smell out what's the basic reason behind it. Everyone, I hope that everyone is interested to understand, to visualize. Why to ask? Just see. Just see. If I write down Mn plus 2, if I am writing Mn plus 2, but first of all, I would like to write Mn 25, and the trick I have told you 52, then you can see 3d5 and 4s2. And if I'm writing 3d5, 4s2, then I would like to say Mn2 plus. Mn plus 2 will be 2 electrons will go from the outermost orbit. Why I'm writing again and again like this? So that you can understand easily this is the outermost orbital, and if anyone is going to snatch the electron, what he or she should do? They have to snatch out electron from the outermost orbit only. Now Mn plus 2 will look like 3d5 only, 3d5. So it is half-filled stability. Are you getting my point? It's having half-filled stability, that's for sure, and I think that everyone can understand because of this half-filled stability, that they are having one electron, one electron, one electron, one electron, one. If you want to say that we are going to split it, in T2G and EG, then also you can understand their symmetry. This is T2G, 3 electrons, and there is EG, splitting is there, then also symmetry is there. Due to symmetry, you can use this word. So that is the stability is there. Everyone, you are able to understand. You are able to understand now why chromium plus 3 is more stable. Just try to find it out. Chromium atomic number is being 24. So an exceptional case, I would like to say 3d5, and that is being 4s1. Now if I'm talking about chromium 3 plus, how it would look like? 1 electron will go from here, 2 electrons from here, so it will look like 3d3. Now my dear student, you can understand half-filled stability of T2G. T2G is half filled. Now you will say, what is T2G? If you have not studied, my dear student, crystal field stabilization energy or crystal field theory, you won't be able to understand. If you really want to understand, then remember that T2G is being half filled stability. Are you getting my point? Half filled stability is 0. Done understood. Done understood, kids. Just to let me know in the chat section whether you got it or not. Priyanshu, oh my God. Kids, are you there or you have gone? Are you there or you have gone? Okay, Priyanshu, no problem. Are you there or you have gone? My dear friend, I think everyone was shouting for D block when you will start D block. Where are you, kids? Where are you? Welcome, Priyanshu, welcome. Number of questions. DNF, they are related with coordination chemistry, so number of questions. Now, kids, what we have understood, one thing we have understood that scandium is showing only +3 and zinc, cadmium, mercury, they shows +2. Zinc, Canada, Zinc, Canadian hugs, but they are not considered to be transition metals. They are very soft, so not considered metallites, not metallites, transition metals. So the one who shows only one oxidation state, this is the answer. Transition metal with only one type of oxidation state. Gets clear? Now, my dear students, one more thing we have got in our brain. Just let me tell you, if I talk about, just try to understand. Manganese, its lowest, or its manganese is 0. So manganese is 0, manganese is +1, manganese is +2, manganese is keeping donating electron +4, +5, +6, +7. So any element's maximum oxidation state will be equal to its group number. Manganese group is 7th. It belongs to 7th group. So its maximum highest oxidation state. In the highest oxidation state, it is unable to donate electrons, so it will act as strong oxidizing agent. Will undergo reduction. Are you able to understand? Will always undergo what? Reduction. What is the meaning of SOA? SOA is strong oxidizing agent. Strong oxidizing agent. Now, this can only lose electrons, so it is donor only. Reducing agent only, right? And manganese, these oxidation state, I will say, they can gain as well as lose, so can behave as both. Can behave as both. The oxidizing and reducing agent. Are you getting my point? Most common oxidation state, if I talk about manganese +2 and manganese +7. This point is clear to each and everyone. Do let me know in the chat section. Till now, is everything clear? Do let me know, kids. Sir, honestly, you are organic king. SR NEET, organic or inorganic? This is inorganic going on. SR NEET, Right now inorganic is going on. So Baba, is organic king or inorganic king? SR NEET. SR NEET, just to let me know. I want to clear it. Both. Okay, thank you. Thank you. Thank you. Thank you. Now see, if you are able to understand this thing, one thing is manganese, one thing is chromium. Just try to understand. Same thing I would like to say, tell you chromium. Chromium also I would like to say, just try to understand. Chromium lies in sixth group. Sixth group. So chromium plus 1, chromium plus 2, chromium plus 3, although we know that these two are highly unstable, so they are not found in this highly, but they can exist. Highly unstable. Yeah, this one is stable. Chromiums, this one is stable. So chromium 4 plus, chromium 5 plus, and the maximum is chromium plus 6. This is chromium's maximum oxidation state, right? Now, let me teach you about some basic fundamental things. Then I will teach you potassium dichromate and KMnO4 in detail, because number of times you are getting number of things about D block, but you're not getting these two things, dichromate and KMnO4. So today I will focus on dichromate and KMnO4. That is the most important thing. Are you getting my point? How many are agreed with me that no one is teaching on YouTube potassium dichromate and KMnO4? They are always saying it's a theoretical part, so either they will come with the slides or they will ignore it. All the properties number of people are showing, number of people are teaching, but potassium dichromate and KMnO4, these two things no one is going to teach. So Baba is going to teach. If you are agreed, I want to see green hearts along with fire. Green hearts along with fire, if you are agreed with what Baba is saying. To understand that, let me teach some common points, simple points. See, some very basic points, some very basic points. First of all, tell me, relation of equality is good or not? Relation or bonding of equality is good or not? Good means stable, and stable means its lattice energy will be more than hydration energy, and the thing will be less soluble in water, less soluble or not soluble in water. Am I right? Now, what is this relation or bonding? I can say smaller cation, this is lattice energy, that is hydration energy. First let me make it clear, otherwise kids won't be able to understand. Lattice energy, this is being hydration energy, right kids? Now, what is the meaning of equation relation? I would like to make it clear. Smaller cation, if somebody is, like say, if I say Pandu is short-heighted, then he must be in search of whom? He must be in search of smaller anion for marriage, the girl who is short-heighted, right? Are you getting my point? Like that, larger cation will be stable with larger anion. Am I right? Larger cation will be stable with larger anion. Am I right? Am I right? Making sense? Now see kids, how to find out? First of all, see kids, if I talk about this relation is stable or not. This is Pandu, short-heighted, and this is Alia. Now this relation, cation is this and anion is, this is cation and this is anion. What do you think? This relation is okay or poor relation? Poor relation. Then poor relation means lattice energy will be less than hydration energy. When you put inside the water, they will flow away. Soluble in water, highly soluble in water. First, do let me know this point is clear. Now, after this is smaller cation, larger anion. Now, the problem is how to find out who is being smaller and larger. This though you can physically see the who is smaller, who is larger. But when we talk about ions, how to find out? Let me tell you how to find out. About cations, you can easily find out the size. That if I say beryllium, magnesium, calcium, strontium, barium, radium, 2 plus, 2 plus, 2 plus, 2 plus, their size is increasing. Their size is increasing. Their size is increasing. Am I right? But once we talk about anions, then it becomes difficult. Anions, then it's not that easy. So remember that anions, smaller anions, fluoride, remember that fluoride, hydroxide, nitride, oxide, these are smaller anions, right? Now, multi-atomic anions and bromide iodide, they are larger anions. Just keep it in your brain. Larger one are, first is bromide iodide, and then is all multi-atomic anions, all multi-atomic, like carbonate, sulfate, chromate, dichromate. Got it? Everyone got it, etc. Till now it's clear. So that I can move ahead, I will tell you today how to remember each and everything, and today I will teach you, today I will let you know each and everything in detail. Kids, do let me know, is this clear? Is this clear to each and every one of you? Is this clear to each and every one of you kids? Okay, now see. Now Baba is going to deal with potassium dichromate preparation. K2Cr2O7 preparation. Okay. K2Cr2O7 preparation and chemical properties. Just move here. Now, kids, remember that if I take iron chromite ore, iron chromite ore, what is that? FeCr2O4, 1 to 4, 1 to 4, 4 to 1. My name is iron chromite ore, or you can write it like this. FeCr2O3, that is same. You check it out, they are same. Just check it out, they are same or not. They are same or not. Now, if you add oxygen and X's, before I move ahead, let me tell you one point. Very, very important point. Let me tell you one very, very important point, kids. There was one chromate. There was one, let us suppose, sodium chromate. Na2CrO4, and he was crying. Sodium chromate was crying. Why sodium chromate was crying? He was yellow in color. Yellow, yellow, dirty fellow. Everyone was saying, hey, sodium chromate, yellow, yellow, dirty fellow. So one day, somebody came, Hanumanji. Hanumanji came and said, hey, Butts, what's your problem? He said, sir, everyone says that I'm yellow colored. Hanumanji said, hey, you don't know who is responsible for your color? He said, no, not at all. He said, might be I am having unpaired electron. Hanumanji said, hey, just check it out, your oxidation state. Just check it out, your oxidation state is +6. And you see your atomic number like 24. You were like this, 3d5 and 4s1. You have lost all electrons. You are not having any unpaired electron. Your unpaired electron number is 0. Oh my God. So you can't show DD transition. So there is no DD transition. That electron cannot move from T2G to EG. That electron cannot move from T2G to EG. Then who is responsible for a color? Then Hanumanji said, your color is due to charge transfer spectra. Metal to ligand, charge transfer spectra. Ligand, metal, charge transfer spectra is responsible for your color. Remember that its color is due to charge transfer spectra, not due to DD transition. Now Hanumanji said, just start eating fruits. Whenever you have acidic medium, your color will change and your strength will also change. From chromate you will become dichromate, Na2Cr2O7, and you will become orange, from yellow to orange. And here also color charge transfer spectra, because chromium is in +6 oxidation state. But remember that if you have ever gone to basic medium, once again you will be like this. So remember that in acidic medium you will be orange, and in basic medium you will be like this. Can you remember this point? First of all, do let me know in the chat section. Can you remember this point, everyone? Do let me know. Will you be able to remember this point? Everyone, just do let me know. I will tell you how to study chemistry with Baba HSP. Baba is the one who will let you know how to study chemistry, kids. Wherever tough things are coming, Baba will make it simple. Idiyappam Murku things will become Romba, Sulbham, Arpudham, Medhuva, Medhuva. I will tell you each and everything. All the tough things. Chemistry Padikara customer. If you're thinking like that, I would like to say it's Romba, Sulbham. I will make it neat and clean so that you will get full marks. Very good, everyone. Kids, make it 500. Hit the like button, make it 500 right now if you're really liking it. Let's see. Thank you, Parama. Right now I can't give break. Now I will complete. Right now I can't give break. Make it 500, kids. Make it 500. Now see. Let me go to that slide. So iron chromide oxidation, and the medium is basic medium, Na2CO3. Now tell me, definitely iron, it is in +2 oxidation state. It will undergo oxidation to maximum, and chromium is in +3 oxidation state. It will go to 6 because they will undergo oxidation, because oxygen is snatcher of electron. Wherever oxygen is there, Oxygen is always trying to snatch electron. It will snatch all the electron. It will make iron. Iron will convert into ferric oxide, Fe2O3. One point is clear. Now chromium will change to +6 oxidation state, but my dear student, do let me know, +6 is chromate, +6 is dichromate. Both are having +6. Just see, this is +6, that is also +6. Here also chromium +6 oxidation state. There also chromium is in +6 oxidation state. Just do let me know which one you will get. Which one you will get, just to let me know. Both are chromium +3 to +6. What you will get, chromate or dichromate, just to let me know. Let me check it your brain. Let me check in the chat section. You will get chromate or dichromate, just to let me know. Kids, do let me know. You know you will get chromate or dichromate. I'm watching your chats. Chromate or dichromate, do let me know, kids. You are going to get chromate or dichromate. Do let me know, kids. Chromate or dichromate? Dichromate. No, kids. You see, this medium is what? Salt of strong base. This is salt of strong base and a weak acid. Have you studied ionic equilibrium? So this is making medium to be basic. And in basic medium, who is stable? I have told you in basic medium who is stable. See, basic medium, dichromate or this is chromate, that is dichromate. Who is stable? Chromate or dichromate? This is dichromate, sodium dichromate, and that is chromate. Do let me know. No one in this world can teach like this. Baba is teaching you. No one can teach without slides. The inorganic chemistry. Is there anyone who can teach without slides, without PPTs? Do let me know. Is there anyone who can teach this chemistry without PPTs, without slides? Do let me know, kids. Is there anyone? Every time whenever somebody is going to teach, they will use slides, PPT. Baba is not using. Baba is teaching like. So definitely this basic medium, chromate, you will get chromate. So sodium chromate, yellow solution. Why I am saying yellow solution? Why Baba is saying yellow solution? Remember that all salts of, let me write down, all salts of ammonium, sodium, potassium, rubidium are always soluble in water. Because kids, the major portion will come from the salt analysis, salt chemistry, qualitative analysis. That also no one is going to teach. Only Baba will teach. Now see, yellow solution. You got yellow solution, but you want to prepare what? You were supposed to prepare potassium dichromate. Now what you will do? See on the next page, the story on the next page. Na2CrO4, add H2SO4. Now acidic medium will do what? What this acidic medium will do? It will convert chromate to dichromate, Na to orange color, Na2CR2O7, orange color solution. Because sodium salt, dichromate, sodium dichromate. Am I right? Now kids, when I add KCl to it, it will change into orange color, K2Cr2O7 plus NaBr. Now ask me why, पूछो क्यों this reaction has happened. This reaction has happened, why? Ask me why. Just ask me why this reaction has happened. Thank you, Sahana. Thank you, Study with a Stranger. Everyone, पूछो क्यों? पूछो ना पूछो ये क्या हुआ है मुझे, हो मैं आँख ला 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 ला. Just ask me why this is happening. Now see, kids. Sodium and potassium, who is bigger? Out of sodium and potassium, who is bigger? Do let me know. Just chill, just to let me know. Sodium, na. Potassium, this is bigger, this is smaller, This is bigger, this is smaller, Na, smaller, big brother, big bro. Now smaller cation, larger anion, no babaro. Now larger cation, smaller anion. Now what happened? NaCl. This will be NaCl, sorry. Nacili, NaCl. Now smaller cation, smaller anion, larger cation, larger anion. Everyone is happy, happily married to you. Got it, kids? Got it? Got it? हम बने तुम बने एक दूजे के लिए. We all together forming stable bonds. I don't know what do you say. You got it? I don't know what do you say. You got it or not? Bond of equality is good. This is known as bond of equality is good. That's why I taught you bond of equality is good. La 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 la. Everyone got it? Now that's why number of questions will be framed on this. Just see what Baba is going to tell you. Just see to it. Just see to it. Just see to it. Now check kids, now check, now check. Now check kids. Audio is okay. Now audio is okay. Am I audible kids? I hope that you have not missed anything, or should I recap? Should I start the last 2 to 4 minutes? Just to let me know in the chat section. Okay. So let me repeat what I said. Okay. Oh, from 2 slides. Now let me tell you. I was telling you that it is going to absorb moisture from the atmosphere. Now suppose you made one normal solution and it has absorbed water, so number of moles will remain constant, volume of water will increase, so normality will change, normality will decrease. It's just like that. You made one house on river, on boat, and you have gone to your office, and now you are returning back to your house. You are saying that, oh, I will do this and that. Now once you are coming to that river, no house is there, because the house has gone 24, 25 to 36 kilometers away from that place, because it's not fixed. So once anything is not fixed, how you can reach up to that place? That's why it is never used as standard solution. Primary standard means with that solution we are going to find out normality of another one, so at least one normality should remain constant. Suppose if I say, if this normality I am going to find out its volume is 20 ml, its volume is used 25 ml, and its normality is also we don't know, then can we solve this equation? There are 2 variables, we cannot solve this equation. Are you getting my point? So can't be used as primary standard in volumetric analysis, can't be used as primary standard in volumetric analysis. This titration is volumetric analysis. Are you getting my point, or should I tell you once more what I'm talking about? The one whose normality is getting changed, the one who's going to absorb moisture from the atmosphere, what to say, what to do, we can never use that primary standard. Now say, if it is clear, I want to see green hearts. If it is not clear, then if it is clear, green hearts. Oh my God, thank you, Selvan. Now do let me know, kids. Rajaram MU is saying no, not able to understand. Okay, I will. Kids, first of all, hit the like button, those who got it. Smash the like button. If you have not, till now not, then smash the like button. Those who have not smashed it. Now kids, let me explain again. See kids. Suppose if I say that you took 1 liter water, and you added 1 mole of Na2Cr2O7, 1 mole inside the water, you got solution of sodium dichromate. What you will say? Molarity is number of moles dissolved per volume of solution in liters. Volume of solution in liters. So what is the molarity? Molarity is 1 upon 1. But another day, suppose this is Sunday or Monday. On Monday you made this solution. Now you came back on Tuesday. You came back on Tuesday that I will try to find out normality of another solution. You said you will find out normality of another solution another day. What happened? You were provided with unknown solution. You were provided with unknown solution 20 ml. Its molarity was missing. Its molarity was missing. This is oxidizing agent. So say a reducing agent. Suppose if I say ferrous sulfate solution, ferrous sulfate, right? Then you said I will apply N1V1, N2V2. You said N1V1 is equal to N2V2. So this is missing. This is missing. And this, you know, it's 20 ml volume, and you said it is 1, and if it has been consumed 20 ml, then definitely the value of this will be N2 will be 1. But this is wrong. Why this is wrong? This is wrong. Why this is wrong? Because Monday you made this, and once you have gone to home, it has absorbed water from the atmosphere. It has absorbed water from the atmosphere. And its normality, definitely moles are 1. But volume got increased. Suppose volume was 1 liter. Now 1 liter plus it has absorbed 100 ml. Suppose 100 ml it has absorbed more. I don't know how much volume it has absorbed. So the molarity will become what? Because this is unknown how much it has absorbed, so we cannot find out, but 1 upon volume will be more than 1 liter, 1 plus something. So this is unknown, so your reading will be wrong. Reading will come out wrong. You got it? Now do let me know you got it or not. Kids, do let me know now you got it or not. Everyone, just do let me know in the chat section. Is it clear? Crystal clear or not? Everyone got it or not? Kids, do let me know. Got it. Parma, you got it. Very good. Now let me tell you KMNO4, about KMNO4. But before moving towards KMNO4, let me give you a flow chart, mind map. How many of you want mind map? How many of you are interested in the mind map? Do let me know. How many of you are interested in the mind map? Now see, mind map. Just see. Iron chromator Fe1Cr2O4. 1 took a 4, 4 took a 1. My name is iron chromator. So if I add what? Excess of oxygen in presence of sodium carbonate, that is basic solution, what I will get? Fe2O3. But I will get yellow color solution of Na2CrO4, right? Yellow solution I will get or not? I will get. Then I am going to add acidic medium H2SO4 I have added. I will get orange colored sodium dichromate. I will get or not? Na2Cr2O7, orange solution. Now if I am adding more, even more acidic, highly acidic, remember that it is given in JD Lee, highly acidic, that is pH is equal to 1, then I will get CrO3, red color. Now all they are having +6 oxidation state. Remember that, +6. Now if I add basic medium, I will get this. Now my dear students, what if I do, if I add NaCl and H2SO4 to this, what I will get, you know? CrO2Cl2, chromyl chloride, reddish brown gas. Reddish brown gas. I will get, it is known as chromyl chloride. What? Chromyl chloride. I will get chromyl chloride. Now if you add to this, what? If you add to this NaOH, then you will get yellow color solution of Na2CrO4. Yellow solution you will get. Now if you add lead acetate to this, then you will get yellow PPT of PbCrO4. Now both, all these three together, if you are getting all these three together, what? 1, 2, 3. All three together are known as chromyl chloride test. Can you remember this? All three together are known as chromyl chloride test. Are you getting my point? This is the mind map. This is the mind map. Got it, kids? Do let me know. This is the mind map. I used to give this mind map for many, what to say? Yeah, you have to memorize this. Half an hour more, kids. Not more than that. You have to remember this. This holds a hell lot of weightage. Now, after this mind map, Baba will move towards another thing. What's that? KMNO4. So now let's move towards KMNO4, kids. Are you ready? Is everyone ready, kids? Are you enjoying it? Do let me know. KMNO4. Baba is moving towards KMNO4. Before teaching you KMNO4, let me write down KMNO4 here. I would like to say KMNO4. Baba used to say PPR. What do you mean by PPR? Do let me know what is the meaning of PPR. Pink, purple, red, and its name is also potassium permanganate. Its name is potassium, PPR, potassium permanganate. Okay. Now my dear students, I will tell you the table of 2. Do you know the table of 2? Everyone just say table of 2. 2 ones are 2, 2 twos are 4, 2 3s are 6. What is the meaning of this? 2 ones are 2, 2 twos are 4, 2 3s are 6. Do you know the table of 2 ones are 2, 2 twos are 4, 2 3s are 6? What is the meaning of this? Let me tell you. In acidic medium, it will change like this. From +7, it will change into +2. How much change? Change is the n factor. I would like to say 5 electrons it has gained. Am I right? So its equivalent weight will be gram molar mass, that is 158 divided by 5, that is equal to 31.6. Now neutral medium, in neutral medium, that is water or faintly alkaline. Faintly means very slightly. Faintly alkaline medium, it will convert into black color powder MnO2. Black color powder MnO2. MnO2 is black powder. Now how many electrons it has gained? Plus 7 to plus 4. 3 electrons it has gained. So N factor is 3. So equivalent mass will be 158 divided by 3 tipche 15 do 52.6667. So if I say, or simply if it is written alkaline or basic medium, we will do like this. Alkaline or basic medium, then we will do like this. Now if strongly alkaline is written, not only make it in your paper, just try to feed in your brain, then only the next step you are able to understand. Otherwise you won't be able to understand. Now only 1 electron, so N factor is 1. N factor is 1, so equivalent weight is 158 divided by 158 divided by 1 is 158, and this is green colored K2MnO4, green like parrot. Its name is potassium manganate. What is the name? Potassium manganate. Now if this chart is clear, do let me know first of all, then only you can understand anything, otherwise you can't, kids. If you are able to understand this, do let me know, then only you can understand anything, kids. First of all, do let me know, kids. If this is clear, then rest of the things you can understand, otherwise not. Do let me know, kids. Yeah, chemical properties of K2Cr24 and KMnO4 I will tell you together. Yes, I will tell you. Reactions I will tell you all together. But kids, you're not smashing the like button. Those who are new, please. Bacha, my bacha, make at least 520 the likes. Kids, what are you doing? Baba will start crying. Oh, Baba is crying for the likes. Okay, you've done it. Okay, no problem. So now kids, see, let me tell you the preparation of KMnO4. Are you ready for the preparation of KMnO4? Everyone, are you ready? KMnO4 preparation. Now see. Okay. First, what I have told you, what I have taught you, let me tell you that in detail, otherwise you won't be able to understand. Whatever I taught you, just let me try to fix it in your brain, then only you can understand. Tell me, repeat what I'm saying. KMnO4, once it has gone to which medium, then it will decolorize. The color will get decolorized. This is colorless. Which medium? Tell me, kids, in the chat section. Which medium? Which medium? Acidic medium. If it is moving towards acidic medium, it will get decolorized, right? Now KMnO4, how it will become black colored? Where it has to go to become black? At least colored. There it was colorless, but at least colored. Either it is moving in water or faintly, matlab weakly. Faintly means weakly basic. Faintly means weakly basic. Now if it is going to which thing, where it will become like plant, greeny, K2MnO4, where it has to go? Strongly alkaline. That means I would like to say this is stable only in strongly alkaline medium. If I add water to this, if I add water or acid to this, it will undergo change like this. Just try to see. It will convert like this from +6 +4. This is being reduction of chromium, and here it is +7. This is oxidation. Manganese is undergoing reduction. Manganese is undergoing oxidation simultaneously. What do you call this reaction? When same atom undergoes oxidation as well as reduction, what do you call it? Let me check it out in the chat section. What do you call it? Do let me know. What do you call it? I will teach you. F block is very simple, don't worry. Toiba, F block is very simple, don't worry. It's very simple. I will teach you, don't worry. It's very simple. Disproportionation redox. Very good. It's being disproportionation redox. Disproportionation. Now I can teach you the preparation of KMnO4. There is pyrolusite. Pyrolusite, MnO2 is pyrolusite. Along with this some impurities, pyrolusite. Now if I add O2 and Na2CO3, then it is in +4, then oxidation will take place. It is supposed to undergo Mn +7, but this basic medium says what? It is strongly basic. So in strongly basic, who is stable? Only K2MnO4. So once if I add water, because there I haven't shown, let me tell you, either water or acidic medium, so I add what? Some water or acidic medium, it will undergo disproportionation redox, right? So it will give you once again MnO2 plus it will give PPR color KMnO4. Got it, kids? So KMnO4 and potassium dichromate both are being strong oxidizing agents. So let's see their properties. Are you ready? Is everyone ready? K2Cr2O7 is in its maximum oxidation state, and KMnO4 is also in maximum oxidation state. They are in their highest oxidation state. So they are strong oxidizing agent. This is +6, its group number, +7. So they are being SOA. SOA means strong oxidizing agent. Am I right? In our language, if I say, if in my language, then they are looters. They are electron looters. What I say? I always say they are electron looters. They are electron snatchers. In my language, I would like to say Baba HSP's language. They are electron looters. Looters or snatchers. Can you understand looters or snatchers? Just like chain snatchers, they are electron snatchers. Now I will tell you so that you can understand. No need to cram. Nothing to cram, kids. Nothing to cram. Everything is dependent on understanding. With the help of physical chemistry redox, I will tell you each and everything. Everyone is able to understand. Everyone is ready to understand. Dinner break, bacha. Let me complete. I will take 30 to 40 minutes to teach you DNF. After that, you can do dinner. Okay. If I'm going to give you the break for dinner, kids, it will be too late then. Okay. Now, let me tell you, kids. Let me tell you. If I say that I'm provided with, somebody has seen what? Somebody has seen this sulfide H2S. Sulfur was saying, oh yay, I'm having 2 electrons, I'm enjoying these 2 electrons. What? K2Cr2O7 or KMnO4 they have seen. Okay, let me tell you one by one. First, K2Cr2O7, orange colored. It is being orange colored. It will snatch electron for this. Sulfur will get precipitated as yellow. And this will convert into green colored. Remember that chromium 3 plus is green. See. Cr2O3 is green colored. It will convert into green colored, right? It will undergo oxidation, that will undergo reduction. So this is acting as, it is undergoing oxidation, -2 to 0 oxidation. So it is being a reducing agent. This is being oxidizing agent, right? So same thing, number of things they will do. If you give ferrous, ferrous will convert into what? Ferric. If you get the same thing, stannous, stannous will convert into stannic. If you get potassium iodide or any iodide, that will get oxidized to iodine. Are you getting my point, kids? Everyone, are you getting my point? All they will undergo. If I say oxalate C2O4 2 negative on carbon is having +3 oxidation state, maximum is 4. So carbon dioxide. Now this is very much clear. All these reactions will be shown by KMnO4 also. The same reactions will be shown by KMnO4 also. KMnO4 will also do the same reactions. Are you getting my point? KMnO4. Just a second, kids. Just a second. KMnO4 will also do same, but one thing I would like to tell you, where is the difference? The difference is that with KMnO4, if I give you KMnO4 and I give you Ki, if KMnO4 you are using in acidic medium, KMnO4 in acidic medium, then you will get I2. Remember that. But if KMnO4 is used in faintly alkaline, KMnO4 in faintly alkaline medium, then you will get KiO3, potassium iodate. You will get iodate. And remember that sodium thiosulfate Na2S2O3. This question has been asked in advance in ITJ, AIMS, NEET number of times. If you are using KMnO4 in redox chapter, you will see faintly alkaline you will get sulfate SO4 2 negative. So this is all about K2Cr2O7 and potassium dichromate. Kids, do let me know you got it or not. Everyone, you are able to understand or not. Okay, Sana, no problem. Fantastic. Kids, do let me know everyone you got it or not. Now let me move towards lanthanoid and actinoids. Ready for lanthanoid and actinoid, kids? Is everyone ready for lanthanoid and actinoids? Okay. Before I move towards lanthanoid and actinoids, let me tell you some oxides nature over here. Oxides of D block. Remember that as the oxidation state increases, acidic character of oxide also increases. Acidic character also increases. So if I say MnO, then Mn2O3, then Mn2O7. So the acidic strength will increase in this order. If I say CrO, CrO3, Cr2O7, the acidic character will increase. This you should know. The acidic character will increase in this order. The acidic character will increase in this order. Lower oxidation states are basic. Lower oxidation are basic. Let me tell you. Lower oxidation states. Lower oxidation state. Metal oxides are basic. Right? Intermediate oxidation states are amphoteric. Higher oxidation state are acidic. This is the order you should know. Are you getting my point, kids? Now are you getting my point? Now, if you remember, oh my God, who is showing green hearts? Wow, kids, thank you, thank you, thank you. Now, let me tell you the exceptions, which are amphoteric oxides, okay? Let me tell you amphoteric oxides. If you understand amphoteric oxide, then you can do anything, okay? Let me show you amphoteric oxides. If you know amphoteric oxide, then you can find out anything, right, kids? Once you know amphoteric oxides, you can do anything, right, kids? amphoteric oxides. I was searching for the slide, but I haven't got that one, but let me write down. Aishwarya Auntie is antimony, and Care Minate Aishwarya Auntie and Care Minate. Aishwarya Auntie and Care Minate got irony victory. Aishwarya Auntie and Care Minate got irony victory. Their oxides are amphoteric. Remember that. Their oxides are amphoteric. Can you remember this? Just to let me know. Can you remember these? Aishwarya Auntie and Care Minate got irony victory. Their oxides are amphoteric. 3 plus 3 plus 3, there plus 4 plus 4, 3 and plus 5. Their oxides are amphoteric, means higher oxidation state will be acidic and lower will be basic. If you know this, their oxides are amphoteric. Got it? Now, jungle's best son is Prabhu. Jungle's best son is Prabhu. Aluminium is all there. Jungle's best son. There any oxidation state, any oxide of any oxidation state. Oxide of any oxidation state is amphoteric. If I talk about secrets, the first one, their particular oxidation state oxides are amphoteric, but there any oxidation state. Suppose if I say PbO is amphoteric, PbO2 is also amphoteric, but there only arsenic oxide As2O3 is amphoteric, but As2O5 will be acidic. Got it, kids? Do let me know. First of all, do let me know, everyone. Have you got it? Everyone, just to let me know, got it? Aishwarya Auntie and Care Minate got irony victory. That is the trick for this one. Aishwarya Auntie, let me write down. Aishwarya Auntie and Care Minate. Aishwarya Auntie and Care Minate got irony victory. Let me write down the trick. Aishwarya Auntie means antimony. Auntie and Care Minate got irony victory. Got irony victory. Got it? Everyone, is it clear? Now let me move towards lanthanoid and actinoid. This each and everything I have told you. Each and everything. One more thing I would like to tell you. The chromium, molybdenum, tungsten, they are having highest melting point. This tungsten is looking like this, W, maximum melting point. This tungsten is having maximum melting point. Remember this point. See, is it clear, kids? Now let me move towards what I was telling you, lanthanoid and actinoids. Everyone is ready for the lanthanoid and actinoids? Whatever can be asked in the examination for lanthanoid and actinoid, Baba is going to tell you, kids. Are you ready for that? First thing is that they can ask that their exceptional electronic configuration. Exceptional electronic configuration for, then first of all we should understand where they are lying, kids. Just see where they are actually located. What is the actual location of lanthanoid and actinoid? Just see, kids. If I talk about the periodic table, it's like this: hydrogen, lithium, sodium, potassium, rubidium, cesium, and it's being francium. First period, second period, third period, fourth period, fifth period, sixth period, and seventh period. Now, if I talk about beryllium, magnesium, calcium, strontium, barium, radium. Okay. Now, if I talk about kits, where they are located, where they are being located, so I will say lanthanum, hafnium. Now, I would like to say there is cerium to lutetium. What I am going to tell you, just try to understand. Just try to understand. Just try to understand. If I write down scandium, titanium, scandium, ytterbium, lanthanum, actinium, titanium, zirconium, hafnium, rutherfordium. So this is 21, this is 22. Now what are these elements? This I would like to say: first A, alkali metals; second A, alkaline earth metals; these are third B, and these are fourth B. Then what these elements are there? So actually this is 58 to 71, 14 elements of lanthanoids, and these are 14 elements of it's 89, 90 to 103 actinoids. Now, first thing is that how to find out their atomic number, and then how to write down the electronic configuration. Are you ready or you got tired? First of all, do let me know. Everyone ready or you got tired? Thank you, Jyoti. Thank you. Thank you. You are the one who can understand really what Baba is telling you. Jyoti, very good student, as well as you can understand. Very good. Now, just 15 minutes more, I will complete it. I will tell you how to write down their electronic configuration, how to find out atomic number, then how to. Just 15 minutes more. No, I never get tired. Baba never get tired. Kids, hit the like button if you are really liking Baba's Josh. If everyone really liking Baba's Josh, then hit the like button, smash the like button, kids. 15 minutes more. Let me tell you how to find out their atomic number and how to find out exceptional configuration. Now see, kids, how to write down their atomic number. How I have done this, let me tell you. Everyone just say Sunday morning. Everyone just say Sunday morning 2 times sip sip. Anything you can sip, sip, sip. Everyone say Sunday morning sip sip. Then simple DP, simple DP. Then safe DP, safe DP, safe DP, safe DP. Can you say like this? The 7 days what we are supposed to do this thing: 1, 2, 3, 4, 5, 6, 7. This will change your world. Sunday morning sip sip. Everyone just say Sunday morning, sip, sip. Sunday morning, sip, sip. Then simple DP, simple DP, simple DP 2 times, simple DP, then 2 times, safe DP, safe DP. Can you do like this? Can you repeat along with me? Sunday morning, sip, sip, simple DP, safe DP, safe DP. No. We know that S subshell can contain how many electrons? Maximum of how many electrons? S can contain how many? Maximum of 2 electrons. So 2 and 6, so 8. 2 and 6, so 8. 2, 10, 6, so 6, 18. 2, 10, 6, so 18. 2, 14, 10, 6, so 32, like Paristomilthetes, Bryophyta. 2, 14, 6, so 2, 14, 10, then 6, 32. These are known as magic numbers. These are known as magic numbers. Why they are known as magic numbers? Now, with the help of these magic numbers, you can find out any atomic number. Just see. If I say helium, neon, argon, krypton, xenon, radon, Augie, just see. This is 2. 2, if you add 8, how much it will become? 10. To 10, if you add 8, how much it will become? 18. To 18, if you add 18, how much it will become? 36. To 36, if you add 18, 54. To 54, if you add 32, 86. To 86, if you add 32, 118. Really, they are magic numbers. If you are really liking it, just to let me know. If you are really liking it, if you are able to understand, kids, if you are really loving Baba's inorganic chemistry, for 11 hours, the one who has not used even a single slide. Have you ever seen? Baba is appreciating himself. You also say to yourself every day that you are an important person. Once you say that you are an important person, you will behave like an important person, and the day will come that you will become an important person. All the obstacles in your path will disappear, and the means to its achievement will appear in front of you. That is the thing. No one is born with silver spoon in one's mouth. It's you. Just stop procrastination. The day will come. Each and everything will become easy peasy lemon squeezy. For 11 hours, if somebody is teaching you inorganic chemistry, others will say, oh, inorganic chemistry requires what? Slides, this and that. Baba has not used even a single slide. Baba can teach anything. You have seen Baba. Thank you. Kids, hit the like button if you're really liking what Baba is saying. Yeah, and you have to write it down. Once this video is getting over, kids, once my class, just in 10 to 15 minutes, whenever it is going to get over, after the online class, I want to see the comments. I would like to see the comments. Yeah. Now, once you are able to understand these atomic numbers, now these atomic numbers will help you to find out lanthanoid and actinoid atomic numbers also. See, I have written hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. But before that, let's see what I was talking about: helium, neon, argon, krypton, xenon, radon, Augie. So what I said, even if I don't know how to write down their configurations, so first though I know now see, I know that which period they are belonging. It belongs to first period, so 1s2. Now Sunday morning, if I write sip, sip, simple DP, safe DP and safe DP. Just try to find out safe DP, safe DP. Now I know one thing, how two electrons are filled, ns2 np6, but n minus 1 d is filled, n minus 2 f is filled, right? Am I right? So if I say that here 1s2 2s2 2p6 3s2 3p6, but here if I write down 4s2 then 3d6 and 4p6, if I write down 5s2 then I will write 4d10 then 4p6. Now here if I write down 6s2 then which f? 4f I will write down 14, and 5d10 I will write down, and 6p6 I will write down. Here 7s if I am writing 2, then I will write down f, 5f14 and 6d10 and 7p6. Are you getting my point? Once again, you are getting this thing. If you are able to understand this thing, then I will tell you how to find out configuration of lanthanoid and actinoid. Thank you, Nagan Janelu, Nagan Jelu. Thank you. You are able to understand what I have written, kids. So speedily I have written. You are able to understand or not, kids? Do let me know. You are able to understand or not? Everyone just do let me know. You are able to understand or not? God of whole chemistry. Wow. Thank you, Sumathi. Understood. Now, this is going to help you a lot. So see, if I say that I am interested in lanthanoid contraction and lanthanoid was placed over here, it was placed over here, 58 to 71. So this is in 1, 2, 3, 4, 5, 6. 6 will come after 5th. So 1, 2, 3, 4, 5, 6, 7, 54. It is 54. After 5th, 6th will come 54, 55, 56, 57. So see 58 to 71. Now it's clear. Now how to write down its configuration up to here? What I will get up to here? This I got 5s2 4d10. Now definitely who is going to start? This is holding for 54. This is holding for 54. Now for 55, what should I write? This will come 6s2. 6s2 will be there. 6s2 will be there filled up to here. 6s2 is fixed. 6 period 6s2 is fixed. Now which d will come? 6s2. So 4d1 will come. 4d1 will come or not? 4d1. No, 4f will come. 6s2 if I am writing, so 4f will get filled and 5d will be there. It's like this or not from cerium to lutetium. Now see, it's 54 and then I will see cerium to lutetium. Now see, cerium to lutetium, you have to learn it. Now see kids, 58 to 71. Now this God is one. This will be asked. Its electronic configuration, gadolinium. It is exceptional. How many are exceptions? Good cellulose. Good cellulose. Cellulose. Where is lose? Cellulose. Where is lose? Good cellulose. Good cellulose. Lows. What is lows? Where is lows? Good cellulose. Where is anywhere lows? Good cellulose. Cellulose. Where is lows? I can't find out. Gadolinium is there. Cerium in class 11th and class 12th, it's given different. So they cannot ask. This is given. Lutetium is not belonging to it, so no need to write. Only gadolinium is important. Gadolinium is important. Now how to write down the electronic configuration of GD? Just see. Now how to remember it? So how to remember it? See, Prime Minister and PM are same. What is the trick for this? See, Prime Minister and PM are same. See, Prime Minister and PM are same. See, Prime Minister and PM are same. So you can learn it from chemical periodic table. There I have told you the trick. You can learn it from there, okay? Otherwise time will get wasted. So you can learn this trick from my periodic table. Now, gadolinium is 64. Gadolinium is 64. God is 1. So remember, God is 1. So God is 1. God is 1. So D1. God is 1. So it is having D1 configuration. D1. Remember that. Rest of others are having 0. Rest are having D0. Rest D0, but it is having D1. One thing is clear, that gadolinium you got. Gadolinium's atomic number you got 64. Now 54 is standing for what? 54 is standing for this one. 54 is standing for Xenu. Xenu is 54. So 54 is standing for Xenu. So you can write down Xenu to 54. After that, how much you are supposed to add? 64, 54 to 64. So 64 minus 54, only 10 electrons you are supposed to add. So one thing is clear, that 6D is 1. 6D is 1. 4s2 is clear. 4s2 is clear, and 6D is 1. So 3 electrons you got. 3 electron already you got. So 4f. So 6D, yeah. So 4f will be how much? 4f is left. What you are writing, sir? You are not able to write properly. Sec at 6s2, 4f I don't know, and 5d is 1. Now see, 54, 55 to 57. How much is left? 64 minus 57. How much is left? 7. So it will have 7 electrons. Half filled stability. So half filled, due to half filled stability, it's like this. This is also cleared. Got it, kids? Now only one more minute. I will take only one more minute to tell you all the chemical properties. I think this is clear to each and everyone. Only one more minute. Lutetium. Yes, lutetium. Sorry, kids. Lutetium. Celu. I was thinking about Celu. Good cellulose. Good Lutetium is there. Yeah, this is lutetium. Yes, lutetium. So it is fully filled stability, because of fully filled stability, right? Fully filled stability, right? So gadolinium is asked. Number of times they have asked about gadolinium only. You got it? Gadolinium. Got it? Everyone, is it clear? Now P block, ma'am will teach you. P block I'm not going to cover. Biomolecules, P block, and rest of the things ma'am will cover. I was supposed to teach 2 chapters. Coordination, I have told you in the starting, coordination and lanthanoid and actinoid. Now see chemical reactions. Lanthanoid and actinoids plus 3 oxidation state is more stable. Lanthanoid and actinoids. Lanthanoids and actinoids plus 3 oxidation state is more stable. right kids? Now it is just like do all the reactions, write down all the reactions like aluminium. So write down all the reactions like Al3 plus, what I'm saying, just like if I say aluminium is combining with oxygen, it will form Al2O3. So if I say any lanthanum is combining with oxygen, any lanthanum, so it will form La2O3, just like this. Simple, simple, it's very simple, it's done and dusted. So I promised that I will tell you each and everything, and I covered up. That will depend when I will take organic, but this chapter is completed. Thank you kids, really thanks. Just to let me know what else I can do. Now let me tell you all the reactions, what they can ask. See, lanthanum oxide I have told you, lanthanum this I have told you. One thing is that lanthanoid contraction. Lanthanoid contraction will affect what? Just see. Now see kids, now this will cause lanthanoid contraction. Just try to understand. Right now you can see this size is increasing, this size is increasing. If I say this is 3D, this is 4D, this is 5D elements. So this is 1, 2, third group, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th group. So size is increasing. Here size is increasing. Size is increasing. Size, this is maximum in size. But if I talk about here, titanium to zirconium size is increasing, but they are approximately of same size because of lanthanoid contraction. They are of same size. They are of approximately of same size, same size, same size, same size, same size, same size. What is the reason for their same size? Why they are having same size? So examiner will ask you, what's the reason for their size, same size? Yes, what you will write? The answer will be lanthanoid contraction. Lanthanoid contraction. And the same thing here, the reason is being lanthanoid contraction kids. Here the reason is being lanthanoid contraction, my dear students. And if I talk about D in D block, the size, if I talk about size in D block, just let me draw that size in D block. Just see everyone, let me make you one memory add, because kids, you are very good students. So if I say here the atomic number is increasing, and here if I write down the size, now size will be like this. Let me make a boat. This is my boat. This is, what type of boat it is? Just see, this is a boat. This is a boat. Just see, this is a boat. What I am writing, try to understand. Just see, first size is decreasing, then it's almost constant, and then increased. This is a boat. You can see this is the boat. Just remember. Now, what's the reason? How many of you, this is the last, how many of you want to know the reason, kids? How many? Just do let me know how many. Yeah, just 5 minutes more. How many of you want to know the reason? Yes, do let me know how many of you want to know the reason behind it. Do let me know, kids. Thank you, Abhinya. Thank you. I want to see these comments after, once the video is over. Then I will remember, I will give you a reply also. I want to see these comments once the video is over, right? Now see, up to here, see, single electron is filled in DC. Its atomic number is 21, 22, 23, 24, 25. So they are having single electrons. So I will say, write down 1, 2, write down 2, 2, write down 3, 2, write down 4. This is the exceptional case. Write down 5, 2. So I will say here the electrons are D1, 3D1, 3D2, 3D3, 3D5 and 3D5. No electronic repulsion is there because D is having single electrons. Can you understand, kids? No electronic repulsion is there, just Z effective is increasing. You know, effective nuclear charge is increasing. So the size decrease in this lot, A lot, size decrease in this lot. If I say this is A lot, size decreases due to what? Size is decreasing due to effective nuclear charge is increasing. One point thing is clear, size is decreasing, effective nuclear charge is increasing. So who's controlling up to here? Effective nuclear charge. Here see 3D6, 3D7, electronic repulsion is there, 3D8. If I draw 3D6, 3D7, 3D8, just see. Just try to understand. 1, 2, 3, 4, 5. The repulsion started. You see repulsion. So effective nuclear charge is increasing, and electronic effective nuclear charge is increasing. That will say size should get decrease. Size should decrease, and electronic repulsion is increasing. Electronic repulsion increasing. That is saying size should increase. So they are cancelling out. Effective nuclear charge is increasing, that is saying size should decrease. Electronic repulsion is increasing, electronic repulsion is increasing, that is saying size should. So they have counterbalanced, so almost same. But you see here the increase in electronic repulsion is dominating. Here electronic repulsion, because maximum number of electrons, electronic repulsion is dominating on effective nuclear charge, and that's why size is increasing. These are the three factors. Factor number A, factor number B, and factor number C. Can you understand, kids? Can you understand? This is given in D block. Just try to understand, kids. Kids, do let me know. Everyone got it or not? Just do let me know, kids. Everyone just do let me know. You got it or not? And thank you, kids. Still 50 to 60 to 70 students are wearing. Almost 11 hours have gone, but still 70 students, 50 to 70 students range is there. Really, I would like to say thanks from the internal core of my heart for really believing this much on Baba, kids. Really, I have become your fan, your dedication fan, that for complete 11 hours you can study. That's really awesome, kids, really. It means a lot, your hard work. Definitely, I will pray to Almighty God that God bless all these students with happiness, prosperity, and along with the best rank in the coming examination. It's really required because these students are really very, very awesome students. And kids, whenever you are putting comment, you have to mention that Baba has not used even a single slide, even in inorganic chemistry. I was teaching you the whole ordination chemistry. I have gone through the whole DNF, but not a single slide, written material slide I have used. And I have given you so awesome visualization. These are the 2 points along with the tricks. These 3 points, you have to comment on these 3 points how much you liked. If you have not liked, you can directly write down that you have not liked. But if you really liked, I would like to see 3 points. First point, slide I have not used, even for inorganic chemistry. Second point, the visualization part. And third point, the trick point. Will you do that once the video is over? Do let me know in the chat section. Will you do that, kids? Let me see. My God. Rashagnya, Gautami, Avinya, Darshana, Mao, Param, Bhala, Surya, Rohit, Vidya, Real Winter, Avinya, thank you, really thanks. Rohit is saying yes. Toiba, thank you. Toiba is saying yes, of course. Wow, why not? Wow, thank you. Amita, Rashagnya, Kanchi, Avinya, Jani, Sujwana. So I will give you written reply, kids, after this. Once the lecture is over, I will see your comments. I will be waiting for your comments. Kids, let me tell you, I will keep on waiting for your comments. Just after, once the video is over, will you give comments? Kids, do let me know. Just after the session is over, will you give comments? I will wait for your comments. Then only I will sleep. Then only I will do my dinner. After seeing your comments, then only I will do today's dinner and I will reply. I will give you reply, kids. So should I wait for your comments? Thank you, Lucky. Should I wait, Dar Arfat, Toiba? Should I wait for your comments? Do let me know, kids. Should I wait for your comments? Oh my God, Rashagnya Kanchi is saying same. Oh, great. Oh my God. That's really awesome. Wow, it's really awesome. Great compliment. It's really great compliment, kids. Thank you, kids. Thanks a lot. Baba is an angel. Pula Surya, thank you. Macro Love Shake, really thanks. Kids, really thanks. Baba is always available. Yeah, this series is more than enough. This series will give you the rank. This series will give you the rank, kids, rank. And which chapter you want from Baba, next chapter, you have to write down in the comment section once the video is over. Dawar Arfut, thank you so much, sir, for this amazing lecture and also for your efforts. Love from Kashmir. Oh, that's really great, Dawar Arfut. Lucky, no, sir, please take care of health. Definitely, Lucky, sure. Loin is always Loin Parama. Thank you, thank you, thank you, kids. So, bye bye to all of you, my dear students. Rashagnya, okay, demand on comment section. I will teach. Once people will see your comments, the management will say yes, do this and that. So everyone, what you want from now, but good comments I would like to see, right? For inorganic chemistry also, right? Bye bye, good night. Shubhratri, Shabba Khair. Okay, kids, bye bye to all of you. Shubhratri, Shabba Khair, Sayonara, all the best. Take sleep, sound sleep, and take care of health. Baba will also take care of his health, kids. दुआओं में याद रखना. Yes, we'll definitely meet you in the next session. Bye to each and every one of you, kids. Bye bye. Bye bye.